What is going on, everybody? My name is Bucky Roberts and welcome to your very first C++ tutorial. Now, my guess is that if you're watching this video, you probably already have a basic understanding of what C++ is. But for those of you guys who don't, C++ is a computer programming language. It's how you make computer programs, computer games. So if you're interested in making any of those, then congratulations, you're in the right spot. So before we just start opening any program and trying to write C++ code, I want to let you guys know that you need to download and install a few programs first. Now, good news, all these programs are entirely free. But before we just go ahead and start installing them, let me tell you guys what they are and what they do. The first program that you're going to need is called an IDE. This is pretty much the program that allows us to write the code and run it. Aside from that, we need something called a compiler. Now, a compiler is basically the thing that translates the code that something that computer programs can understand to something computers can understand. So, we're going to be typing code and it's going to be easy for us to read and understand what's going on, but in order to translate it to a bunch of ones and zeros that the computer can understand, we need that compiler. So with that being said, a lot of people download these separately. They download an IDE and then they download a compiler. But what I'm going to be doing is I'm going to be showing you guys a program that is going to allow you to download it and install it all in one big shebang. So let's go ahead and open Google, and like I said, don't worry about paying for anything because this program is entirely free. So anyways, like I said, go ahead and open Google and type in code blocks and go ahead and press enter. Now the first link that's going to pop up is probably going to be for codeblocks.org. So go ahead and click that, and this is the program that we're going to be downloading. So of course we need to find the download link. You can either click on this one on the left or this one on top, it doesn't matter. Go ahead and click on one of those and we see a couple options here. Download the binary release, download the source code, or retrieve source code from SVN. We're going to want to download the binary release. It's the easiest and most simple way to download this program, CodeBlocks. So go ahead and click download binary release and check it out. It gives us all these options. Now, depending on what platform you're running, most of you guys will probably be running Windows. You're going to want to choose one of these options. But for those of you running Linux, and they also have a Mac version down here, you might want to choose these. But for most of us, we're going to be running this on a Windows machine. So you're saying, alright, now we have it narrowed down to two choices, CodeBlocks 10.05 setup or CodeBlocks 10.05 MINGW setup. What we want to do is we want to download this second one, the one that says MINGW. Now this version 10.05 may be different depending on when you're watching this tutorial and if they updated CodeBlocks, but make sure you get the one that says MINGW. The first one is the IDE, the second one, MINGW, that MINGW means the compiler too. So when we download this, it's going to give us the IDE, and remember that's where we write the code, and the compiler as well. And remember, the compiler is the program we need so the computer can understand what we're doing. So go ahead and you can either download it from Barely OS or SourceForge. I already have it downloaded, so I'm not going to click this, but oh, excuse me, I got some phlegm in my throat. I just drank a Frutista Freeze from Taco Bell, and I ate a taco, and that is not a good idea because they should call these things brain freezes, brain freezies, because that's all it does to you. Just freezes your brain in your throat, and and it puts a bunch of phlegm in your throat, but I can't stop drinking it. It's addicting. So anyways, go ahead and click this link from sourceforge.net and go ahead and save the file. And whenever you save it and open it, a wizard's gonna pop up and you just have to click next like 80 different times and then you have CodeBlocks installed. So I already installed it, so I'm not gonna walk you guys through how to do that because it's really simple and I'm not gonna act like you guys are dumb and you don't know how to install things on your computer. So anyways, once you have it installed, you have this program called CodeBlocks right here. Now you probably have it on your all programs. You might have it under CodeBlocks. What I like to do is right click it and just send it to desktop. And what that's going to do is it's going to give you a nice little icon on your desktop. But anyways, Once you have it installed, just go ahead and double click it, and we're going to run a really simple program just to make sure it's working correctly. So go ahead, it gives you these tips, close them out. What we're going to want to do is create a new project, and you can either do that by creating this new project right here, but what I like to do is I like to go up to the file menu and click new project. Now it's going to give you a list of a bunch of different projects you're going to want to create. What we're going to want to choose is console application. This is what you're going to be choosing most of the time. This pretty much means a basic program for the computer. So just go ahead and select this and press go, and make sure you're working in C++. C is a totally different language. We don't want that. So C++, go ahead and click next, and now name your project anything you want. I'm going to name mine YouTube, why not? And you can save it wherever you want. I might as well just save mine right on desktop. It looks good. But it really doesn't matter where you save it or even what you name your project. Just name it something that's easy to remember. So go ahead and give your project title. Go ahead and click next. And make sure you're using the GNU GCC compiler. Basically everything should be set up by default. Make sure your settings look the same as mine. As long as you didn't hit anything by accident, you should be good to go. So go ahead and click finish, and you see that nothing pops up by default. And you're saying, alright, I thought we just created something, so how do we see what we just created? Actually, if you click this little plus sign next to sources, it shows you that all the files it created for you automatically. So go ahead and double click this main CPP, and it shows you, or in other words, it brings up the file that it created automatically. So this is actually the core basics of a very simple C++ program. We don't understand what anything means right now, but trust me, it's a very simple computer program that the only thing it does is it prints out hello world on the screen. So to make sure that everything is set up and running smoothly, let's go ahead and we need to do something called build and run this. Now I'm going to be talking about this later, but for now I just want to make sure that your computer is set up, you installed it and downloaded it properly. So go ahead and click this build and run icon right here. It's with the little gear and the little green triangle. So go ahead and click that, and it should, maybe flash a couple boxes. But basically, a box should pop up that says Hello World. And this is all that that program is. Basically, it prints out Hello World on your screen. So if you build and run this and you get Hello World, it means that you downloaded it, installed it, and set up your project successfully. So we are good to go. So again, I know you guys don't know what any of this means or even know how to code one line of code yet, but I'm going to be going over that in the future tutorials. But for now, that's all I have for you guys. So thank you very much for watching. Don't forget to subscribe, and I'll see you next tutorial. What is going on, guys? It's Bucky, and welcome to your second C++ tutorial. And in this tutorial, what I'm going to be doing is I'm going to be breaking apart this computer program that we ran in the last tutorial. So if you remember, whenever we first created a project in CodeBlocks, CodeBlocks already made a very simple computer program for us to run and test out just to make sure everything was working. And all it did was it printed out Hello World on the screen. So if you go ahead and build and run this, we see that it just says Hello World and some other computer stuff that isn't really relevant. But anyways, all this computer program does is print out Hello World. And before I get into breaking this apart and telling you what each piece does, I want to say one thing. You would think, since computer programs are just made up of a bunch of lines of text, that we can learn each line one at a time. But computer programs are weird in that this is pretty much the most simple program you can write. And check it out. There are already 7 different lines included here. So in order to even write a most basic program, you need to code at least 7 lines of code. So it seems kind of confusing, and I just want to give you guys a warning. As long as you can get through this video, all the rest of the videos are going to be incredibly easy. This is the only one where I have to throw a bunch of information at you, but still I'm going to break it down as easy as possible. And the reason for that is because you need so many things in order to run such a simple program, but once you understand the basics, everything else is just smooth sailing, I promise. So let me go ahead, and we're going to be getting more in depth in each of these lines, but for now, let me just give you guys a brief introduction to what each line does. Let's go ahead and start at the top and work our way down. This include IOStream line right here, This is technically called a preprocessor directive. So if you're taking a test, if you're watching these tutorials because, maybe you're in C++ class and your teacher's kind of confusing you, answer on the test, this is a preprocessor directive. Now, what that means in everyday terms is it pretty much says, all right, we're going to be including a file in this program that we're going to be using later on. So it's going to be including a file, IO stream, that we didn't make. We didn't make this file, but it needs it to run this program later on. So that's why it needed to include it. Again, we're going to be talking more about header files later on, but for the basics of this tutorial, all you need is to know that this line includes a file that our program needs to use later on. Now, the next line you can see is just a blank line. And you may say, alright, do you need this blank line? Do you not need it? Blank lines and spaces, you can have a million of them if you want, or you can have none of them, just like that. All blank lines do in programming is they make the program easier to read. Just with a book or a magazine or a newspaper, sometimes you want blank lines between your code. Sometimes you just want your code right under each other. It's personal preference. People, whatever you want. Blank lines just make it easier to read, so whatever is easier for you, add as many lines or as less lines as you want. And that brings me to another point. These tabs, too, see this is kind of tabbed out or tabbed in. It's the same thing. Some people tab things in, make it easier to read. This program is just going to run just fine if it's just like that. But, people just like to line certain things up. So you'll see later on once we get coding that tabs and spaces and blank lines, they don't really mean anything significant. They just make the program easier to read. So that being said, under that blank line is this using namespace STD. And believe it or not, this does not stand for sexually transmitted disease. I like to think that, but trust me, it doesn't. It stands for the standard library. And that's another thing that is built in to C++ that is pretty much saying this. We're going to be using all the standard things with C++, nothing fancy. Again, we're going to be going over libraries and stuff in the future, but basically these two lines include things that we're going to need later on. This includes a file, and this includes something called a library, which, is just a bunch of C++ stuff. So with that being said, we know that these two lines include things. Fair enough. So now let's get to the meat and I don't know, meat and potatoes, I guess, of the computer programming, and that's this. This entire thing is called a function. Now, all computer programs are made up of functions, and all functions are things you want the computer to do. For example, whenever we're making programs later on, we're going to make a function to play sounds, and we're going to make a function to draw graphics on the screen. And as you can see, functions are just things that you want the computer to do. So every computer program starts with a function called main. This is how your computer knows where to start. So for example, in a couple tutorials we're going to have a function called main, and like I said, we're going to have another function called play a sound, and we're going to have another function called make a ball bounce around on the screen. And you're going to have all these functions, and your computer's going to say, alright, you gave me all this stuff to do, but how do I know what order to do them in? Well, your computer automatically knows anytime it runs a program to start with the main function. So that's why it's so crucial to name this function main. So in order to make a function, you do this. You first write what type of data you're going to be working with. And what functions typically do is they do some sort of calculations. For example, find the body mass index or calculate the velocity of something. Well, whenever it makes this calculation, it usually wants a number back, an answer in other words. Well, since we're going to be working with just integers, main always works with integers, so that's why we need that. But again, we'll be getting into that later on. After that is the name of the function, and this one is named main. Don't worry about these parentheses right now, but what we do need to worry about is these little, they're not semicolons, squiggly brackets, I guess they're called, curly braces, I don't know, whatever the heck they are. And this has an opening and a closing curly brace, and in between them you have something called statements. Now all functions are made up of statements, and all statements are basically instructions, and each instruction needs to end with a semicolon. That's why you see every line inside a function ends with a semicolon. For example, if you had a function that says make a peanut butter and jelly sandwich, one statement would be get out the bread. The next statement would be put butter on a piece of bread. The next statement would be put jelly on a piece of bread. The next, put them together. The last, put them in your mouth. Bam. You now have a function and a series of statements. Well, all this function did, the main one said, print out something on the screen and return 0. Simple enough. So now you can see the basics of a function, how they're made, and how every function needs to include statements or instructions. So that being said, let's break this down even more. The first statement is saying this. First of all, the C out thing right here, that's called an output stream object. And it's basically used to write characters on the computer screen. That's how we are able to type hello world on the computer screen. So this is always used in conjunction with this. This is called the stream insertion operator. This pretty much takes all the stuff to the right of it and prints it out on the screen. I mean, this is just, it's weird symbols, but that's whoever made C++, they decided to use these weird symbols to print out something on the screen. Why they did, I don't know. You have to take it up with them. But anyways, this is basically how you print out stuff in the screen. So this prints out hello world, and then this pretty much just means end line or go to the next line. So this line right here is pretty much just saying print something out on the screen. Now this last thing I want to talk to you guys about is called the return statement. Now usually, like I said, functions will calculate something like body mass index or velocity, and when they calculate it, it's going to want an answer back. So if I had a function that calculated my weight, it would return 155 or 160 depending on if I ate tacos or not today. Well, the main function should always have return 0, and return 0 means whenever you return 0, it tells your program that it ran fine without any errors. For example, if you had a bunch of extra text right here, your computer program would give you an error and it would never get to this line right here, so it would never return 0. So whenever it does get to this line, it means everything above it ran fine, and return 0 means you are good to go, main ran fine. So I know that was a lot of information to give to you guys for just your first tutorial. But again, like I said, every computer program starts with a bunch of stuff that you need to know, and we're going to be covering each more of these topics in depth, but for now I just want to give you guys a basic understanding of how a computer program is made. So if you don't understand everything completely, then don't worry, you're not alone. You will in the future, I promise. But for now, thank you for sticking with me, and thank you for watching this tutorial, and I can't wait to see you in the next tutorial. And if you have any questions, don't forget to check out my website, thenewboston.com, and yeah, I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your third C++ tutorial. And in this tutorial, I want to go over a little more about printing text out on the screen. Now, in the last tutorial, you remember that we could use that special thing called cout, which was technically called the output object, and the less than sign, which was called the stream insertion operator, to print out text on the screen. And the way we did this is we added double quotes after, and whatever we printed out in these double quotes, like boy, I love bacon, whatever we put inside those double quotes would just print out on the screen. So if we go ahead and we built and run this, we saw boy, I love bacon right on the screen. Simple enough. But now what I want to go over is just a little more about cout, and I just want to make sure you guys understand how it works. So each function is made up of these things called statements, and typically people put one statement per line of code. And remember, all statements end with semicolons. So say we wanted to print out something else out on the screen. Well, you'd write cout less than, and write something else like and ham, just like that. So you might be thinking, alright, I got a feeling I know what this is going to do. On the first line, it's going to print out boy, I love bacon. And on the second line, it's going to print out and ham because, that's how it appears in our code. So that's what it's going to do. But if you go ahead and build and run this, it says boy, I love bacon and ham, all on the same line of code. And if you're scratching your head saying, alright, why exactly does it do that? The reason it does that is because when you're using this thing called cout, it's called printing it out into a stream, and it pretty much takes all your characters and prints them out in the same stream. So whenever this stream is done, you're not telling it to move to a new line. You're just saying print out these characters and then stop right at the end of this line. So then this stream starts printing out, and again, you're not telling it anywhere to move to a new line. computer programs are very picky and they need to be told exactly what to do. So in order to move to a new line, we need to add a special symbol, I guess you would say. And the symbol is this. First of all, you need to add another stream insertion operator, and you can go ahead and write ENDL. What this means is end line. And now, when we go ahead and build and run it, check what happens. It runs boy I love bacon, and then it runs end line. And before, your stream insertion operator would be right here, but now since you said end line, it go ahead and it ends this line and it moves it to a next line. So basically all you have to remember is anytime you want to move to a new line, use the character end L, which is code word for end line. Now if you're saying, alright, that's easy enough to remember, so let me go ahead and show you something that might be even easier for you. Inside your quotation marks, if you go ahead and add \n, this is basically the same as adding a new line. \n is the code, I guess that all is code, for go to a new line. So now it's going to say boy I love bacon, and then it's going to come across this thing called \n. It's going to say, hold on, what is this \n? Oh, I know what it is. It's the symbol to move to a new line. So this is basically just an alternative way to move to new lines. The only difference is when NL, you needed to add another insertion operator and then write NL right there. With a new line, you write it inside the quotation marks because it gets interpreted in a different kind of way. So let's go ahead and build and run this and just verify that, yep, boy I love bacon, new line, and ham. So again, like I said, whenever you want to print text out on a new line, you have to be very specific with C++ and tell it exactly what to do. And you can do this either using the NL or the new line that goes inside the quotation marks. So aside from this, you might be thinking, alright, so I printed this out and I got this on the next line, but what if I wanted a blank line in between these two? Well, all you would have to do is write new line, and then when you go ahead and you build and run this, it will say, alright, boy I love bacon, new line, and then it printed out and ham. Simple enough. Pretty cool, huh? And I guess one other thing I can show you is if you go ahead and do cout insertion operator, you can do things like this. Boy, new line, I, new line, love, new line, bacon, new line. So, you're not only limited to, one new line per statement. You can have multiple new lines in a single statement. So now it says, boy, I love bacon. Pretty cool, huh? So that's all the basics I want to teach you guys for this tutorial. Again, I wanted to stress how to print out text on the screen, and also the stream insertion operator. It's basically this. Each stream insertion resumes its printing out wherever the previous one stopped. So if you want to move it to a new line, you need to use one of these new line symbols, either NL or new line. So that's all I have for you guys in this tutorial. Now you should be a pro at printing text out on the screen. So we're not ready to bundle up this program and sell it to Microsoft yet, but hey, it's a start. So thank you guys for watching. If you have any questions, go to my website, thenewboston.com, and ask me on my forum. So thank you guys for watching, and I guess I'll see you in the next video. What is going on, guys? Welcome back to your fourth C++ tutorial, and in this tutorial I'm going to be going over something called variables, because variables are such a huge part of C++. I can't stress this enough. So let's go ahead and tap into our memory banks and try to remember back in like 7th grade when you first started learning about variables. And if you can't remember, let me give you a brief history lesson. Variables are basically just placeholders. That's all they are. So let's go ahead and say we had a variable named x and we set it equal to bacon. Well then, whenever we would have a sentence like Bucky loves x, we knew that x equals bacon, so this meant Bucky loves bacon. Simple enough. So let me give you guys another quick example. Say x was equal to 7. So then when we had a statement like 5 plus x, we knew that this meant 5 plus 7. Simple enough. So as you can see, a variable is basically just a placeholder. Now, let me go ahead and show you guys how to make variables in C++. In C++, in order to make variables, you go ahead and first write the type of variable you're going to be working with. Now, I'm going to be going over data types later, but for now, I want to give you guys one data type, and that's int. This stands for integer, and an integer is pretty much like a whole number like 6, 83, 540. It's a number without a decimal place. So now that you gave C++ the type of data you're going to be working with, you need to go ahead and name your variable. Go ahead and name it anything you want. I'm going to go ahead and name mine tuna. So now it has a type and a name. So now all we have to do is use the equal sign and set it equal to a value. So since this has to be equal to a whole number, let's set it equal to 6. It doesn't matter what whole number you set equal to, but I just like 6. It's easy to type. So now we have the variable tuna, and C++ knows that it's an integer and it's equal to the value of 6. So now what can we do with variables? Well, just like we can print out text on the screen, we can also print out variables just as easy. So if you went ahead and said cout and just go ahead and print it out tuna, we can go ahead and build and run this, and it would print out not the word tuna, but it would print out 6, just like that. So that's pretty cool, and that's the basics of variables and how we can use variables in C++. And actually, in this tutorial, what I was planning on doing is building a simple calculator. Let me go ahead, and I guess I have time for this. Let's go ahead and make two variables, and I'll show you guys another cool thing that you can do with C++. Let's go ahead and make int. Make a variable called a, and we'll set it equal to 4. Let's go ahead and make another variable called b, which is of course an integer because that's the only type we know right now, and we'll set this equal to 21 or something. Doesn't matter as long as they're both numbers. Now let's go ahead and make another variable called sum, and this sum is going to be equal to a plus b. So now you can see, aside from, well, let's go ahead and, yeah, that's good enough. So now you can see that aside from just assigning variables numbers just like that, you can also use basic arithmetic to set variables equal to another value as well. So now the value of 25, a plus b, is going to be equal to sum. So now if you go ahead and print out cout sum, and then we go ahead and we build and run this, check it out. It prints out 25 on the screen. Pretty cool, huh? So again, in this tutorial, I want to show you guys that in order to make variables, go ahead and write the data type, what do you want the name of the variable, or excuse me, what you want the name of the variable to be, and what you want the value of the variable to be. And then, aside from just assigning variables basic values, you can also use basic arithmetic like a plus b, b minus a. You could have done that. Let's see, if you had b minus a, let's go ahead and see what the value of that is. 17. So again, you can go ahead and set variables equal to basic arithmetic using other variables, and you can even do this. Sum equals 48 minus 7. Again, this isn't really the sum anymore. It's more of a what is it? Not the product, not the quotient, the difference. There we go. That's what and there we go. I got it. So again, you understand the basics of variables. That's what I'm trying to stress. So in the next tutorial, what I'm going to be doing is I'm going to be showing you guys how to make a very basic calculator. And this is the first program we're going to be building that actually interacts with the user. And it's going to be awesome. And you needed to understand variables before I could show that to you guys. So that's why I had to go over this tutorial. But for now, thank you guys for watching. Don't forget to subscribe. And don't forget to check out my website, thenewboston.com. It's awesome. So anyways, thank you guys for watching, and I'll see you next video. Alright guys, welcome back to your 5th C++ tutorial, and in this tutorial, since we now have the knowledge of variables within C++, let's put that knowledge to use. So let's go ahead and make 3 variables right now, but I'm going to be making them a little bit different than before. So in the last tutorial, we had a variable like a, and you set it equal to a value like 54. Simple enough. But I want to tell you guys that whenever you first create a variable, you have the option of assigning the value then or assigning the value later on, such as a equals 54. This is perfectly fine, and you can do it this way. So whenever you first create a variable and you don't assign the value, this is called declaring the variable. Declaring is just another name for creating the variable. So let's go ahead and create 3 variables. And by the way, I'm going to be making a basic computer program where the user enters 2 numbers such as like 2 and 3, and the computer is going to add them together and it's going to give them the answer, which would be 5. So int a, I'm going to have a variable called a, and I'm going to have another variable called b. And what we're going to be doing is we're going to be calculating the sum, or in other words, when you add the 2 numbers together, the answer of that, and storing it in a variable called sum. So we don't have any of the values yet, so that's why we can't fill them in. The user is going to be entering the values for us. So the first thing we want to make in this program is just a little prompt on the screen to tell the user to enter a number. And we do that using cout, and we just write enter a number, Haas. And then let's go ahead and write new line. And now we need a way for the user actually to input information from their keyboard. So here's a neat little thing I can tell you. Cout took information from your computer and output it to the screen. But anytime you want to take information from the computer, or excuse me, from the user and give it to the computer, you need to use cin. So cout basically takes information from the computer and gives it to the user. Cin takes information from the user and gives it to the computer. So if you write cin, and by the way, if you're taking a test, this is technically called the input stream object. And the little greater than sign is called the stream extraction operator. So, make sure to fill that out on your multiple choice if you're watching this in a C++ class or something. So anyways, you can see that this is different from the cout for 2 reasons. First of all, it's cin instead of cout, and also your arrows face the opposite way. That's because you're giving information to the computer instead of the computer giving information to you. So now what we can do is we're going to enter a number, and whatever number we enter, we need to give it a place to store that number. Well, we already have a variable right here, so let's go ahead and use that and use the variable a. So check this out. It's going to allow us to enter a number, and whatever number we enter, it's going to be stored in the variable a. So for example, if we enter the number 3, a is going to be equal to 3. Simple enough. So now that we have that variable taken care of, we basically need to do the same thing again with the other variable b. So cout, we'll say enter another number, and just go ahead and we'll just make a new line to make the program easier to read, and use that cin again. But now when they enter a number, we want that value to be equal to the variable b. So they're going to enter 2 numbers. One's going to be equal to a, the other is going to be equal to b. So now for the sum, we don't want them to enter a value for the sum. We want to calculate that ourselves. So in order to do that, just go ahead and write sum equals a plus b. And now what our computer program is going to do is it's going to say, all right, I'm going to grab the value you put in for a, and I'm going to grab the value you put in for b, and I'm going to calculate that, and I'm going to store that in the variable sum. So for example, if you wrote 10 and 15, it's going to say, all right, grab 10, grab 15, calculate the sum of it, which is 25, and store it in a variable called sum. So now the sum is equal to the answer, and all we have to do now is print it out on the screen. So cout, we'll just write the sum of those numbers is it the sum of those numbers are, or sum of those numbers is? I think it's is because it's one sum. And again, anytime you want to add more than one line of text, you could do it like this. You could write a new line and then print this out on another line, but I want to add it on the same line. So I'm going to go ahead and add another insertion operator just like that, and just go ahead and write sum. And then add another one and just go ahead and write end line, just so our program looks nice and neat. So basically, well, let me go ahead and run this, and I'll talk you guys through it after I run it. Our computer program says enter a number, Haas. I'm going to enter 50 and then go ahead and press enter. Once I press enter, 50 is going to be stored in the variable a. It says enter another number. I'm going to enter 32. Then I'm going to press enter, and that 32 is going to be stored in the variable b. Then it's going to make our calculation and print it out on the screen. The sum of those numbers is 82. 50 plus 32 is indeed 82. So remember, what we did is basically this. We made three variables that we're going to be using later on. The first thing it said is just basically a prompt. Enter a number. Then we entered 50. It stored 50 in the variable a using cin. Again, cin is a way that the user can give information to the computer program instead of the other way around. So now a is equal to 50. It gave us another prompt and we typed in 32. Now b is equal to 32. So in order to calculate the sum, we took the sum variable and set it equal to the sum of 50 plus 32. So now sum holds the value of 82 or 83, whatever I typed in, I can't remember. And then all we did is we printed it out on the screen. And again, we could have wrote three different statements for this. One C out for this, one C out for this, one C out for this. But in order to save us some time, we can actually use this operator right here and print everything out on one line. So that is why our program ran the way it did. Again, let's just go ahead and run it one more time. Enter a number, 44 and 76, hit enter. The sum of those numbers is 120. Pretty cool, huh? So that's how you build a basic calculator in C++ using variables and cout. So now that you got that done, we can begin moving on to the next topic, which is I don't know. But trust me, it's going to be amazing. So you study this, and once you understand the basics of variables and cin, you're ready to move on to the next video. So for now, thank you guys for watching. Don't forget to subscribe, and I will see you in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 6th C++ tutorial. And in this tutorial, I want to go over some concepts with variables that are definitely going to help you later on. So the first thing I want to go over is this. You remember in the last tutorial where I told you guys that there are basically two different ways to create variables. The first way is to create a variable called tuna or something and set it equal to a value like 43 all on one line. Simple enough, easy to understand. Well, what I also told you guys you can do is you can declare, aka create it on one line and set it equal to a value on another line, such as that. They're both perfectly acceptable ways to do things. The one thing I wanted to stress is that whenever you do this way, declare it on one line and set it equal to a value on another line, you don't need to write what type of variable it is again. Once you give C++ the information of what type of data you're working with, you don't need to list it every time you're working with a variable. C++ will remember that information and, it'll keep it. So whenever you're working with tuna later on, you don't need to explicitly write int, and actually you can't, or else it'll give you an error message. So just make sure that, just remember that don't write int twice on the same variable. So aside from that, let me show you guys this. Int tuna equals 99. So later on, and I didn't tell you guys this, but what you can do is if you set tuna equal to something else, like 76, whenever your computer creates a variable, it sets aside a piece of memory to store that value, in this case 99. Well, whenever you whenever you use that variable again and set it equal to a new value, what your computer is going to do is it's going to wipe out the old value in order to make room for the new value. So now you said, alright, we have a variable called tuna and that's equal to 99. Well, now we have a variable called tuna and we want to set this equal to 76. Well, alright, so we're going to try to print out tuna, and our computer is going to say, alright, should I print out 99 or 76? Well, since we created one originally that was 99 and then we overrode it to make it 76, it's going to print out 76. So let's go ahead and build and run this and see what we get. 76. So basically, whenever you have a value, it's placed in a memory location, and then whenever you give that variable a new value, it's going to overwrite the old value and put it in the same location. So I just want to tell you guys that this is how you can overwrite variables. So if you're expecting 99 and you got 76, this is why. So that's actually all I have for you guys for this tutorial. Again, the two things I want to stress is whenever you're creating a variable, you only write the type once. You don't need to write it every single time. And then whenever you need to reassign a value, you just go ahead and write the variable name and not the type again. And also, whenever you're overwriting a variable, you use the variable and it's going to be equal to the latest value. So whenever you set this equal to 76, it's going to wipe out the 99 and use the 76. So I just wanted to stress those, a couple of memory concepts, so then whenever we're building programs later on, you might have a better understanding of how it works. So for now, that's all I have for you guys. In the next tutorial, you know how I said that we're going to be going over arithmetic, like how to add two numbers together? Well, there's actually a bunch of different arithmetic operators that we need to learn, and that's what we're going to be covering in the next tutorial. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you in the next video. Alrighty guys, welcome back to your 7th C++ tutorial, and in this tutorial, as promised, I'm going to be going over basic C++ arithmetic. Now, I don't know, I think it was like 2 tutorials ago, I gave you guys a variable and I showed you guys that instead of just setting it equal to a plain old value like this, you can use basic arithmetic like 4 plus 6. And then when you go ahead and you print it out X or anything like that, it actually calculated the value and printed out the answer. So go ahead and run this and you see that X now equals 10, 4 plus 6. So aside from addition, I want to show you guys all the arithmetic operators that you can use, and they're a little bit different than you might expect. So let's start with the easy ones first. The first one is subtraction, and of course, like 8 minus 4, this would be valid. If we go ahead and build this, we saw that the answer would be 4. So addition, subtraction, easy enough. But also, aside from addition and subtraction, you can use multiplication. But make sure not to use X like that, because that'll mess up. In order to multiply in computer programming, you use the asterisk, and that's the symbol above the 8 on your keyboard. And what this is going to do is multiply these two numbers, 8 times 4. So now if you go ahead and run this, we should get 32, and check it out, 32, just like that. So well, let's go ahead and before I go over this, let's go ahead and go over division. In order to use division in computer programming, let's go ahead and take 81 divided by 3. Division, the symbol for this is the /. So let's go ahead and take 81 divided by 3 and we get 27, just like that. Simple enough. But check this out. What if we have something like 81 divided by 2? Well, it should be 40, but it has a remainder of 1. So let's go ahead and try to build and run this and see what we get. Well, it just says 40, and that's not entirely right because it should have a remainder of 1 with it. So we're saying, alright, we're working with integers right here, and we don't know any other data types, so how can we get that remainder? Well, whenever we want to use the remainder, we need to use something called the modulus operator, and that is the percent sign like this. What this is going to do is it's going to give you the remainder of the answer. It's not going to say 40 remainder 1. It's just going to give you that 1. So let's go ahead and build and run this, and you can see that whenever we do 81 modulus 2, it's going to give us the remainder, which is 1. So let me show you guys a better example, maybe 24 modulus 7. Well, we know that 24 divided by 7 is 3 with a remainder of 3. So let's go ahead and build this, and again, it doesn't say 3 remainder 3. It just says the remainder, which is 3. Simple enough. So now that we know all the arithmetic operators, I can begin teaching guys about order of precedence. Now, aside from just, one number arithmetic operator, another number, you can have complex calculations like 6 times 4 plus 8 times 4 plus 9 divided by 20. And if we go ahead and build and run this, let's see what we get. 56. We're saying, alright, so what order is this doing this in? Is it doing 6 times 4 and then plus 8? Or is it doing, 4 plus 8 and then times that by 6? Because depending on how you do it, it's going to come out with a different result. So the basics is this. If you remember way back in like 7th grade math, you know something called your associative property, and that's pretty much this. Anything that's in parentheses gets done first. If you don't have any parentheses, it goes like this. It does all the multiplication and division, which would be this, this, and this. It's going to do that first, and then it's going to do your addition and subtraction. If you don't have, if if you just have like 4 plus 8 plus 7, you're saying, all right, then is it going to do 8 plus 7 first or 4 plus 8 first? It really doesn't matter. It comes out the same either way. The only time you have varying answers is when you have like 4 plus 3 times 7. For example, if you did 4 plus 3, it would be 7 times 7 would be 49. But whenever we run this, whoa, easy box, we get 25. Why is that? Because it uses the associative property. It actually multiplies first, which is 7 times 3, and that's 21 plus 4, which is 25. So again, if you want to explicitly say 4 plus 3 first, you need to surround that in parentheses. So now whenever we build and run this, it's going to run your parentheses first and say, alright, 4 plus 3 equals 7 times 7 equals 49. So remember, the rule is this: parentheses first, then your multiplication and division, and then your addition and subtraction. So remember that, and if you get confused, it's called the associative property. You should have learned it in like 8th grade math or 9th grade math or maybe 7th grade. I don't know. I can't remember. It was a long time ago. For now, that's all I want to talk to you guys about. Basic arithmetic and how it works in C++. So for now, that's all you guys get. So thank you guys for watching this tutorial. If you have any questions, go to my website, thenewboston.com, and click on forum, and you can ask me there. So one last time, thank you guys for watching. Don't forget to subscribe, and I'll see you next video. What is up, guys? It is Bucky, and welcome to your 8th C++ tutorial. And in this tutorial, I want to talk to you guys about something called the if statement. Now, the if statement is a way where we can have our program make very basic decisions. What we're going to be doing is we're going to be giving our computer program a test, and it's going to run that test. If the test is true, then it's going to run a certain bit of code. If the test is false, then it's not going to run any bit of code. So depending on that test depends whether we run code or not. So it sounds confusing, but it's actually incredibly simple. So let me go ahead and I'll show you the syntax for if statement right now. The syntax to make an if statement is if. You just go ahead and type the word f, and then go ahead and add parentheses. Now inside our parentheses is where we're going to be making our test. Now after those parentheses, go ahead and add curly braces. Now this is called the body of the if statement, and now here is where we write the code to run if the test is true. So let's go ahead and make a simple bit of code. Let's go ahead and just write like cout Bucky is awesome. So if our test is true, it's going to print out Bucky is awesome on the screen. If the test is false, it's not going to print out anything. So let's go ahead and let me talk to you guys about the different types of tests. The first test I want to show you guys is the greater than test. And this simply tests if one value is greater than another value. So if 5 is greater than 3, go ahead and run this code. So 5 is indeed greater than 3. So this is true. So whenever we build and run this, it's going to say Bucky is awesome. Pretty cool, huh? So now let's go ahead and make something like is 1 greater than 3? So it's going to test this. Is 1 greater than 3? Well, this is actually false. 1 is less than 3, so it's not going to run this bit of code. So go ahead, build and run this, and as you can see, it did not print out Bucky is awesome on the screen. How sad. So of course we have the greater than test. We obviously have the less than test. 1 less than 3. Well, now this is going to be true, so it's going to print out Bucky is awesome on the screen. So let's go ahead and run this, and indeed it prints out Bucky is awesome. So aside from greater than and less than, we also have these two tests, greater than or equals to. So whenever we tested whether 3 is greater than 3, this test is going to be false because 3 is not greater than 3. 3 is actually equal to 3. Well, if we want to test if 3 is greater than or equal to 3, we use greater than with the equal sign after it. So now whenever we run it, is 3 greater than or equal to 3? Yes, 3 is equal to 3. So it printed out Bucky is awesome. So aside from that, we also have the less than or equal to. So if, is 1 less than or equal to 3? Yes, 1 is less than 3, so it's going to print out Bucky is awesome. So again, what I want to show you guys is that you have greater than, less than, greater than or equals to, and less than or equals to. So now those are called the relational operators. We also have two more tests that we can do, and these are called the equality operators. This is a really simple test. It tests whether one value is equal to another value or if one value is not equal to another value. So in order to do this, go ahead and write is 3 equal to 3. And you might be thinking, alright, why don't I just use one equal sign? Why didn't they make it that way? Well, whenever we were creating variables, such as like int x equals 8, the one equal sign, the single equal sign, is a sign for creating variables and assigning values. So that's why they decided that two equal signs was sufficient for testing. So remember, a common mistake is to put one equal sign in there and you're going to get an error or something terrible is going to happen. So whenever you're testing, you need two equal signs. So let's go ahead and run this test. Is 3 equal to 3? Well, yes it is, so it's going to print out Bucky is awesome. Give it another test, like is 7 equal to 3? Well, no it's not, so it's not going to print out Bucky is awesome. So that is one test. It's called the equal sign, or equal to test. And there's one more test I want to go over, and that's exclamation point equal sign. And this is the keyword for not equals to. So is 8 not equal to, or in other words, is 8 different than 8? Well, no, it's the same, so it's not going to print out everything. Is 10 different than 8? Well, yes it is, so that's going to be true, and it's going to print out Bucky is awesome. So that is all the tests that I have for you guys, and that's all the tests in C++. Again, to recap one last time: greater than, less than, greater than or equal to, less than or equal to, equal, and not equal. So now that we know all those tests, I probably should tell you guys this. People typically don't, and by people I mean computer programmers typically don't just test two numbers against each other. They usually have variables that they test against each other, like int a equals 98, int b equals 76, and then they test something like is a greater than b. Well, if we go ahead and run this, 98 is indeed greater than 76, so of course that's true. It's going to print out Bucky is awesome. And aside from that, you either have two variables to test, or you have a variable and a value, like is 98 greater than 5, something like that. We can actually mix variables with values, and that would be true as well. So again, you can either have two values in here, two variables, or a variable on one side and value on another side. Pretty cool, huh? So that's the basics of, again, relational operators are the greater than and less than one, and equality operators are the equals equals and exclamation point equals. So now that we know how to make a basic if statement, again to recap one last time: if your test and then the body, and it's going to run the test, and if that code is true, it's going to run the body. That's the basics of an if statement. Now that we understand that, we can begin enhancing our programs a little bit more. So in our next tutorial, what I'm going to be doing is I'm going to be having the user enter two numbers, and we are going to be comparing those numbers, and depending on what numbers they entered, run a certain bit of code. So now, as you can see, we're just building and building to our knowledge of C++ to make better and better programs. So don't skip over if statements, because it's a huge part of C++. So for now, that's all I have for you guys. So thank you guys for watching. In the next tutorial, we're going to be building that calculator thingy, so it's going to be awesome. So thank you guys for watching. Don't forget to subscribe, and don't forget to check out my website. What is going on, guys? It's Bucky, and welcome to your 9th C++ tutorial. And in this tutorial, I'm going to be talking more about functions. Now, I talked about this a little bit in, like, I don't know, a couple tutorials ago, but I want to talk about it again because I really want to stress what functions are and why they are useful in C++ programming. So if you remember, a function is basically a computer program is made up of a bunch of functions. Right now we have one function right here, and basically the job of a function is to do something. So inside function we can give our program a bunch of separate instructions, all followed by a semicolon. So our main function that we already learned is the starting point for every computer program. Every program starts with the function main. So this is one function right here, but let's go ahead and create another function. And in order to do that, go ahead and separate from your main. So before we were coding everything inside the main function, but now we want to create another function. So go outside main right here. Now the first thing that we need is a return type, and this is whenever people build functions, they usually make a calculation and give you back something. For example, if we had a function to calculate the speed of my car, it would give me back a number. If we had a function to calculate my weight, it would give me back a number. Well, sometimes functions make calculations, and sometimes when they don't make calculations, just as like printing something out on the screen, it doesn't really need to calculate anything. So sometimes functions are going to return a number to you. In that case, you would use int. And sometimes they just do stuff like print something out on the screen and don't return any answer to you. Whenever a function doesn't return anything to you, just go ahead and put void. And this means, function, just go ahead and do your thing, and I don't want anything in return. So the very first thing you write is the return type of the function. So this one, you see it returned a number, but this one is just going to print something out on the screen, so it's going to return void. So after this, you go ahead and you name your function. This one is named main, and you can actually name it anything you want. This function is just going to print something out on screen, like I said, so I'm just going to name it print something. Pretty dumb, I know, but hey, it's my function. I can do what I want. So after this, you see that I added two little curly braces, and those are actually called parameters. Whenever your function needs additional information, you add parameters, but we're going to be covering this in the next tutorial. For now, just remember to add them and add nothing in between them. Trust me, I'm going to be covering this in the next tutorial, and I'm going to make it real easy to understand. But after these parentheses, go ahead and add two curly brackets. And just like I said before, this is the body of your function. For example, if you had a function called make peanut butter and jelly, inside your body you would have a set of instructions like get out the bread, next instruction, put peanut butter on one slice, next instruction, put jelly on one slice, lastly, eat it. Well, in the body of our function, we give it each instruction about what we want this function to do. So in our function called print something, the only thing that we want this function to do is print something out on the screen. Easy enough, we already know how to do that. So let's go ahead and cout. Oops, there we go. And what are we going to print out on the screen? Just write like, ooh, I am text on the screen. It's a very feminine function we have here. But anyways, then just go ahead and end the line. Simple enough. So now, whenever we use this function, whenever you use a function, it's called calling the function. Why they did that, I don't know, but just remember whenever I say call the function, I basically just mean use the function. So whenever we call this function, all it's going to do is print out, ooh, I am text on the screen. Simple enough. So let's go ahead and remember, since our computer program starts with main, we need to tell it in main that this is the function that we want to use. So in order to use or call a function, all you do is this. Just go ahead and write print something, empty parameters, and a semicolon. So again, anytime you want to use a function, just go ahead and type the name of the function, empty parameters, and a semicolon. But check this out. Whenever we try and build and run this, we're going to get an error. This is what this little red rectangle means. You can't read my error message because it's down here, but it says printing something was not declared in the scope. And you're saying, alright, what did we do wrong? Because Bucky told me that this function is built perfectly, which it is, but whenever it tried to call it or use it right here, it didn't understand what was going on. So why is our compiler kind of confused? Well, the reason is this. Computer programs work from the top down. It starts at the very top line and it runs downward until it gets to the very end and then it quits. So whenever our computer program was running, it said this, alright, include this file, done. Use this, done. Okay, now start with main. Print something. What the heck? I never seen that before. Is this a function, or are we trying to make a variable, or what the heck are we doing? I don't know what this means. Well, that's because whenever we created our function, we created it after we used it. We need to tell C++ before we use our function that it is actually a function. So we have a couple ways of doing this. Probably the easiest way is just to do this. Go ahead and cut it, and then above your main, go ahead and paste it. And now C++ is going to think like this. Alright, I'm going to include this, simple enough. I'm going to use this, easy enough. And oh, you made a function called print something now. Okay, I'll remember that. So now whenever I call my main and I come across this thing called print something, I know that it's a function that you created. So that's why whenever I build and run it now, it's going to run perfectly without any errors. So that is basically how a computer program works. First, you need to tell it that you are actually creating a function before you can use that function. So if you just try and use it, it's not going to know what it is if you didn't create it first. So we're saying, alright, I'll just remember to create all my functions before I use them. Okay, you can do that, but let me give you an alternative method of doing this. If for some reason you like your main at the top and you like to create your functions after, well, we already know that whenever you try to run this, we're going to get an error. But there is one thing that you can do, and this is called function prototyping. And all this is this. Trust me, it's the easiest thing ever. Go ahead and select your return type, your function name, and the parentheses, and go ahead and copy that. Now, above your main and under your using, go ahead and paste this. This is called the function prototype, and it's pretty much a copy of your function's header. And it basically is saying this. Alright, whenever you run this program now, go ahead and include this, and then we're going to, this is called prototyping a function. This is pretty much telling our C++ program this. Alright, later on, you're going to come across something called print something. Now, whenever you come across it, we don't want you to freak out like you have before, sending us a whole bunch of error messages. What we're telling you right now is we created a function called print something, but you have to go find it. And C++ is going to say, oh, alright, now whenever I try to run my main and I come across this function, instead of giving you an error message, I'm going to know that this is a function that you have somewhere in your program. So I'm not going to freak out. I know this is a function. I know to handle it accordingly. So check it out. Whenever you try and build and run this, it works perfectly. So that is why you need to do one of two things before you use your function in main. One, you can prototype it, or two, you can just go ahead and make your function before main. Either way, whenever you run this function in main, it needs to know beforehand some way that this is a function. So those are your two different ways of doing that. And again, in order to create a function, go ahead and type the return type, the function name, and the parameters. And again, I'm going to be talking about these parameters in the next tutorial. So as long as you understand this and the basis of how to create a function and how to use them in main, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What is going on, guys? It is Bucky, and welcome to your 10th C++ tutorial. And in this tutorial, I'm going to be teaching you guys how to create a function that uses parameters. Now, a parameter is quite simply additional information that that function needs in order to work. So let me give you guys a quick example of this. Say you made a function to calculate the age of someone, how old they were. Well, some additional information you would need before you can calculate that is what year were they born. And once you have this information, you can calculate their age. So let's go ahead, and now that we understand why a function would need additional information, let's go ahead and create a simple a simple function to use additional information. So let's go ahead and create a function that just prints out Bucky's favorite number is blank. We might say Bucky's favorite number is 20. Bucky's favorite number is 68. Bucky's favorite number is 99. Well, since we don't know what my favorite number is yet, we're just going to go ahead and put a variable in place for that number. So since this isn't going to be making any calculations really, we can just go ahead and use void, because that means return nothing. So name your function anything you want. I'm just going to name mine print crap, since that's all it's going to do, print crap out on the screen. And before, we just added these empty parentheses with nothing in between them, and then we coded the body right here. Well, whenever we use a parameter, you actually put that information right in your parentheses. And check this out. You know how I said we didn't know what that number is yet? And that's the additional information that we need. Well, since we don't know what it is yet, we just go ahead and we set it equal to a variable. And since this is an integer, we go ahead and set it equal to the variable int x. You can name your variable anything you want, but I'm going to name mine x because it's really simple, easy to work with. So now we can go ahead and we can add the body of this function. And all we're going to do in this function is print out on the screen Bucky's favorite number is, did I spell everything wrong? Yep, good to go. Bucky's favorite number is X, and then just go ahead and end that line. And now when our function runs, it's going to run something like this. If we say that our favorite number is 20, it's going to say Bucky's favorite number is 20. If we say that our favorite number is 10, Bucky's favorite number is 10. So we can run this function a bunch of times and give it a different piece of information each time, and it's going to work. So let's go ahead and remember, in order to use a function in your main, you just go ahead and you type the function name, and then you add your parentheses and your semicolon at the end. But whenever your function needs an additional piece of information, you need to give it that information inside the parentheses. So we know from making our function that it needs one integer in order to work. So let's go ahead and inside these parentheses give it one integer, 20. So now what it's going to do is, well, let me go ahead and run this and show it to you guys. Bucky's favorite number is 20. Alright, so what happened is this. We said, alright, C++ program, we want to use this print crap method. Well, it said, alright, in order to use this method, I'm going to need one integer. So we gave it the integer 20. So then, whenever in this function it came across the variable x, it just substituted 20 for that. So whenever you're making parameters, you first need to list what type of data and also a variable name. So then whenever we give it that variable, it substitutes that variable for x later on in the program. So for example, let's give it one more example, like 854. Well, now we run it and it says Bucky's favorite number is 854. And that's the beauty of parameters and functions. It doesn't need to be the same every time, so that's why you can use variables. So again, what we did is we created a function and it needed an additional piece of information, which was an integer. And since it didn't know the value yet, it just went ahead and it set it equal to a variable. Then later on in the body, whenever it came across that variable, it knew whatever value you told it to substitute for x, that's what value is substituted for x. So we can run this 100 times with 100 different values if we want. It's going to substitute it for x each time and use that information to plug it in. So that's the basics of how you use functions with parameter. Again, whenever you're creating a parameter, use the data type and a variable name, and whenever you're using the function, don't forget to pass in or give it whatever information it needs. So that's pretty cool, simple enough, we understand that. But in the next tutorial, what I'm going to be teaching you guys is how to use functions that use multiple parameters. What if a function needs more than one piece of information in order to work? Well, I'm going to show you guys how to do that too, and it's a little different than this, so you definitely want to watch that. So once you understand this and understand the basics behind functions and parameters, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Hey guys, what's up? Welcome to your 11th tutorial, and in this tutorial, I'm just kidding, I'm not going to do this whole tutorial in song. Maybe another tutorial, but I'm not really in the mood this time. So anyways, in this tutorial, what I'm going to be teaching you guys is how to use functions that require multiple parameters. So let me give you guys a quick example of a function that might require multiple parameters. If you were making a calculator and you wanted the user to enter two numbers, well, it doesn't exactly know what those numbers are yet, so we go ahead and we use these numbers as parameters in functions. So as you can see, instead of just a single piece of information, it might need 2 numbers or 8 numbers or 20 numbers. So in order to use multiple parameters in a single function, let me show you guys how to do that. So let's go ahead and make that program right now that just goes and adds 2 numbers together. Well, we can't use void because right now it is making a calculation. It's gonna calculate 2 numbers, find the sum of them, and return to us the answer. So let's go ahead and say, alright, since what you're going to be returning to us is an integer, go ahead and type int. And now what am I going to name my function? Add numbers. Simple, easy, pretty clear. So now we go ahead and make our parameter list and body list. Here's what I do. before I add in my parameters. I don't know why, but you know, I just do it. So what we want to do is we already know that we can use one parameter by going setting the data type and giving it a variable name such as int x. Well, we know that this function is going to need two numbers. We already did one, so how do we say we want to use another number as well? Well, anytime you use more than one parameter, you have to separate it with a comma, and then you give it another piece of information that it's going to need. So it's going to need two numbers. One is going to be called x, and one is going to be called y. So let's go ahead, and now we have a function that takes two extra pieces of information. So we're going to be giving it two integers, x and y. So now let's go ahead and use those numbers somehow. So what we're going to be doing is, let's go ahead and make another variable called answer, and this is just equal to the values of x plus y. So say that the user passed in two numbers, 5 and 6. Well, what we're going to do now is say, alright, 5 equals x, 6 equals y, so answer equals 11. So once we have that answer calculated, all we need to do now is we need to return it. And this pretty much means give it back. So in order to return anything, you just go ahead and write return and then what you want to return. Well, just return the answer. So a return value is basically, once you make your calculation, the final calculation, that's what they get back. So in main, we return 0 because computer programs know whenever you get 0 back, this means that your computer program ran successfully. Well, for this one, we want to return the answer because that means that we calculated the answer, so that's what we're going to return back. So now, when we're using our function, we can just go ahead and print out that value using cout, and then go ahead and write add numbers, and then go ahead and write whatever numbers you want to add. And just like before, whenever we were creating our function, we had to separate these variables with a comma. Whenever we're using this function later on in our main program, we separate the values we're passing it in with a comma as well. So 43 is going to be equal to x, and 86 is going to be equal to y. So let's go ahead and build and run this and check it out. 129. Pretty cool, huh? So what happened is this. We said, alright, we want to print out the return value of this right here. So we can't just go ahead and do this because this is going to go ahead and calculate it, but it's not going to print anything out on the screen. So it actually made that calculation, but nothing's printing out. So in order to print that out, that's why we need that cout to print out the return value of this. So anyways, what we did is we said this. Alright, we want to use this add numbers function right here, but it needs two integers in order to work. It needs an x and a y. So we said, alright, you want two integers? You got it. You got a 43 and an 86. Let's make some magic happen, baby. So it took that 43, plugged it in for x, and 86, plugged it in for y, and it stored that value, or excuse me, it stored the sum of the calculation in a variable called answer. And the answer was like, I don't know what it was, but it took that answer and it returned it back to you. So it says, alright, this is basically equal to 129. So this right here is pretty much just a different way of saying 129, so I'm going to print out 129. And that is how you use functions with multiple parameters. For example, if you wanted to add four numbers together, it would be the same thing. Int x, int y, int a, int b, and then you just go ahead and use those values just like before. So plus a plus b, and then later on when you needed more information, 32, 43. Again, why I'm doing this, I just want to show you guys that you're not only limited to two parameters, you can have as many parameters as you want. You just have to remember to separate them all with a comma. So whether it's 2, 3, or 100, remember to separate them all with a comma in here, and also when you're actually using the function out here. So now you understand the basics of what a function is and how to use multiple parameters, single parameters. You're pretty much a pro with functions now. So once you understand this, you're ready to move on to my next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys later. What is going on, guys and gals? Welcome to your 12th C++ tutorial, and in this tutorial I'm going to be giving you guys an introduction to classes and objects. Now, classes are basically an easy way to group all your functions and variables and to group a bunch of stuff together. For example, people like to group similar functions together in the same class. For example, if you had a bunch of functions, maybe working with temperature, or you had a bunch of other related functions, you might want to group them all in the same class. It makes them easier to work with later on. So then, if you have like 1,000 functions, you say, alright, where are all my temperature functions? Because I need them now. Oh, they're in my temperature class. So that is kind of the usefulness of classes and the basics behind that. So let's go ahead and in order to create a class, we go ahead and make sure you're outside your main. First of all, I want to say that. So I'm going to create mine before my main. And in order to do this, go ahead and type the word class. And now, after this, go ahead and add a space and name your class. Now, people typically name their class with uppercase letters, and I'm going to name mine Bucky's class, just like that. And now go ahead and add curly braces and a semicolon at the end. Now everything, all your functions, all your variables, all your crap goes inside the body of your class right here. So basically, all your crap that you want to go in the class goes in the class body, just like that. And I believe whenever you create a class, it's called declaring a class, but if your teacher ever asks you, make sure you say that. They'll probably be impressed. So before we start adding a bunch of functions and stuff, I want to talk to you guys about something called an access specifier. Now, sometimes you want to make functions that you can only use in your class, and sometimes you want to make functions that anybody can use outside your class. So if you want, for example, the main to be able to use your functions inside your class, you need to make your functions public. If you don't want main to be able to use the functions inside your class, then you would use something called private, but we're going to be going over that later. For now, just remember, whenever you use the public access specifier, it says that you can use it outside of the class. So in order to use that public access specifier, just go ahead and type public with a colon, not a semicolon, just a regular colon. And this means that anything you put after this, you're able to use it outside of this class. So if you didn't have that, then you would only be able to use your stuff right here. And what's the use of that if you need to put it in main? So anyways, make sure you add public. It's called an access specifier if you're taking, C++ test or something. So now let's go ahead and we create a function just like before. Let me just go ahead and print out something on the screen. So it's not going to make any calculation, so it's just going to print something out. So void. I'm going to name it cool saying, and it's not going to take any parameters. A really simple function here, and all it's going to do is print something out on the screen. Now I got to think of a cool saying. Preaching. Wow, totally messed that up. Preaching to the choir. I think that's how you spell choir. Not sure. Hope I don't look like a fool in front of all my subscribers. So now just go ahead and end line. And so all this function is going to do is print out preaching to the choir on the screen. Simple enough. So now you're saying, alright, this class looks good to go. We have the class declaration, class body, we have public, and we even have one function in our class. This is a pretty sweet looking class. So let's go ahead and use this right now. Well, now I want to talk to you guys about the other part of this tutorial. I told you guys I'm going to be talking about classes and objects. I already talked to you guys about classes. Now I want to talk to you guys about objects. An object is how you access the stuff inside of your class. For example, why do you need to make objects at all? Why can't you just write cool sayings just like this and use it just like that? Well, whenever you're making big computer programs and you have a bunch of different classes and a bunch of different functions in them, you may have this cool sayings. You may have a function that says cool sayings inside Bucky class. You may have another function cool sayings inside Tuna class. You may have another function cool sayings inside a class temperature class. Well, how does C++ know what function you want to use? Well, it needs an object, and an object basically tells it what class you're working with. So in order to create an object, it's basically the same as creating a variable. You go ahead and you do this. You type the name of your class, which is Bucky's class, And then after this, you give your object a name. And I'm just going to name mine Bucky's object, just like that. And go ahead and add a semicolon. And now this object, Bucky's object, you use this kind of as the key whenever you want to access the crap inside your class. So now, instead of just writing the function name, we have to write the object name first, like Bucky's object. And then in order to access anything inside the class, we need to use a dot separator. And a dot separator is basically our way of accessing the variables, the functions, all that stuff. So as you can see, we'll put the dot separator up, and it already knows that what we want to do. We want to access CoolSang just like before. Just type the name of the function and empty parameters, and bam, wham, thank you ma'am. We now have a full working program. So let me run this for you real quick to show you guys that it's working, make sure I don't have any errors, and then I'll talk you guys through it one last time. Preaching to the choir. Works perfectly. Pretty cool, huh? So anyways, people make classes in order to group similar functions. So if I had, a program that just had a bunch of cool sayings, I'd have cool sayings 1, cool sayings 2. I would want to put them all in the same class. For now, we only have one function because this is just an example. So we have a function that we put inside the class, and make sure to make it public. That means that main can use it as well. So we have a class, and we made that by making public and threw a function inside it. Pretty cool. So now we wanted to actually use that function that's inside the class. Well, we can't just go ahead and write CoolSang, because if we had a bunch of different classes, it wouldn't know which function named CoolSang to use. So it wouldn't know what class we wanted to use. So in order to use that function, we needed to make an object of that class. So we're saying, alright, we're making an object called Bucky's object, and it is from the Bucky's class. So now whenever we use Bucky's object, it knows that we're going to be working with Bucky's class. So we use Bucky's object CoolSang, and that knows, and that's basically our way of telling C++ that we want to use the CoolSang function, and we want it to come from Bucky's class since we use Bucky's object. So that is why you need objects, classes, and yada yada, all that stuff. So that is your basics of classes and objects, and why you need to make objects before you can use the stuff inside your class. So I know this is kind of confusing, but this is the basics behind object-oriented programming. So if you understand this, then tutorial, then the rest of your programming life is going to be a whole lot more simple. So watch this tutorial, watch it again, until you understand exactly how to make classes and exactly why objects are useful. And once you do, you're ready to move on to the next tutorial. So for now, thank you guys for watching. You guys have no idea how important the information you just learned was. So anyways, thank you guys for watching. Don't forget to subscribe. If you have any questions about any of this, feel free to ask me on thenewboston.com/forum. So yeah, enough of me talking. I'll see you in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 13th C++ tutorial. And in this tutorial, I'm going to be teaching you guys how to use variables and classes. But it's a little different than you guys might expect, so just stick with me, and I'm going to show you guys the wrong way, and then I'm going to show you guys the proper way to use variables in your classes. So before we even get started this tutorial, I want to include the string class as one of our files, because we're going to be working with strings in this tutorial, and if you can't remember, a string is just basically another word for text. So whenever we are outputting things like hey now, brown cow, this text is just another word for a string. So that's what a string is, to give you guys a quick little background on that. So go ahead and include the string class right under your IOStream, right above your namespace. And now, like I said, before I show you guys the proper way to use variables, I want to show you guys the wrong way, because this is a common mistake that a lot of beginners do. So you go ahead and you added your access modifier, public, and say you wanted to make a name variable. Well, name is of course a string, so go ahead and make a variable called name and set it equal to the type string. This is good to go. So now we have a variable in our Bucky class called name. So again, if you remember from last tutorial, in order to use the things in that class, you first need to create an object. So in order to create an object, you type the class name and then the name of your object. I'm going to name mine BO, which does not stand for body odor, stands for Bucky's object. So then we have an object named BO. And with that BO object, we can access variables by using the dot separator and just the name of your variable. So then once we have this variable name from the Bucky's class, we can go ahead and set it equal to any name we want, like Bucky Roberts. And then this variable right here is equal to Bucky Roberts. So then whenever we try to print it out, bo.name, it just goes ahead and it prints out Bucky Roberts on the screen. So you're saying, alright Bucky, that seemed to work pretty darn good to me. So why did you say that that was not the proper way to do stuff? Well, I don't want to get into too much detail, but basically I want to stress this. Making class variables public is generally not good programming practice. I don't want to get into like software engineering, but basically whenever you make your variables public, it makes your programs really easy to mess up. So typically what people like to do is make their variables private. And again, there's some exceptions, but typically you want to make all your variables in your class private. So you're saying, alright, I remember from the last tutorial you told me that whenever I make variables private, I can't access them in main. So whenever you try to run this program right here, we get an error. So you're saying, alright, this is just going to cause me a bunch of headaches. What am I supposed to do? Well, if you remember what I said nothing outside your class can access these variables. So we need to build a public function inside your class to have access to those variables. So that is what we need to do. So let's go ahead and delete all this. And we already made our variable private. So now let's go ahead and make public functions to access them. Because remember, if we make a public function to access that variable, we can use those public functions outside our class in our main. So in order to do that, just go ahead and write public, and now everything you type under here is going to be public. So we want to add two functions. The first one is just going to be, first of all, we're going to want to do two things to this variable name. We want to be able to change it, and that means set it, like set it equal to Bucky, set it equal to Tom, set it equal to Jessica. So we want to be able to set the name. And our second function is just going to get the name. We want to return the value Bucky, we want to return the value Tom, Jessica, whatever. So we have two functions, one to set the variable and one to get the variable. So in order to set the variable, just go ahead and set it equal to void because it's not returning anything, we're just changing the variable. And what people typically do is write set and then your variable name after that. And after this, we're going to go ahead and use the string, and we're going to call X because we're going to be passing in a string such as Bucky Roberts, Jessica Thompson, Tommy, and that variable is going to be equal to the value X. So whenever we set name, we want to change it, all we need to do is set it equal to the variable X, and then it sets it equal to whatever value we passed in. For example, if we say set name Bucky, it's going to treat Bucky as X, and now our name variable is going to be equal Bucky. Simple enough. So that is called our setter method, or excuse me, setter function. A method is actually, if I say method and I actually mean to say function, just remember that I've been teaching like 80 different computer programming languages, and in some languages they call a method a function and vice versa. So I might get it mixed up, but trust me, a method and a function is just the same thing. So anyways, with that little background, I now want to say this. We already built our setter function, how to change that name variable. Well, now we want to build a function to access it. And remember, since we want that name in return, we go ahead and type string because the name is of course a string, a bunch of text. So what people typically do here is instead of set, they write get because they just want to get the name. So go ahead and write get name. It's not going to take any parameters. And in the body, this is probably the easiest thing you're ever going to do. All you do is return the variable. So check it out. We don't have direct access to this variable, so we have to go through functions. In order to change this variable, we go ahead and we use this function. In order just to get the value of the variable, we go ahead and we use this function. So now instead of directly accessing this variable, we can do it through public functions. So again, like I said, the only thing that has access to these private variables are other things inside this class. So if we make those functions public, then we can access that variable, kind of like cheating, you know? So in order to do this, again, in order to use those functions, we again need an object. So Bucky's class, make another BO object, and now under this, if I scroll up, we can go ahead and BO, we can use the functions from that class by using the object name and then the dot separator, and then we'll just go ahead and the first thing we want to do is set a value to that. So go ahead and let me just copy this, paste it right here, and we'll set the name equal to something stupid like Sir Bucky Wallace. If you guys know where the name Sir William Wallace comes from, then leave me a comment below. Congratulations. So now this name variable is equal to the name Sir Bucky Wallace. So instead of accessing it directly, you can see that we went through a function that was public to do so. So now what we can do is we can just, print it out or something stupid. So cout, and in order to print it out, we just can't go ahead and write bo.name because we don't have access to that variable. What we need to do is we need to go through the function getName, just like that. And now what this function does is it returns the name. It's basically a way to make a private a public. Simple as that. So now when we go ahead and print it out, building around this, as long as I don't have any errors, and I don't, check it out. Sir Bucky Wallace. So let me talk you through this one more time. What we did is we wanted to access this private name variable. Well, we couldn't access it directly or else it will give us an error. So what we needed to do is we needed to build public functions. One to change the name and one to get the name. So then later on in our program, whenever we wanted to use those functions, we went ahead and we created an object. And then remember, whenever you want to use anything inside your class, write the object dot separator function object dot separator function, and then we ran our program and it worked pretty darn good. So that is the bad way to use variables and also the proper way to use variables. Again, you can put these variables as public, but it's just bad programming practice and bad software engineering. You're never going to get a job as a computer engineer if you make your variables public. So thank you guys for watching this tutorial. If you have any questions, check out my website, thenewboston.com. It's a pretty sweet website. I definitely want to check it out. So I am going to go get a drink because I've cotton mouth now, and you guys study this tutorial, and I'll see you in the next video. What is up, guys? Welcome to your 14th C++ tutorial, and in this tutorial I'm going to be going over constructors, what they are and why they are useful. So first of all, I want to tell you guys what a constructor is. A constructor is a function that gets called automatically as soon as you create an object. So before, what we could do is we could create an object and use that object to call functions from our class. Well, now as soon as we create this object, it's going to call a function called a constructor. We don't need to explicitly use that object to call a function. It's going to do it automatically. So if you're saying, alright Bucky, you talk the talk, time to walk the walk, show me an example. Well, creating a constructor is incredibly simple. To do so, it's basically the same as creating a function with a couple weird rules. First of all, I need to tell you guys this. Constructors never have a return type, so you don't need to type int or void or string or anything like that. The only thing you need to do is type the constructor name, and the constructor name is always the same as the class name, the exact same. So let's go ahead and copy this and paste it right here, and that's how your C++ program knows that it's a constructor, because once it comes across a function with the same name, it knows that that is the constructor. So let's go ahead and we'll add no parameters, and in the body, what do we want to happen as soon as we create this object? We can have just, maybe it'll print something out on the screen like this will get printed automatically. Pretty cool, huh? So now we have a constructor that's going to get called automatically as soon as you create an object. And you're saying, alright, you keep saying that, but what exactly does that mean? Well, say we have an object from Bucky class named BO. Well, before, we would have to write BO dot yada yada yada, whatever we wanted to use from it. But now, as soon as we create this object, this constructor is going to get called. So let's go ahead, build and run this, and see. This will get printed will blah 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 automatically. So you could see that before we needed to use that object to call functions, but this is a special function called a constructor that gets called automatically as soon as you create that object. So you're saying, alright, that's pretty cool and interesting, but why wouldn't I just, print this out on the screen or something else? What's the use of a constructor? Why would you even want things to happen automatically? Well, typically people don't print things out in their constructors. Actually, if you see anyone printing something out in their constructor, then they're an idiot and you should slap them upside the head, because constructors, the main reason that people make constructors are to give variables an initial value. So, for example, this class has a variable called name, but it might have another variable called age, height, weight, favorite color, favorite sports team. Have all these variables, so as soon as you create an object from that class, you might want to assign a bunch of values to these variables right now. So in order to do that, here is what you do. Whenever you want to take a value and assign it to a variable, you need to add a parameter in your constructor. So let's go ahead and assign a value to this name right here. And in order to do that, we need to pass in string and just name it Z or something. So now what we can do is we're going to be passing it in a string to be setting it equal to name. Well, we already have a function that does that called setName. So in order to do that, just go ahead and call setName with a parameter of Z. So now later on, whenever we want to use our constructor can take a parameter as well. And for our parameter, let's just go ahead and write something like Lucky Bucky Roberts. And now what's going to happen is this. As soon as we create this object, it's going to call a constructor with a parameter Lucky Bucky Roberts. So it's going to go up, see if it has a constructor. Oh, I do. And as my parameter, I need a string. And for a string, we gave it Lucky Bucky Roberts. So anytime it saw Z, it plugged in Lucky Bucky Roberts. So it says, alright, in your constructor, you told me to set the name equal to Lucky Bucky Roberts. So it basically set the name equal to Lucky Bucky Roberts. So pretty much Lucky Bucky Roberts got passed into Z, which got passed into X, which got passed into name. So that's why our name was Lucky Bucky Roberts. So now that our name is Lucky Bucky Roberts, that gets kind of repetitive saying that. But anyways, we can just go ahead and, print it out on the screen or something. So, of course, to access anything in our class, you use the object and, of course, the get name, just like that function. So let's go ahead and build and run this. And we have int main. We got a problem here. Hold on one second. Let me find it. Oh, I see. What the heck? How in the world did I do that? For some reason, I must have actually hit paste or something, but I copied the word name outside my class. I just wrote the word name randomly in the middle of my program. So remember not to put words randomly in the middle of your program or else it won't run. So now let's go ahead and build and run this and check it out. Lucky Bucky Roberts. So that is the basics of a constructor, how they work, and also how you can add a parameter to your constructor. And basically the only times you wouldn't want to add parameters to your constructors is whenever you're taking those variables that are inside your class and you want to set them equal to values initially. So that is basically why a constructor is useful. Whenever you have a bunch of variables in your class and you want to set them equal to values initially, that is how you can do that. So here's that example, and you just printed out our name. So simple enough. So aside from this, I guess I have time to show you this one thing. You might be thinking, alright, so I have an object from this Bucky class named BO, and its name is equal to Lucky Bucky Roberts. So does that mean later on, if I were to create another object from the Bucky class named like BO2, and I set this name equal to, what's even dumber than Lucky Bucky Roberts? Sally McSalad? That's what's on my mind right now. So does that mean that I'm gonna overwrite this one? Well, let's go ahead and print out bo2 dot get name, just like this. So let's go ahead and print it out and see what we get. Lucky Bucky Roberts and Sally McSalad. So what I want to stress is this. Whenever you create an object from a class, each object has its own set of variables. So this object, BO, name is Lucky Bucky Roberts. This object is named Sally McSalad. Even though they're from the same class, it's not like changing the same variables. So even though we set this BO2 equal to Sally McSalad, it didn't overwrite this. They're just from the same template pretty much. So anyways, what I wanted to stress is that you can create multiple objects from the same class and they don't overwrite each other. They're just assigned their each set of variables. Am I saying that right? They're each assigned a set of variables. So yeah, just wanted to stress that before you get into objects and classes more and you get confused. So anyways, that's just a little side note. Stick with constructors, and then once you're good with constructors, you're ready to move on to my next tutorial. But for now, thank you guys for watching, and remember, don't stick words into randomly middle of your program. And yeah, I guess I'll see you in the next video. What is going on, guys? It is Bucky and welcome to your 15th C++ tutorial. And in this tutorial I'm going to teach you guys how to separate your classes and actually add them in different files. So what programmers usually like to do is they like to separate their classes into separate files because it just makes it easier to work with and manage and edit later on. So once we have like a huge program with 100 classes, we don't want all of those classes in the same text file or else it'll just get way too huge. So what they like to do is separate it, and it makes it easier to work on, especially if you're working with a couple people. Maybe one person could work on each file at a time. So anyways, enough of me talking, let me show you guys how to do it. So we have a basic program right here, and we decided that it's time to add a new class. Well, in order to do that, go ahead and press File, New Class, and then we have a new pop-up box that pops up. The first thing we have to do is name our class, and I'm just going to name mine Burrito or something like that. And by default, a couple things are checked, and I don't like to have them checked. There's something called a destructor, and we're not going to deal with any of that yet. So uncheck virtual destructor and also has destructor. And another thing I like to do is I like to keep all my class files in the same directory as my main file. So by default, I think this is unchecked, and what you want to do is check it, and that way all of your files are going to be in the same directory or in the same folder as your main CPP file. So once all your settings look the same as mine, go ahead and press create, and what it's going to do, just go ahead and press yes, yes to that stuff. And what it's going to do is it's going to create a couple files for you. And you're saying, alright Bucky, what the heck is all this? I thought it was just going to give me a blank file. I was going to put my class in it and I was going to be good to go. Well, what we need to do is we create our class a little bit different than we were creating it in the last couple tutorials. We're going to be separating it into two files. So by default, CodeBlocks automatically created pretty much a template of the two files that we need. One is a .h and one is a .cpp. The .h is called the header file and the .cpp is called the C++ source file, and this is where we're going to be writing the code. So first of all, let me explain to you guys what the header file is. The header file is where we're going to be putting all of our classes function prototypes and variable declarations. So remember before I said that whenever you made a function, you could go ahead and prototype it above int main. Well, we're going to be putting all those prototypes in the header. You'll see later on. And aside from that, this .cpp file is where we're going to be actually building the functions themselves. So this is pretty much where all the titles go, and this is where all the bodies go. Basically, it's a little more in-depth than that, but that's a real basic summary. So the first thing that I like to do is get rid of this private and protected because we don't have any of those yet. And another thing that I like to do first off is see this .cpp file where we're saying, alright, how come you needed this using namespace and include in this CPP, but you don't in this CPP? Well, actually you do. So go ahead and copy that and paste it right in there. So again, both of these .cpps should have the same things, include IOStream and using namespace std. So once you have this pasted in your new Burrito CPP, you're going to be good to go. Another thing that you're going to see is this class has already built our constructor for us. Remember in the last tutorial I taught you guys how to build constructors, what they are, pretty much functions that get called automatically. Well, as you can see, this already builds the function prototype and starts building the function body for us. So by default, it just has a comment in it, and I don't even know if I told you guys what comments are, but they're pretty much just little notes that you could write to yourself, have no effect on the program. So let's go ahead and delete this, and before I start writing something in this function, I want to talk to you guys about this last thing that might confuse you guys. It's the colon, colon. What this double colon is it's called the binary scope resolution operator. So just remember that for your test. So that's the technical term. But what the point of it is it's basically saying that this function, which is called burrito because it's a constructor, because it's a constructor, is a member of the class burrito. So usually you're going to have this second one be a different name and this first one stay burrito. But anyways, it's basically saying that this function is a member of this class, and you use that with the two colons right there. If you didn't include those colons, then it wouldn't know what class this burrito was supposed to belong to, so it would give you a bunch of errors. But now, whenever you're making functions, make sure you have the class before it separated by two colons. Again, it's kind of weird seeing it first, but you'll get used to it. So aside from that, let's just go ahead and add something to the constructor. So remember, a constructor gets called automatically as soon as we create the object. So if we go ahead and just go ahead and type like, I am a banana or something like that, something incredibly stupid. So now let's go ahead and write end line. And now whenever we create an object from this class, it's going to print out I am a banana, spelt wrong, but hey, who cares? So before I go ahead and run this program, I want to talk to you guys about one more thing. You're saying, alright, Bucky, I understand how to do this, and it's not like I made C++ or anything, but just out of curiosity, why do you have to separate the .h and .cpp file? Why didn't the users, whoever made C++, just let you make it all in one file? Well, the reason behind that is this. Whenever you're gonna, give these functions to your friends to use, or maybe you're working on it with a team of programmers, or maybe you're just distributing this for sale on the internet. Well, you're going to want to compile this right here and change this all into ones and zeros. And what you're going to be giving the other programmers is this. And the reason you only give them basically the prototypes or the titles of the function is saying, alright, I already built all these functions. They work perfectly. You don't need to change it. All you need to do is to use the functions themselves. So again, whenever you're distributing this, this is going to get compiled and the programmers are going to have access to your functions, but they aren't going to be able to change the function bodies themselves. So anyways, that's a nice little background. You didn't really need to know that for this tutorial, just a nice, little tidbit of information. So that's why you split them up. So the last thing that you need to do is this. In order to use objects from different classes in our main CPP, we need to include the headers. So go ahead and just like your burrito.cpp included the header, we need to include the header right here as well. So now that we included the header, we can use objects from that class. So let's get rid of this cout hello world because we don't need it. So now that we have the constructor doing something, printing out I am banana, we can go ahead and build an object. In order to build an object, we just go ahead and type the class name and some object like BO, and it should be good to go. So let's go ahead and build and run this and see what happens. I am a banana. Simple enough. So to recap one last time, in order to make a new class, you go to File, New Class, you name your class, and make sure you check to have the header, which is this, and the implementation file in the same directory as this. So now what it did is it created all these files for us automatically. The only thing we needed to do is make sure that all of these includes and all of these includes were the same, and basically whenever we wanted to use this class in our main CPP, we needed to include the header. And what this header did is it basically included the whole class, and then we were able to use all the functions, variables, and all the stuff from that class. So I know this is a little weird at first because we're just looking at really small examples and they aren't really useful. They don't really tie together to make a full computer program. But later on, once we are building a full computer program, you'll begin to see why classes are useful, why a header is super beneficial, and why you actually do want your function bodies in a separate file. So again, these really small examples might be hard to see, but I just want to break it down easy for you guys so you understand the basics before we dive into something a lot bigger. So for now, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What is going on, guys? Welcome back to your 16th C++ tutorial, and in this lesson I want to talk to you guys about something called the if statement. Now the if statement is basically a simple way to have your computer program make a very simple decision. So before, when we were programming, we built simple programs and it pretty much just ran line after line after line of code without question. So that's nice and all, but sometimes you want to have your computer program make a simple choice. For example, you might have some code that you only want to run sometimes, and you're saying, alright, why would I even put it in there if I only want to run it sometimes? Well, for example, if you're making a website and you had a message on there that said, "Hello Bucky," well, you would only want to show that message whenever I logged in. You wouldn't want to show it whenever a guy named Tommy logged in or a girl named Jessica logged in. So you would say, if the user is Bucky, then say "Hello Bucky." So you can see that unlike before when we just built a program and you ran it from top to bottom, now we have different routes, different choices that our computer program can make. And the basic decision that each computer can make is made using the if statement. So the syntax for the if statement is incredibly simple. You go ahead and type the keyword if, and in between parentheses right after, you're going to give it a test. Now go ahead and add curly brackets, and if that test is true, then it's going to run the code, whatever you put in here. If it's not true, then it's not going to run the code. So you're going to say, alright, the test is the user Bucky? And the code would be, say "Hello Bucky" on the screen or something like that. So that's a basic example, but of course that isn't real code. So let's go ahead and make a real program that actually works. So what people typically do is they have a variable first of all. So let's go ahead and make int x and set it equal to 10. So now we have a variable equal to 10. They might want to test this to see, is this variable equal to 10? So go ahead and say if x, and now in order to make these simple tests, we use something called comparison operators. And when you're testing numbers, there are 6 different ways you can compare numbers. I know you think, is it equal or not equal? But there's a lot more. First of all, you can test, is x equal to 10? Is x not equal to 10? Is x less than 10, greater than 10, less than or equal to, or greater than or equal to? And let's go ahead and test it besides something other than 10. So we know x is equal to 10. If we want to test if it's the same as 10, we go ahead and write equal 10. And you're saying, alright, first of all, slow down. This doesn't make sense. Why would you not just write if x equals 10? Because that makes sense. Well, the single equal sign is, they already reserved that for setting a value equal to a variable. So if you did this right here, it would think that you were trying to set x equal to 10, and your program's not going to work right. So that's why whenever you're comparing a variable and a value, you need that double equal sign. So this means, alright, test if x is equal to 10, and if it is, let's just go ahead and give it something stupid. Cout OMG I am preggy. That means pregnant in ghetto talk. So let's go ahead and NL, and let's go ahead and run this and see what happens. Build and run, and on the screen it says OMG I am preggy. And why did it do this? Because we had a variable x and it was equal to 10, and then we said, alright, if x is equal to 10, then go ahead and print this out on the screen, and it was, so it printed it out. But if you had something like if x is equal to 87, now we try and build and run it, you see that our computer program didn't print it out because 10 is not equal to 87. So you're saying, alright, I know how to test whether a value is equal to a variable, but what if I want to test if they're not equal? I want to make sure that these values are not equal. Well, the sign for that is explanation point equal sign. This means, alright, if x is not equal to 87, print this out. And it's going to print it out because is 10 equal to 87? No, that doesn't even make sense. So it's going to go ahead and print that out. So that's why we get OMG, I am preggy. So aside from that, let me go over the basics, less than and greater than. If x is less than 87, is 10 less than 87? Yes. And by the way, whenever we have a test and that test is true, we say true. Whenever the test is wrong, we say false. So is 10 less than 87? Yes, 10 is less than 87, so we call this test true. And since it's true, it goes ahead and prints it out. OMG, I am preggy. Now let's go ahead and be like, is 10 greater than 87? No, 10 is not greater than 87, so that's why it didn't print it out right there. So aside from that, there are two other simple ones I want to go over with you guys. There is less than or equal to. So if you had something like, is 10 less than 10, and you just had a basic less sign, then you try to run it and it wouldn't work because 10 is not less than 10, 10 is the same as 10. Well, what if you want to test if a value is less than or equal to another variable? Well, we go ahead and we have our variable 10. Is it less than 10? Nope. Or is it equal to 10? Yes. So this is indeed going to print out OMG, I am preggy. And of course, there is greater than or equal to, but I'm not even going to show you an example because it's pretty self-explanatory what we have. So aside from testing a variable against a value, I just want to tell you guys that you can go ahead and test two variables such as 43. So now we're going to say, alright, is x greater than or equal to y, aka is 10 greater than or equal to 43? Let's go ahead and build and run that, and we see that 10 is not greater and it's not equal to 43. So we can test two variables, and we can even test two numbers, like is 5 greater or equal to 3? And we go ahead and run that, and we print out OMG, I am preggy. But this testing two values is the least common thing. People, I don't want to say always, but I've never seen it where people had two values in here. It's either one variable or two variables. If we go ahead and we just had this code right here, then it would make sense just to forget this whole if statement just like that. Unless you don't know how to compare numbers, then you would have a problem. Then you shouldn't even be watching this tutorial. But for now, I just wanted to talk to you guys about the if statement and how you can use it to make a basic decision. Again, technical terms, whenever your test is positive, we call that a true test. Whenever your test is negative and it doesn't make sense, we call that false. So the code inside the if block is only going to run when your test is true, as you just saw. And again, we have two equal signs for equals. Explanation point equals means not equals. Greater than, less than, greater than, equal to, less than, or equal to. So now you are pro with the if statement. So thank you guys for watching. Don't forget to subscribe, and yeah, see you in the next tutorial. What is going on, guys? Welcome back to your 17th C++ tutorial, and in this tutorial I'm going to be covering something called the if-else statement. Now let's go ahead and first I want to build a basic if statement because an if-else statement is pretty much like an enhanced if statement. So let's go ahead and use the knowledge or the information that we learned in the last tutorial and build on it. So let's go ahead and make a simple program. We have a variable called age, and go ahead and set it equal to whatever your age is. Now go ahead and make a basic if statement. Now if you remember from the last tutorial, all an if statement does is it runs a simple test. If that test is true, it runs a bit of code. If that test is false, it doesn't do anything. So let's go ahead and test age. Say if age is greater than 60, let's go ahead and say cout, wow, you are old. So if the user is over 60, let's go ahead and say you are old. And now let's go ahead and end that line, run this program, and see what we get. We get nothing, and that is because I'm 24, so this program does nothing. But you build this program, you show it to your boss, and you're like, hey, where's my raise? And they're like, wow, this program is impressive and all. However, wouldn't it be nice if we could give a message to the user no matter how old they are? What if instead of skipping this if the test is false, let's give them an alternative message like, if anyone's over 60, we're going to tell them they're old. If anyone is under 60, we're going to tell them, hey, get a job. So you're saying, alright, I suppose I could put another if statement and then write age is less than 60, but you know what? That isn't the best way to do things. I'm going to show you guys something called the if else statement. So the if statement basically ran a simple test. And if that test is true, it ran this bit of code. And if it was false, it did nothing. It skipped it. But now we want to say, alright, else, if the test is false, then we want to run this bit of code. So either way, it's going to run a bit of code either way. If it's true, it's going to run this bit of code. And let me just go ahead and copy that. If it's false, it's going to run this bit of code. But let's not put wow, you're old for either one. If they're under 60, let's go ahead and write you are young, get a job. So now when we go ahead and run our program, unlike before when it says alright, since this test isn't true, I'm just going to skip it. It says alright, this test isn't true, so what am I supposed to do if it's false? Well, I'm supposed to do the else. So let's go ahead and, enough of me talking, run it, and it says you are young, get a job. And of course, if the user is like 87, we run the program and they say, wow, you are old. So now you can see, instead of just having a basic if statement where it was either run a bit of code or do nothing, we now have the option of something happens for true and something happens for false. So now either way, your computer program is going to do something. So that is the basics of an if else statement. So now that you guys know that, let me go even deeper. I said that you can go ahead and run a line of code inside an if statement. Well, you can also run multiple lines of code just by putting them under each other. So if we go ahead and we copy this, we can go ahead and paste it, paste it, paste it. It doesn't matter. You can go ahead and run it 4 times as long as it's in between those braces right there. So we're saying, alright, what if I wanted to do something like this? What if not only I wanted to check if they were over 60, but if they were over 60, I wanted to check if they were over 100. So let's go ahead and do that. So what I want to teach you guys now is that inside if statements, instead of just running simple lines of code, you can also put additional if statements. This is called nesting if statements. So let's go ahead and say if, and remember, this code is only going to run if the user is over 60. So now we want to test if the user is over 100. And then we're going to write cout, why are you still alive? I know this is harsh, but hey, just trying to get the point across. So now let's go ahead and we'll run this bit of code right now. So our program is going to say this. Alright, if the age is over 60, which it is, I'm going to run this bit of code right here. And in this bit of code, I'm going to test if the user is over 100. Well, they're not over 100, but they are over 60, so nothing's going to happen. So we're going to run this, nothing's going to happen. But say our user was 178. Pretty old, huh? Well, we're going to say, alright, is your age over 60? Yes, so now go here. Is your age over 100? Yes, it is. So now run this bit of code right here. And we're going to go ahead and run it, and it's going to say, why are you still alive? Because, come on guys, let's face it. If you're 178 years old, you should be dead. Just saying. So now we begin to see how we can make complex tests and very complex programs. And I know that it's called nesting an if statement inside another if statement, but you can also nest an if else in here, and you can also nest another if in here. And what you can do is you can nest if inside of ifs as many times as you want. But say you wanted to test if the user was over 10, then over 20, then over 30, then over 40, then 50. Well, there's even a more simple way to do this than nesting 1,000 different ifs inside of each other. And I'll probably be teaching you that in the upcoming tutorials. But for now, what I want you guys to take away from this tutorial is, instead of a basic if statement where if the test is false, then it just skips the code, you can now add an else, and what this does is it gives it an alternative choice. And also, aside from that, you can also nest if inside other ifs. So that way you can basically test two things, and if two things are true, run a bit of code. So as long as you understand those concepts, you should be good to go. So for now, thank you guys for watching. Don't forget to subscribe. And yeah, if you have any questions, send me a message on my website, thenewboston.com, and I'll be glad to answer them for you. So thank you for watching. Don't forget to sub, and I will see you in the next tutorial. What is going on, guys? Welcome to your 18th C++ tutorial. And in this tutorial, I'm going to talk to you guys about a while loop. And if you're saying, alright, Bucky, take a step back. I don't even know what a loop is, and now you're trying to talk to me about a special kind of loop? Alright, let me step back. A loop is basically, in computer programming, if you want to take a certain bit of code and run it over and over and over again, you can go ahead and you can just type it on like 100 different lines and it will keep running. Or you can throw it in something called a loop. And what a loop does, it says, alright, write this code only one time, and I'm going to run it as many times as you want me to. So for example, instead of, say we wanted to print hello on the screen 100 times, instead of writing cout hello on 100 different lines, we can only write it on one line and loop it 100 times. So it's a much easier way to make pieces of code run multiple times. So let me show you guys an example. And by the way, now I can talk to you guys about a while loop. There are many different types of loops. A while loop is pretty much the most basic type of loop. In my opinion, it's the easiest. So that's why I'm showing this to you guys first. So let's go ahead and I'll show you guys an example. Go ahead and make a variable called bacon and set it equal to 0. The syntax for a while loop is this. We're going to say while, and then in the parentheses right after it, we're going to give it a test, just like the if statement. We're going to test if bacon is less than or equal to 5, go ahead and run this bit of code over and over again. So let's go ahead and just run cout bacon is, and then it'll say the value of bacon, and then end line. So now, if you were to go ahead and run this, you would say, alright, run it, bacon is 0, bacon is 0, bacon is 0, and you can see that it keeps printing it out over and over. By now, it probably printed it out like 20,000 times. So you're saying, alright, that's kind of useful, I guess, but wouldn't it be more useful if this loop would end? For example, if we only wanted to run it 20 times, how would we go about doing that? Well, sometimes people do want loops that never end, but typically they don't. Typically you want to only have this code run like 5 times or 10 times or 15 times. So how do we control exactly how many times it runs? Well, in order to do that, we usually add a line of code like this. Again, what this test is going to do is test, is bacon less than or equal to 5? And since the value is 0 right now, this test is always going to be true. So in order to make this test false and this loop to stop running, we need to change the value of bacon at some point. So it is equal to 5 or greater than 5. And in order to do that, go ahead and make bacon equals bacon plus 1. Now, each time we run the loop, it's going to go ahead and do its thing right here, and then when it's done, it's going to add 1 to the value of bacon. So the first time it runs, it's going to be 0, and then it's going to add 1 to it, so then it's going to be 1, then it's going to be 2, 3, 4, 5, and by the time it gets to 5, it's going to change it to 6 and not run. So let me go ahead and show you guys. Bacon is 0, 1, 2, 3, 4, 5. So we already know why bacon ran in this case. When bacon was equal to 0, it was less than or equal to 5. 1, yup. 2, yup. 3, 4, 5. Is 5 less than or equal to 5? Yup, so it printed that out. But then, whenever it said, alright, the value of bacon is 5, so I'm going to print out bacon is 5. And then I'm going to add 1 to bacon. So now bacon equals 6. Alright, let's try this loop again. Is 6 less than or equal to 5? No. Finally, the test is false, so I can quit running my dumb loop. So that is how you add, again, like I said, when okay, take a breath, Bucky. You're jumping too fast. Sometimes people want loops to run forever, and when they do, you would do something like the first example I told you. But typically, and I want to say like 95% of the time, people build loops that they only want to run a certain amount of times. For example, 5 times. If you only wanted to run it 5 times, or actually it was 6 in this case, you would add something called this line right here. And this pretty much just changes the value of bacon. So at some point, that test has to be false. If you wanted to run it 20 times, you would go ahead and just change that to 20 and check it out. Bacon is 1, 2, 3, 4, 5, all the way to 20. Pretty cool, huh? So you can change how often your loop runs by a couple things. Its starting point, its ending point, or how much you increment that value by. Again, you can add 3 to it each time if you want, and then you would get something like this. 1, add 3 to 4, 7, 10, 13, 16, 19, and when you added 3 to that and it was 22, well 22 is indeed not less than or equal to 20, so that's when it stopped the loop. So that is the basics of the while loop. Again, all a while loop does is take a certain bit of code and runs it over and over and over again until the test is false. And again, like I said at the very beginning of this tutorial, there are many different loops that allow you to take a bit of code and run it over and over and over again. A while loop is pretty much just the most basic kind. So make sure whenever building your while loops not to forget to change that value or your loop's going to run forever, and who wants that? So for now, thank you guys for watching. I'm actually going to go make some bacon right now. So you guys sit tight, rewatch this tutorial, and once you're good, once you understand the syntax of how a while loop works, you're ready to move on to my next video. So again, thank you. Don't forget to subscribe, and I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your 19th C++ tutorial. And you know what? All these nice little quick examples are fine and dandy, but let's go ahead and build a program that is actually somewhat useful, a program that you can use. And maybe your teacher assigned you something, or maybe your boss came to you and was like, you know what, Bucky, I want you to make a program that allows the user to enter 5 different numbers, and then I want you to total the numbers for them. But you have to use a while loop. So we're saying, alright, no problem. So here is how I would go about making this program. And by the way, this is some nice little programming tips. You start with the basics of your program and you do it in little baby steps. So first of all, I want to make a loop that runs 5 different times. So what I would do is make a loop int x, set this variable equal to 1. This is just going to be the looping variable. While x is less than or equal to 5, let's just go ahead and print out something to make sure our loop is working. Cout x end line. So that's going to print out x, and you know how I said that in order to add 1 to x each time, you go ahead and write x equals x plus 1. Well, you can do that, but let me let you guys in on a little secret. If you go ahead and write x plus plus, this is the exact same as writing x equals x plus 1. It's just a quicker and easier way to do things, and that's actually where the name C++ came from. They wanted it to be cute and, anyways, that's the history of C++. It came from an old language called C, and they added 2 little plus signs to it, thought it was cute. So anyways, that's your history of C, but what we're worried about is making sure that we have a working loop that runs 5 times. So let's go ahead and run this. So alright, 1, 2, 3, 4, 5. Our loop is working perfectly. We can now move on to the next step. And by the way, this was just a tester line. We don't really need that in our program. So we're saying, alright, our boss told us to make a program so the user can enter 5 different numbers. So we already know that the CIN is the way that the user can enter a number, but we probably need to store that number in a variable. So let's go ahead and store that number in a variable number. And since we don't know the value yet, we can't set that equal to anything yet. So what we would do in order to have the user enter a number 5 times is inside this loop, go ahead and write CIN number. Now our loop is going to run 5 times, and the user is going to enter a number each time before the program quits. So what I would do now is test the program again just to make sure it's working. Alright, 43, 54, 66, 2, and 3. Enter. Our program's done. So now we see not only do we got a loop that runs 5 times, but we also have the user enter 5 different numbers. So our program is working fine and dandy so far. So we're saying, alright, now what's the last thing he said? Oh yeah, he wanted to find a sum of all those numbers and print it out to the user or something. So we're saying, alright, now not only a number variable, but we need another variable to hold the sum or the total of all those numbers. So what I would do is go ahead and put int total, and by default their total is going to be 0 because they didn't enter any numbers yet. That's what we know. So now what we can do is this. You might be thinking this. So just go ahead and set total equal to number. But whenever we run this, it's not going to work because say they enter 10 the first time, where then total is equal to 10. Okay, it's working fine so far. But the next time they enter 8 and we were expecting 18. Well, this isn't being added to total. Total is now being changed to 8. So instead of being 18, it's just 8. So this isn't going to work. So what we need to do is do this. Total equals the old total plus the new number. So now what happens is this. Whenever they enter 10, it's going to be 0 plus 10. Total is equal to 10. The next time they enter 8, 8 equals number. So 10 plus 8 equals the new total of 18. So let's go ahead and once this loop is done running, let's go ahead and just give them a nice little printout on the screen. Your total is total, and might as well end that line. Why not? So let's go ahead and run this program, and now let's go ahead and run it and make sure it works. So let's go ahead and put 10, enter, 8, enter, 2, enter, 5, enter, 5, enter. Your total is 30. So alright, let's go review this one last time. It seems like everything is working fine. Let's just go ahead and make sure. Well, I guess I can cover that up. That says end line there. Now I'm covering it up. So basically, the first thing we did is we got a loop that worked. Then we wanted to have the user enter a number, and then we did something with that number. So what happened is this. The first time the user entered a number, it was 10. So the total, which was 0 before, is now equal to 0 plus 10. So now total equals 10. The next number they entered was 8. So now the new total is 10 plus 8, which was 18. The next number they entered was 2. So 18 plus 2, now total equals 20. Next number was 5, now it equals 25. The last one was 5 also, now it equals 30. So this is basically saying, alright, take the new value of total and set it equal to the old value plus the number that they entered. And at the end, we just said your total is 30. Works pretty good. So let's go ahead and just to make sure that it's working good, let's really test this. Add some big numbers like this. Why do I keep entering the same number each time? And that. So, okay, I'm not going to check this in my head, but you guys can go ahead and check that on a calculator. And if it works, then it means we just built the best calculator on earth. So I'm actually going to go ahead and copy this and email this to Microsoft, and hopefully they pay me, just a couple $1,000,000 for it. So you go ahead, and what I want to stress in this tutorial is this. Not only this is how you build a basic program to, it's just an example of why a while loop would be useful, but also whenever you're building programs, take it in baby steps. Do the most basic thing first, and then once you got that working, go on to the next step. And then once that working, you can go on to the final step. And now we can do something like maybe we can find the average of all these numbers, or maybe we can find the product or the quotient or something stupid. So again, take your program in baby steps. That way you don't try to build a whole program and then at the end when you got 10 different errors, you're saying, alright, what went wrong? So that is the basics of not only how to be a good programmer, but also how to use the while loop in a meaningful way. So for now, thank you guys for watching. Like I said, just going to go ahead, cut this, and paste it to Microsoft. And yeah, I'll see you in the next tutorial when I'm a millionaire. What's going on, guys? Welcome to your 20th tutorial. And in this tutorial, I'm going to be teaching you guys how to build a Sentinel controlled program. Now, let me explain to you guys what that is. You remember in the last tutorial where we built that program and we ran a loop 5 times, and each time we allowed the user to enter a number? Well, sometimes we're going to want to build programs where we don't know how many times the user wants to enter a number. So if you we're calculating the average grades for kids in your class, you know how many kids are in your class. If you were calculating the average age of people in your family, you know how many people in your family. But if we built a program and we just sold it to everyone in the world, everyone's family has a different size. Every teacher's class size is different, so we don't know exactly how long to make that loop last. So what we do instead is we give a special code, and this code is usually something like -1. And we use this because ages and weights and number of things cannot be -1. So whenever we enter -1, this is when our program knows to stop and make its calculations or do whatever it does. So let's go ahead, and I'm going to be building a program that we enter the ages of a bunch of people. How many, we don't know yet, but we're going to enter the ages of a bunch of people. What our program is going to do is figure out how many people we entered and calculate the average age of all those people. So let's go ahead, and it's pretty much an age averager. If I was to make this program, I would name it Age Averager 5.0. Why 5.0? I don't know, I just like 5. So let's go ahead, and we're going to need some variables. The first variable we need is someplace for the user to enter and store that age, each age at a time. So they're going to enter someone's age like 32. We're going to store it in the variable age. After this, we need some way to keep track of all of those ages a total. So if they enter 32, then 32. We want this to store the total, which would be 64, because we're going to be averaging it later on. So int, just name it like age total. And this, of course, is equal to 0 first, but it's going to be the total of everyone's age combined. And the third thing we need to keep track of is how many people did they enter. So you take the total over how many people they entered, and this gives us the average age. So int number of people entered. And I don't really like making variables that long because it's easy to make a typo the longer your variable is, but it's descriptive for this tutorial. So the first thing we want to do is just write a prompt on the screen. Cout enter first person's age or -1 to quit. So what we're going to be doing is our code is -1. Whenever we get the input -1 from the user, we know that they want to quit the program. So let's go ahead and then give them something to enter, age. So they're going to enter a number, and it's going to be stored in the variable age. So now we just need to test to make sure it's not equal to -1. And we need to loop this program as many times as possible as long as the value is not equal to -1. So as long as age is not equal to -1, go ahead and run this program. And at the heart of this program is this. What we're going to be doing is we're going to be taking that age total, and it's going to be a running total of the old age total plus the new value that they entered for age. So the first time, say they enter 6, it's going to be 0 plus 6. The next time they enter 10, it's going to be 6 plus 10, so the total would be 16. So then when we divide it by the number of people, which would be 2, their average age is 8. So let's go ahead, and now each time this loop runs, it means that they entered a new person. So let's go ahead and just write number of people entered plus plus, because remember, plus plus is the same as adding 1 to it each time. So now we said, alright, our age total is good and the number of people entered is good. So now every time we run this loop, we want to give them another opportunity to hit -1 or enter someone's age. So make another cout and just write something like enter next person's age or -1 to quit. So right now they're going to enter -1 or someone's age. And let's just go ahead and end that line. So now, semicolon, there we go. So now we're going to store that value in age. So they're going to keep running this, and every time it runs, they're going to have a chance to input an age. What this loop is going to do is check, and it's going to run the loop over and over and over and over again until the user enters -1. once they enter -1, it's going to say, alright, that's my sign to bail out of this loop and go ahead and make my calculations. So for calculations, let's first go ahead and make sure our program is going to work properly by saying, let's first tell them number of people entered. And I know I spelled that wrong. Big deal. Who cares? And now we just output number of people entered. Looks good. End line. And after this, what we want to do is we want to find the average age of all those people. So cout average age, and then we just go ahead, and the formula for average age is age total over number of people entered. For example, if your age total is 100 and you entered 10 people, then the average age would be 10. So let's go ahead and run this program first to see if it works, see if I forgot any semicolons or anything. Alright, so the program is up and running. It looks good. So what I like to do whenever I build programs like this is I like to enter values that I already can calculate in my head just to make sure that the computer is calculating. So let's go ahead and enter a person with the age of 10, the person with the age of 20, and a person with the age of 30. Now I know that whenever I average these together, 10, 20, and 30, well, that's 60. So 60 divided by 3 is 20. So I'm going to be expecting 20. And that way I know that my program's working correctly. So let's go ahead and quit by hitting -1 and go ahead and hit enter. And it says number of people entered 3, which is correct, 10, 20, and 30. Average age of them is 20 because 60 divided by 3 is 20. So that is pretty cool, and our program works fine. Number of people entered, it got that right, and it calculated their average age right. So that's what I like to do before I enter big numbers like 87, 68, 5, and all those. Like 5's a real big number. So anyways, how our program worked is this. What we did is we built 3 variables. Well, let me just go ahead and skip to the good stuff. It says, alright, enter the first person's age. And we went ahead and we entered 10 right here. So it says, alright, is 10 equal to -1? Nope. So let's go ahead and run this right here. I'm going to go ahead and store 10 in age total and change the number of people entered to 1. And now go ahead and give me another age. Well, we went ahead and we entered 20. So now 20 plus 10, our age total was now 30. And our number of people entered was 2. So it said, alright, give it to me again. We entered 30. So now our age total was 30 plus 30, which is 60, and number of people entered was 3. So then it said, alright, now give me another age, or -1 to quit. We gave it -1 to quit, so it bailed out of this loop, and it went ahead and just make the calculations. For this calculation, it just printed out the number of people entered, which was 3. And for this one, it said the age total, which was 60, divided by the number of people entered, which was of course 3. 60 over 3 is of course 20. So again, that is called a Sentinel control loop because we can run this program in, it doesn't matter how many numbers we enter. You know, we're not limited to 5 or 10 or anything. As soon as we hit -1, it calculates how many people we entered and their average age. So again, this is a much more dynamic program in the sense that you're not only limited to a certain number, but you can disperse this, you know, maybe a bunch of different types of people, and it doesn't matter their sample size. Any amount of people in this program is still going to continue to work fine. So that is the beauty of a Sentinel controlled program. These are the loops that you're going to be using more often rather than, you know, a fixed number. So get used to it, become familiar with it, and once you are, you're good to go. So for now, that's all I have for you guys. In the next tutorial, don't know what I'm going to be covering, but my throat is dry now, so I need to go get a drink of water, and you need to watch more of my videos or something. I don't know. So thank you guys for watching. Don't forget to subscribe, and I'll see you next time. What's going on, guys? Welcome to your 21st C++ tutorial. And before I even get started with this tutorial, I just want to mention one thing that you guys probably noticed already, and that is I don't have return 0 at the end of my main. And that is because I just found out that, well, let me say this. In the old C++ ways, you had to have that return 0 statement, but now the new version or whatever, whenever you don't include return 0 at the end of your main, C++ just assumes you return 0 after the last statement. So, if you go ahead and type your program, you can either put it if you're a, old school programmer, or you can not include it and it will just assume you have return 0. But for the rest of these tutorials, I'm going to exclude it, so, don't freak out that it isn't there. So anyways, let's go ahead and get to the heart of this tutorial, and that's assignment operators and increment operators. Now we already know, well, let's go ahead and get a variable first. Set x equal to 10. Looks good. So we already know we can do something like this. X plus equals 10, and this is basically the same as writing x equals x plus 10. So then whenever let me just go ahead and end this line and print it out, we go ahead and we get 20, just like that. So what it does is it takes this value, adds it to x, and sets it equal to the new x variable. So I already told you guys plus equals is a shortcut, but I also want to go over all of them so when you see them in programming you don't get confused. X, well, let's change this to 5. It's weird if they're the same number. So x minus equal 5 equals 10 minus 5, and assigns that to the new value of x. So let's go ahead and see that that is 5. Now if we go ahead and see multiplies equals, what this would do is do 10 times 5 and set it equal to 50. And the last one, without getting in the weird stuff, is divide equals 5. And this, of course, is 2. So what this does is it basically takes the old value of x, divides it by this value, and sets it equal to the new value of x. So aside from that, there's one more, and I rarely use it this way. I hate writing it like this, and I hate seeing other people write it like this because it's confusing. This is going to be a bad example because 10 divided by 5 is 2 with no remainder, so it'll be 0. But if we go ahead and throw like 3, something like this, what this does is it takes the old value of x, divides it by 3, and it stores the remainder in 1. So now x is going to be equal to 1. Right like that. So those are all your assignment operators: plus, minus, multiply, divide, and modulus, which is a remainder. So now whenever you come across them in programming, you'll understand what they mean. So now what I want to talk to you guys about is those increment operators. So let's go ahead and get a new value, 20. That's a little bit better. It's my favorite number. So you know how I told you guys that you could do something like this, x plus plus, and this was the same thing as adding 1 to x. Simple enough, right? Not exactly, because there are two different versions of this increment operator, and I'm going to show you the differences between both. So let's go ahead and see out x n line. Let's go ahead and run this and take a look at what happens. So our initial value of x was equal to 20, and then we ran this line of code and it printed 20, alright, and then we ran this line and it was equal to 21. Well, what the increment operator is doing, whenever you write variable with plus plus after it, it's going to go ahead and run this line of code, and then it's going to add 1 to that variable. So it runs this line of code, x is still 20, then when it gets done running, it assigns 21 to x, and then it runs this one. So that's why it was 20, 21. So if you're saying, alright, simple enough, what's the other version? The other version is this. Whenever the increment operator is before the variable, like plus plus x instead of x plus plus, what happens is you can see whenever we run the program, it goes 21, 21. So what this does before the variable is it adds 1 first, and then it runs the statement. So it adds 1 right here and then runs it. So right here, the value of x is getting set to 21, and then run it 21, still 21, 21. So it's basically, if your pluses are before the x, it's going to add 1 before it runs it. If your pluses are after the x, it's going to run the line of code and then add 1 to the variable. So if you're building a program and you're off by 1, maybe you're running a loop or something and you're always off by 1, chances are your pluses are on the wrong side, either this side or that side. So this is a common error, and it's actually something that people have a hard concept understanding. But just remember, where you add your pluses indicate when it's going to add 1, before or after the statement. And if you remember it like that, it'll be simple enough. So now you understand that you don't need to return 0. You understand all the assignment operators. That's actually kind of a tongue twister. Assignment operators, assignment operators, assignment operators. Got it. And now you understand increment operators, which is plus plus x and x plus plus. Oh, and one other thing, there's also minus minus x, and what this does, of course, is subtracts it, and x minus minus, but I don't need to show you guys that. So just remember those four different increment operators, all those assignment operators, and you don't need to return 0 anymore, and you'll be good to go. So thank you guys for watching my 21st tutorial. No idea what I'm going to cover in the next tutorial, but it's going to be sweet. So thank you guys again, and I will see you guys later. What's going on, guys? It is Bucky, and welcome to your 22nd C++ tutorial. And in this tutorial, I'm going to be talking to you guys about a different kind of loop than the while loop. This is called the for loop. Now, if you guys remember, a while loop was basically something that took a bit of code and ran it over and over and over again. This isn't only for while loop, but all loops do the exact same thing. They take a bit of code and they run it over and over and over again. The only difference is different loops, you have to set them up in different kinds of ways. So anyways, I already told you guys how to build a while loop. Simple enough. So now let's go ahead and take a look at the syntax for a for loop. And the first thing you need is the word for. Now after this you add parentheses. Now inside your parentheses, your for loop requires three pieces of information: a starting value, an ending value, and how much do you want to increment it by. For example, if we started at 10 and we ended at 20 and we wanted to increment it by 2, it would be 10, 12, 14, 16, 18, 20. So let's go ahead and build a simple loop that starts at 1, ends at 10, and it increments by 1. Pretty much 1 to 10, counting by ones. So the first thing we need is to initialize a variable. So int x equals 1. Now every piece of information you separate it with a semicolon. Now after this, it's pretty much the same as the test in the while loop. How long do you want to let your loop run? Well, let our loop run as long as x is less than 10. So it's going to go from 1 to 9, because remember, when it gets to 10, 10 is not less than 10. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. But how does it know to go 1 at a time instead of 2 at a time or 5 at a time? Well, that's that last piece of information that this loop needs. X plus plus, and if you remember from the last tutorial, this means add 1 to x every time. You can also do x plus equals 1, but x plus plus is a lot easier. It saves you one character and, only two different characters. But anyways, I'm rambling. Enough of me talking. So basically, the syntax for a for loop is this: initialize a variable with a starting value, give it an ending value, and say how much you want to increment it by each time. So now we would just do something like this: cout, print out x on the screen, and print it out on a new line every time. So let's go ahead and build and run this and see what we get. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we started at 1, and we ran the loop the whole time as long as x was less than 10. So that's why 10 isn't printed out, because 10 is not less than 10, but all these values are. And since we wrote x plus plus, it went by 1 each time. 1, 2, 3, 4, 5. Kept adding 1 until we got to 9. So now, let me go ahead and show you different, we'll just add some different values so you guys can clearly see. Instead of 1, let's start at 5. By the way, 0 and 1 are going to be your most basic starting points. But, you can use anything you want, but people typically stick with 0 or 1. Let's go all the way to 50, and let's go ahead and increment it by 5 by writing x plus equals 5, which means add 5 to x each time and assign that to the new value. So now if you go ahead and build and run this, we go ahead and we have 5 all the way to 45 by 5s, and we start at 5 right here. Well, all the way till we were less than 50, and that's why it doesn't print out 50, because 50 is not less than 50, it's equal to 50, but 45 and all these values are less than 50, and we told it to add 5 to x each time. Simple enough. So basically, starting point, ending point, how much you want it to change each time. So now, those are, the basic Bucky terms, but if you're taking a test, I want to give you guys the technical terms. This is called initialization, where you start off a variable. This is called the loop continuation condition, basically when you're on the end. And this is called the increment. So with those three things, it has all the information that your loop needs: where to start, where to end, how much to go by. So this is a really basic example of the for loop. All we did is print out numbers and we didn't really do anything useful except learn the for loop. So in the next tutorial, I'm going to be showing you guys an example of why the for loop, it's basically this. I'm going to show you guys the for loop in a cool program, and I'm going to show you guys how it's going to be used to do stuff like calculate how much money you can make in the stock market. So if you don't know what I'm talking about yet, just check out my next tutorial because it's going to be awesome and we're going to be building a super cool program. So thank you guys for watching. Don't forget to subscribe and I'll see you guys next video. What is going on, guys? It's Bucky and welcome to your 23rd tutorial. And in this tutorial I'm going to be building a simple program and I'm going to be using the for loop, and I'm just going to be using it to show you guys that it is actually useful outside of just showing you guys examples. So what we're going to be doing is we're going to start with $10,000 and we're going to invest in the stock market, and we're smart enough to earn 1% each day on our money. So at the end of 20 or 30 days, how much money did we make? So, it's a little funner program than what we've been programming before. It's a little cooler, a little break from just basic examples. So before I get started, I want to mention this. In our formula for calculating interest rate, we need to use a function called power, and that's included in the CMath library. So make sure you include this before you get started in this tutorial. So let's go ahead and get down to it. Now we're going to be calculating interest rates and stuff like that. So we're going to be needing to work with decimal points like 0.01, 0.02 for 2%. But we already know int. So can we use integers when working with decimal points like this? No, we can't. Int is for whole numbers only, like 98, 4, 54. Int is for whole numbers without a decimal place. So in order to use a decimal place, we need to have a new type of variable, and that's called float. Float is basically the data type that allows you to work with decimal places. There are a couple different ones, but this is one of them, one of the most popular ones. So let's go ahead and make a variable called a, and this is going to be the amount we're trying to figure out. How much money did we make? The next variable we need is called principal. So float p equals your principal amount. In everyday terms, how much money did you invest? How much money did you start with? Well, say we just had $10,000 laying around, so let's go ahead and start with that. I wish I had $10,000 around, but hey, we can dream, can't we? So now, let's go ahead and say this. Our last variable is rate, so I'm going to set it equal to r, and that's how much interest do you want to earn each day. And let's say we can earn 1% each day, and that's 0.01. If you had 2%, it would be 0.02. Make sure not to put 2 or 1 for this. You need 0.01, or else it's not going to work. So let's go ahead and use the for loop to run through each day. So what this is going to be doing is looping through each day one by one. 1, 2, 3, 4, 5, 6, 7 days, and each day is going to give us a dollar amount. How much money did we earn that day at 1%? So of course the for loop is going to loop through days. Let's go ahead and make a variable called day, int day, and we'll start at day 1, obviously, and the next parameter it needs is how long do you want to invest your money for. So let's say 20 days. So day is less than or equal to 20 days. And of course day plus plus, because one day at a time. We're not skipping any days and we're not taking any vacation time here. So now the formula for interest rate is this. The amount of money that you earned is equal to the principal amount times, and in parentheses put this, actually no, not yet, the principal amount times the power, and this is where you put parentheses, 1 plus the rate, and this would be, let me go ahead and type this out. I can't talk and tell you guys financial formulas at the same time. The formula for calculating interest rate is this. The amount of money you're going to make is equal to your principal investment times 1 plus rate, and the rate would be 0.01 in this case, to the day exponent. So it would be like 1%, 1.01% to the 20th power. So I mean, it's a weird formula, but that's how you calculate it. Just trust me, it works. So anyways, now what we have to do is just print out on the screen how much money we're going to make. So let's give it a nice little print thing. Let's go ahead and print the day first. And then just want to give it a nice little spacer here. There we go. and then we go ahead and write A. A is the amount of money that we're making, and then go ahead and we'll print this on a new line each time. So let's go ahead and run it, and you'll see what I'm talking about whenever I run it. So here is the day to the left, 1 through 20. We start off, and at the end of the first day, if we invest $10,000 at 1%, we earn $100 at the end of that first day. At the end of the ninth day, we almost earned $11,000. If we invested $10,000 and we earned 1% each day for 20 days, at the end of your 20th day, you would earn over $12,000. Well, you would actually earn $2,000, but calculating the money you already had in there, you would have over $12,000. That's pretty sweet, huh? So now you know why everyone wants to get in stock trading, because basically by just sitting at your computer and clicking buttons, making trades, you can earn $2,000 in 20 days. Pretty sweet, huh? So since you know this is fake money and we're just dreaming, let's say that we were a genius like Warren Buffett or Bill Gates, and we were smart enough to earn 3% each day. And let's say we invested this for 30 days. So go ahead and let me run this. Oh mama, check this out. If you invest in money for 30 days and you earn just 3% on your money each day, at the end of 30 days or 1 month, you would over double your money. You would have $24,000 and more, and enough to go out to Taco Bell. So that is pretty sweet, and this makes me second guess my career as a computer programmer and kind of makes me want to get in the stock market. But by the way, before you guys get into the stock market, earning 3% a year would be good nowadays. Earning 3% a day is virtually impossible unless you're like Warren Buffett. So anyways, there is your tutorial on a useful way to use the for loop in program, and also, you know, some financial advice too, the formula for APR. So there you go, and I hope you guys learned at least something from this tutorial, and hopefully I didn't get you addicted to the stock market, because hey, we got more C++ to learn, guys. So thank you guys for watching. Don't forget to subscribe, and yeah, I'll see you guys later. What is going on, guys? It's Bucky, and welcome to your 24th tutorial in C++. And in this tutorial, we're going to be covering the do while loop. But you guys probably already knew that, because I got a feeling that the title is right above this video. And you know what else I do a lot? I tell you guys, this is probably going to be a short video, and I just realized that the time is right under the video. So I don't know why I say those things, but it's habit. I'm going to continue to say those things, so get over it. So anyways, we're going to be covering the do while loop in this tutorial. And if you remember from, I don't know, however many tutorials those go, I talked to you guys about the while loop. And the while loop was basically a loop that you had a test, and if that test was true, then you ran a bit of code inside. While the do while loop is basically the while loop flipped upside down. What the do while loop does is it runs the bit of code first, and then it runs the test. So let's go ahead and let me show it to you guys, and you guys will understand better what it means. Let's go ahead and get a counting variable called x and set it equal to 1. This is our starting point. Now the syntax for a do while loop is do, and then you go ahead and add some code in the body. So let's just go ahead and print out x. And then after this, we need to increment x, or else the loop's going to run forever. So x plus plus. And now after the body, immediately after it, you write while. And then after this, you have your test ended with a semicolon. A lot of people forget that semicolon, because in basic while loop, there is no semicolon if it's not in the body. So don't forget to put this semicolon right here. So let's give it a simple test like x is less than 10. Now go ahead and run this and check it out. Just like the while loop, it ran the same bit of code, printed out x on the screen, from 1 all the way to 9. Pretty cool, huh? So we're saying, alright, a couple of things are kind of weird here. First of all, why is this loop even useful? Because it seems like a bad while loop, because isn't the point of a loop to run the test first? And if the test is true, then run the bit of code. But if it's false, then don't run the bit of code. Well, people use do loop mainly for this reason. Whenever you have code in here and you need it to run at least one time, it's guaranteed to run at least that one time. And the reason is this. Say you have a test that is false, like 99. Well, this test is going to come false as soon as it hits it. 99 is not less than 10. 99 is a whole lot bigger than 10. So whenever you run this, it's just going to print out 99. So as you can see, it ensures that you run your code at least one time before testing it at all. So no matter what this value is, it's going to do it one time and then test it. So whenever you want to run your code, guarantee that it runs at least one time. This is what you do. So that's the main reason that people use a do while loop, to ensure their code runs at least one time. Again, if you have a basic program and you just want to loop it normally, your best bet is to run the while loop or the for loop, because those are your basic loops where you test it, and then depending on the test, you run your program. So again, this is basically a weird kind of loop. This is probably the most uncommon loop, but whenever you come across it, I wanted you guys to pick up on it, understand what it's doing, and why some people prefer it over the while loop. So now that you have knowledge of the do while loop, and you guys know that it's really not that common in programming, so you don't want to use it that often, you at least know what it does and how it, I was going to say how it worked. Well, yeah, that makes sense, and how it works. So anyways, that's all I have to cover for the do while loop. Pretty simple, basically a while loop flipped upside down. So thank you guys for watching. Don't forget to subscribe, and yep, I'll see you in the next video. What is going on, guys? Welcome to your 25th C++ tutorial, and in this tutorial, I'm going to be talking to you guys about a really cool feature of C++, not only C++, this is basically in all computer programming languages, but it's called the switch statement. And the switch statement in your computer programming career is going to save you a whole lot of time and headaches. So let me give you guys an example of when you would use this. Say you have a variable like age, and you want to test the age of a user, and you had a bunch of different like statements you wanted to print out depending on how old they were. So if they were 16, you would say, congratulations, here's a new car, since you can drive now. If they were 18, you would say, go buy a lottery ticket. If they were 21, you would say, go buy some beer. So you have all these different values that you could apply to the same variable. So with our knowledge so far, we can build a program like this doing this. If age equals 16, let's go ahead and type our body, and then after this, if age equals this, yada yada, if age equals that, and that, and that. Well, all those if statements are getting pretty old, so wouldn't it be cool if we could combine this all in kind of a compact statement? Well, it would be cool, but unfortunately we can't. So on with the next tutorial. In the next tutorial, I'm just kidding, we actually can do this, and that is through the use of something called a switch statement. Now, in order to use a switch statement, here is what you do. Type the word switch. Now in parentheses right after that, write the variable that you want to test. Well, we want to test the value of age, so go ahead and type age right in there. Now after this, go ahead and add the body to your switch statement. Now inside your body, you're going to give it all the values which you think age is equal to. And we're going to be giving it in the form of cases. So pretty much we're saying this. In case they enter 16, but don't write in case, it's only case. So in the case of 16, and then write a colon. Now after this colon, you write whatever statements you want your computer program to perform, or computer program to perform. You're the computer programmer, this is computer programming. There, I got it straight in my brain. So in case the value of age equals 16, let's just go ahead and print something stupid out on the screen like cout, hey, you can drive now. And go ahead and end line, why not? And after this, add a keyword that says break. Now, I'm going to be talking about break later on because it's easier if I make the whole program first before I talk about it. Now after this, we can write something like, alright, what if the case is 18? Then what are we going to print out then? Cout on the screen, go buy some lotto tickets, because you can do that at 18. Now end line, and of course after this, add that break statement that we don't know what it does yet, but we will. And let's go ahead and give it one more case, why not? In the case of 21, the best one, let's go ahead and cout, buy me some beer. And go ahead and end that line. So now you can see, through the use of this switch statement, it basically saved us the trouble and the time of making a bunch of different if statements. So instead of 3 different if statements three different if statements, we only had one switch, and we just tested a bunch of different cases. So the last thing is default. And what default means is if none of these cases were true, if they entered a value like 2 or something like that, it ran through all these cases. Was it equal to 16? Nope. 18? Nope. 21? Nope. So what do you want me to perform by default? And of course, you don't need like default 2 because it doesn't have a value. It just, if all of these values failed, then what do you want me to do by default? By default, we'll just write cout, sorry, you get nothing, because 16, 18, and 21, that's where the important stuff happens. Everything else is just a birthday. So let's go ahead and end that line. And one thing you might notice, whenever you build and run this, you're saying, alright, sorry you get nothing because you're 2, but before you go ahead and build and run this, why didn't I add a break at the end of default, and what exactly is break? Well, this break keyword right here pretty much means end the switch. So you're saying, alright, why would I want to end it? Why doesn't it just keep going through the rest of the stuff? Well, the reason you had break after each case is because of this. Say you had 16 and you wanted to test it. We know that whenever it ran, it printed out, hey, you can drive now, and that's because we tested age, and age is equal to 16. So in our first case, it say, hey, this is a match. Let's go ahead and run this bit of code right here. So since we got a match in our first case, there's no need to test this one, and we're not going to run the default because this is the only one we want to run right here. So what break says is break this switch. It pretty much saves your program the trouble of having to run through the rest of these cases because it's not going to be useful to run through the rest of them as soon as you found a match. So let's go ahead and say we had 18 in there. What we would do is it runs it and it prints out, go buy some lotto tickets. Since we have that break in there, it did this. Alright, in the case of 16, nope, you're 18. In the case of 18, bingo, we have a match. So let's go ahead and print out go buy some lotto tickets and break out of this loop. So no need to test 21 and no need to use the default. Since we broke out of it, we found our match. So again, what break does is it basically saves you from going through the rest of the loop. And why do I not have one at the end of default? Because by the time we get to the end of default, it's at the end of the switch anyways, so why would you need to break out of it if you're just going to exit out of it after the default anyways? So that is basically a switch statement. It basically takes a variable and tests the value against each one of its cases. 16, 18, 21. If it isn't any of those values, it runs the default. Now I have 3 cases in this example, but you can have 1, you can have 1,000, you can have 1,000,000 if you want. And yeah, that's all. So anyways, that is how a switch works, and that is what break is. And I just want to mention one more thing before I let you guys go. Break, I'm using it in this example of a switch, but it's a keyword that we're going to be coming across a lot in C++ programming, not only with switch. So whenever you see it later on, whenever we're doing, just regular loops or something, I just want to let you guys know it isn't only limited to the switch statement. We can actually use this all throughout C++. So whenever we come across it, they'll be like, hey, isn't a switch supposed to go around that? Because we're not. So for now, thank you guys for watching. Understand the switch, and once you do, you're ready to move on to my next video. So like I said, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What is going on, guys? It's Bucky, and welcome to your 26th tutorial in C++. In this tutorial, I'm going to be talking to you guys about something called logical operators. Now, let me go ahead and build a simple program right now. Say we were the owner of a nightclub, and we wanted to calculate whether a person was allowed in or whether they weren't. So first we looked at their age, and we're going to make sure it's, over 21. Because we don't want to get sued. And the next thing we're going to be looking at is how much money they have, because we don't want to allow poor people into our, 5-star nightclub. So let's say they need more than $500. So let's go ahead and make this like person has $650. So we can test this like this. If age is greater than 21 and if money is greater than what I say 500, where would I just hit insert? Where the heck's my insert key on this keyboard? This keyboard is really messed up now that I look about it. So That took me like 5 minutes to find the insert. It was actually by my up and down arrows. That's weird. So anyways, now that we had our nice little break, we can go ahead and just write something like C out, you are allowed in, and make sure you spell it with a 9 in U, and make sure you spell in ion, or else this program just won't work. So let's go ahead and run this and see what we get. We are allowed in because we indeed are greater than 21, and we have more than $500. So you're saying, alright, pretty cool program. Maybe I'll open up a nightclub now, but check this out. This can get kind of confusing after a while because this brace goes to this and this goes to this. We're pretty easily distinguishable, but what if we had 5 different tests that we need to check? What if we had 20 different tests? Well, one little mistake, say we had this over here, our program's still going to run fine, but it looks like this goes to this and this goes to main or something. Who knows where this one goes? I mean, putting a bunch of if statements inside other if statements is not always the best idea. So we have a better way to test 2 or more things, and that's through the use of something called logical operators. And this allows you to make all your tests on a single line. So here's what we can do in this case. Go ahead and make your if statement, and then might as well make our C out right now, like you are allowed in, exclamation point with an end line. And in our if statement, go ahead and write your 2 tests, like what do you put? Age is greater than 21, and whenever you join them, you use this logical operator and. And now go ahead and write money is greater than 500. Now let's go ahead and run this and check it out. Same results, a whole lot less programming. So what and means, do this test and do this test. If they're both true, then run this bit of code. And since they both were true, it ran this bit of code. If one of them was false, say we only had, $4, like that, well, yeah, this test is going to be true because we're greater than 21, but this is going to be false because $4 is not greater than 500. And whenever we run it, we are not allowed in. Check it out. And also, if both the tests are false, like we're only 2, and oops, wrong space for that. Say we're only 2 years old and we only have $4, probably from the Tooth Fairy. Of course, we are not going to be allowed in the club. Not cool, but we're a 2-year-old. Who needs to go clubbing when they're 2 anyways? So basically, a double and sign means this: test all these tests, and if they're both true, then you can run this bit of code. But if one of them is false, or both of them is false, then we don't run it. Simple enough, huh? And I say and with this test and this test, but you can also have and in another test, and even and in another test, and it's just going to run all of your tests and make sure that they're all true. So the only way this bit of code is going to run is if all your tests in this is true. So if you're saying, alright, I understand that logical operator, all the tests need to be true in order to run. But what if you say this: alright, I'm, not the most professional nightclub owner, so I'm going to allow them in if only one of these tests is true. If they're over 21, then they're allowed in, of course. Or if they have over $500, I'm going to allow them in because, if a 20-year-old walks in with like 8 grand, I know he's not 21, but I think we should let him in anyways. So say we want to do that. Make sure only one of the tests is true. What we do is use a logical operator called the OR logical operator, and that's if you see above the enter key on your keyboard and hold shift, you get these 2 little things. I call them pipes, but I think some people call them pipelines. Tell you the truth, I don't know what they're called. It's like a straight line up and down, as you can see. But that's what it is, and 2 of them in a row is the OR logical operator. And what the OR logical operator says is this: unlike the AND, where this one and this one had to be true, only one of them has to be true and the other one can be false, and it still runs the bit of code. So check this out. We passed this test as true, 26 is greater than 21, but we don't have more than $500, so this is going to be false. So true and false. So we run it, and it allows us in even though one of these was false. But if both of these were false, say we were only 6 years old, it wouldn't allow us in. So anyways, what you have to remember is this: the AND logical operator, both the tests have to be true. With the OR logical operator, one of the tests have to be true. And another thing, if both of the tests are true in an OR, it's going to run your bit of code. So let's say you were, 64 and you had, a crap load of money. It would run, and even though they're both true, it would allow you in anyway. So with the OR, this one, or this one, or both of them have to be true. And with the AND, this one and this one has to be true. And of course, you can add another OR, test, and another OR, test, and another OR, test. And when you run a program like this, it's going to run through all of your tests. And as long as one of them is true, for example, this one could be true, and all these other ones could be false, and it will still run this bit of code. An OR basically means look for at least one that's true, and if it's true, run the bit of code. So now that I repeated that about 800 times, you guys should understand the difference between an AND and an OR logical operator and when you would want to use one versus the other. I guess it depends on what kind of nightclub owner you want to be. But for now, that's all the club on I'm going to do. So thank you guys for watching this tutorial. Don't know what I'm going to cover in the next tutorial, but if you click on the next link, you can see. So thank you guys for watching, and I'll see you then. What is going on, guys? It's Bucky, and welcome back to your 27th C++ tutorial. And this tutorial is actually going to be a pretty fun one because we're going to be talking about random numbers, what they are, a couple functions that are going to help us build random number generators, and I'm actually going to teach you guys how to build a sweet random number generator. So before we get into that, we need to include a header file. So include, and the header file is called CSTDLIB from the C standard library, and we include this because we want to use a function from it called rand, not rund, rand. And what this does is whenever you call this, it basically returns to you a random number. So let's run it, and we got 41 in this case. So as you can see, whenever we print out rand, it pretty much takes a random number and gives it to you. So you're saying, wow, there you go, there's our random number generator, perfect. Well, there are actually a couple problems with rand, and we're going to be talking about those later on. But for now, I want to show you guys how to build a basic random number generator. And let's go ahead and just call rand like 25 times. So let's go ahead and make a for loop, and go ahead and make int x set equal to 1, and make x is less than 25, and of course x plus plus. So now we have a loop that's going to run 25 times or sometime around that. So now let's just go ahead and see out let's just go ahead and see out rand and see what happens. And then might as well end that line so it looks nice and pretty. Let's go ahead and print it and see what we get. Okay, so it looks like we're getting a huge list of random numbers. Alright, looks pretty good. But what if I'm going to build a random number generator and I don't want numbers quite this big in tens and thousands and stuff like that. Say we're building a random number generator to simulate people rolling dice or something. Well, I only want the numbers 1 to 6. So here's a neat little trick where you can get that result set. In order to get a certain set of numbers, go ahead and take your rand and put modulus 6. What this is going to do is it's going to give you 6 random numbers. It's going to take a big number like 25,000 or something, divide it by 6 and give you the remainder of that. So the remainder, whenever you divide by 6, can either be 0, 1, 2, 3, 4, or 5. So let's go ahead and take a look at that. Whenever you divide by 6, you're limited to only the number 0, 1, 2, 3, 4, and 5. You can't have 6 as a remainder because anything divided by 6 with 6 remainder, it would just be another 1. So you can say, alright, well, I'm trying to simulate a dice here, and they have the numbers 1 through 6, not 0 through 5. So we got 6 numbers, but we don't want 0 through 5. We want 1 through 6. So, Bucky, can you just show me how to take all these numbers and shift them, add 1 to them? Well, that is very simple. Just go ahead and surround your rand 6 and just put 1 plus. Now, what this is going to do is it's going to take a random number, divide it by 6, and whatever the remainder is, which would be 0 through 5, it would add 1 to it. So now you're getting 1 to 6. So now you can see that 0 is eliminated, and we have 6 now. So 1, 2, let me find a 3, 4, 5, and 6. So that is how you build a random number generator using, a specific result set. So remember, however many numbers you want, you put as a modulus of rand, and however many you want to shift it by, just add that many to it. But let's go ahead and take a little closer look at this random number generator. Okay, let's read these numbers. 565115. Okay, they look like, they're pretty random to me. Let's go ahead and run it again. 565115. That seems kind of familiar. Let's go ahead and run this one more time. 565115. Alright. What's going on with our random generator? We built this program perfectly, which we did. So, we use random. Alright, everything's good to go. So, what's the deal? Why did it give us the same numbers every time? Well, in order to understand this, I need to talk to you guys about computers and random numbers. Now listen very closely because this is actually pretty important. No computer random number generator is truly random. The truth is that computers are not humans. Computers have to follow a certain algorithm, a certain set of instructions, a certain pattern. So for example, whenever you go into a casino and you see those automated slot machines and it looks like people are just spinning and it's giving them random numbers, well, the truth is that it's not actually giving them truly random numbers. Those slot machines, even though they're supposed to be a random number generator, they have to follow a certain algorithm, a certain pattern. And whenever you're looking at like game shows or whenever you buy an electronic and it flashes like random lights, well, those lights are not random either. Everything in electronics that is supposed to be random is not random. It's a computer. It has to follow a complex algorithm and a complex pattern. Now, the reason that these are so complex is that's what gives the appearance that it's random to humans. We don't understand this algorithm right away. Only the computer does. So whenever we see numbers like this, 5651156, those are random numbers to us, but the computer, it's really just following a big algorithm. So if you're saying, alright, so whenever we're building games and stuff, we don't want our numbers to be predictable. So what can we do in order to change that algorithm a little bit? Well, let's go ahead and let me include another, well, I won't do this yet, but the rand function right here runs on a very complex algorithm, and I don't know what the algorithm is, and I don't think many people do, but it's basically a large function that that humans aren't meant to understand. So what C++, the developers allowed us to do, is seed a random number, and you use that in a function called srand. Now what this function does is it allows us to pass in a random number, any number we want, like 67, and now whenever we build it, we get different results. 621616. Now let's go ahead and pass in another one like 215, and now we get 41311 or whatever. So whenever we seed a random number, we throw any old random number in there, and it changes the algorithm. So now I don't even know what happens when I type in 43. I get truly random numbers. So if you're saying, alright, so let's go ahead and put 43 in there every time, and we get 44151. Okay, now let's run it again. 44151. OMG, Bucky, what are you doing? All you did is you changed the algorithm a little bit, and we didn't really make it a truly random number generator. We just gave it a different algorithm to follow. Well, alright. I'll show you guys one last trick, and in order to do this, we need to include another header file. Include, and this is called ctime. And what this does is it allows us to access the clock or the time in our computer. And now let's go ahead and pass in a function called time. And as a parameter of time, not time, go ahead and pass in 0. Now let's go ahead and run this and see what happens before I explain it. Okay, 2522. Okay, let's run it again. 4614. Sweet. And one more time. 54646. So now we have a random number generator that works perfectly. So now let me tell you guys why. We know that we can use srand to change the algorithm a little bit, but if we just threw the same number in here every time, it would just have a different algorithm but with the same results every time. So what time 0 does is time 0 calculates the seconds since like 1970 or something, And what this does is every second this value is changing. So now it might be a million seconds, now a million and one, now a million and two. People don't have access to how many seconds are, counting since 1970. So this gives the appearance that this number generator is truly random now. So this value is ever changing, and that's why every single time we run our program, we're going to get a different result. So that is how people build random number generators that are is truly random, or they're not truly random, but they're as random as we can make them. So again, what we did is, here's the algorithm. All RAND does is it runs a complex algorithm. SRAND allows us to throw a number in there to change the algorithm a little bit, and time zero counts the number of seconds, and this value is changing every single second. So that's why, since this value is changing, this whole algorithm is changing every single second, and that allows us to make a truly random number generator. So there you go. I hope you guys enjoyed this tutorial. Thank you guys for watching, and don't forget to include your header files, because you can't use this program without it. And there you go. I'll see you guys next time. What is going on, guys? Welcome to your 28th C++ tutorial, and in this tutorial, as you can see, I'm going to talk to you guys about something called default arguments. So of course we're going to be building a function that takes a couple arguments, and a default argument is basically exactly what it sounds like. You know how we can have a function to like calculate the area of something, and then the user would need to enter arguments like length and another value for width. Well, they can either enter the values explicitly, or we can have a default value already in that function. So let me go ahead and we'll build a really basic function here just to demonstrate this point. So let's go ahead and calculate the volume of just something, a box or something. And so we have three arguments, or three parameters: int length, int width, and int height. So we can go ahead and make this function right now, and well, let's actually go ahead and make this function right now. Go ahead and copy this, and under main, make sure you're not in main when you make this. Go ahead and paste it, and to calculate the volume, in case you don't know, it's just length times width times height. So now we can go ahead and call this function cout volume, and the user can enter three values like 4, 5, and 5. So this should go ahead and print out 100, because 4 times 5 is 20, 20 times 5 is 100. So the volume of this box is 100. So alright, we have, just a regular function here with three values, or three parameters that it takes, and the user goes ahead and passes in those values, and it calculates it perfectly. But in order to add default arguments or default parameters, here's what you do. In your function prototype right here, instead of just having, the variable type and a variable, you can go ahead and set these equal to something automatically, like 1. We'll just set them equal to 1 right now. So if a box is 1 by 1 by 1, we can go ahead and assume that, well, it's basically this. If the user doesn't enter any values explicitly, then it's going to use those default values of 1, 1, and 1. So whenever we call this function without any values, check it out. It gives us the value of 1, because a box 1 by 1 by 1 has a volume of 1. Now let's go ahead and say that the user enters a number like 5. Okay, so the user enters a number like 5, and it gives us the value of 5. But you're saying, alright, so does that function use that 5 for length, width, or height? Well, when a user enters one value and you have a function that has three default values, the computer is automatically going to assume that you meant 5 equals the first parameter, or 5 for length. So if we go ahead and run this again, we get 5. That's because it's 5 by 1 by 1. So if you go ahead and enter something like 5 and 6, the user's automatically gonna, the computer is gonna assume that you meant 5 for length, 6 for width, and by default height was 1. So the only thing you're really overwriting is length and width. So it's basically, the rule is this: you can have a function that has default values, and by default it's going to use those values unless the user overwrites it with values of its own. Whenever the user does overwrite it with values of its own, it's going to pass them in order of which it received them. So if it passes in one number, it's going to replace the default value for that number. If you pass it in two numbers, it's going to replace the second value for that number right there. And if you just pass it in two numbers, it's going to, of course, keep that same default value of 1 for the last one. So you get 30 for your value. So, of course, I just want to point out that you can, go ahead and add 3 values if you want. But, what's the point of having default values if you're just going to have 3 parameters you're going to pass in anyways? So basically that is how you have a function that uses default arguments, in other words default parameters. And one other thing that people typically mess up, you only have to put the default value in your function prototype right here. Whenever you create the function and the function body itself down here, you don't put the values down here because you already saying, alright, if I don't explicitly pass in any values, I want to use these as defaults. So you don't need to retype it right here. So people get this wrong a lot. So don't forget to just remember that simple rule. So now you understand the basics of having default values in your function, why they are useful, and how you can pass in a different number of functions like 6 or 6 and 5 or 6 and 5 and 7, and it would all work fine. Basically, whatever you pass in, it replaces the rest with the default values. So that's all I have for you guys for this tutorial. Hopefully you understand. If you don't, just go ahead and ask me one of the questions on my forum, thenewboston.com/forum, and I will be more than happy to answer it for you guys. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 29th C++ tutorial. And in this tutorial, I'm going to be talking to you guys about something called scope. I can't remember if I talked to you guys about scope already, but I need to talk to you guys about it again anyways. So anyways, I'm going to be talking to you guys about scope, not the mouthwash, a little bit different, and also something called the unary scope resolution operator. But I call it the colon because, whenever we're typing it, it's just a colon. So let's go ahead and first, let me build another function aside from main. I'm just going to build another function called Bucky. And all this is going to do is, well, we won't even have it do anything yet. So right now we have two functions, main and Bucky. They're both good to go. So sometimes people build variables inside a function like int x and set it equal to 10. Well, let's go ahead and make some interesting variables. I'm tired of x. So int tuna and set it equal to 69. Now let's go ahead and build another variable called tuna and set it equal to 20. Well, I just want to demonstrate one thing. Some people declare variables outside functions, and some people declare variables inside functions. Now, it's not just like some people have blue eyes, some people have brown eyes. They're people nonetheless, and it doesn't really matter what eye color they have. Well, actually, this does matter. It's not a personal preference. It actually does matter in your computer program where you declare or make your variable. Whenever you make your variable outside the functions, then every single function can access this tuna variable. So this function can use it, Bucky can use it. Every function has access to this variable. But for example, say you only made your variable inside one function, so you only made this variable inside main. That means that whenever Bucky tried to use the variable tuna, it's going to get an error message. So check it out. It says, tuna, what the heck is tuna? Because main functions are basically greedy. Whenever they create a variable, they're the only ones with access to that variable. So that's why people typically like to use variables and declare them outside all of the functions, because whenever you make a variable outside the function, then every single function in your program is going to have access to that. So say for example, main wanted to print out tuna and Bucky wanted to print out tuna. Well, you can go ahead and run this program right now and check it out. Both programs are going to print out tuna just fine. So the reason Bucky didn't print it out and you only saw tuna once was because we didn't call it anywhere. But anyways, that's what the scope of variables is. Basically, where you create variables depends where you can use them. So if you declare a variable in here, only main can use it. If you make one in here, only Bucky can use it. If you declare outside, both the functions can use it. But now we come across a little bit of a conundrum, and let's go ahead and delete Bucky for the rest of this tutorial because he was just an example. A dang fine one, but hey, he was an example. What if a user did something stupid like this? They made a variable called tuna outside main, so of course main has access to it, but they made another variable called tuna that's inside main as well. So main can access that one too. So now when you try to print out tuna, it has a choice. Do I use this one or do I use this one? Well, let's go ahead and print this out and see what happens. It chose 20. And why did it do that? Well, computers pretty much take the most recent or most inner variable that they can. They say, alright, here is a variable that I can use, but why use that one when I have one right inside my function? I'm going to assume that since this one was built right inside my function, that that's the one you want me to use. So these are called local variables and these are called global variables. And when it has the choice, it's always going to choose that local variable. So you're saying, alright, let's go ahead and say that I'm building a function just like this, and I want to call both of these variables tuna, but I actually want to use this variable tuna out here. Well, how do I tell my program that, alright, I know you have a local variable called tuna, but I want you to use this one? Well, in order to do that, you need to use something called the unary scope resolution operator. In other words, the colon colon. Colon colon tells your program, alright, you have two functions called tuna. One of them is local and one of them is global. Whenever you have this colon colon before tuna, that means use the global tuna. In other words, use the tuna outside your function. So now whenever you run the program, check it out. It uses that global tuna instead of the local tuna. And the reason people actually do this is because when they have variables with the same name of different data types, that's when it comes in handy. So for example, if you had an int tuna and a double tuna and you ran it, it would use the double tuna, which is 20. But if you use that colon colon, which is called, again, the unary scope resolution operator if you're taking a test or something, then it uses a 69. So I just don't want to show you guys if you're stupid and put int twice. People typically write variables with the same name whenever they're using different data types. So just wanted to point that out. So what to take away from this tutorial: whenever you create a variable inside a function, you can only use that variable inside the function where you created it. You can't use it inside any other function. Whenever you create a variable outside a function, you can use it in any function in your entire program. So if we had another function called Bucky and another one called Tony and another one called Jessica, we can use this tuna in all of those functions. So that's why you can decide whether it makes this outside or inside your function. And the last thing I want you guys to remember from this tutorial: whenever you have two variables with the same name, one is local and one is global, and you want to use the global variable in your function, you need to use this dot dot or colon colon unary resolution operator, whatever the heck you want to call it. It's two colons before your variable, and that tells C++, hey C++, I know I have a variable in here, but I want to use this one, the global variable, instead. And if you remember these three rules, you'll be good to go. So that's all I have for you guys for this tutorial. Again, basically a really easy tutorial, just a little weird concept that you have to understand. So thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next video. What is going on, guys? Welcome to your 30th C++ tutorial. 30 tutorials, that's like a milestone or something. And in this tutorial, I'm going to be talking to you guys about function overloading, what it is, why it's useful, and when you would use it. So let's go ahead and say we wanted to build a function to, I don't know, maybe we wanted to have the user input a number and we just wanted to print it out on the screen. Really stupid function, but really simple. So let's go ahead and make two variables. We'll make an integer variable a, and we'll set this equal to, 54. And we'll make another float variable, and remember, a float is basically a number with a decimal point, so we'll use like 32.4 yada yada, something stupid. So now we have two different types of numbers, an integer and a float. Well, we have a function that we are going to build called print number, So let's go ahead and call this function, and again, we didn't build this yet, so if you're looking, where did print number come from? We'll build it in a second. So we're going to go ahead and try to use this function for both of these variables, print number A, and we're going to try and print out B too. So then we say, alright, now we're going to go ahead and build this function to print out a number. So we go up here, it's not going to return anything, so it's just going to be void. Of course, it's named print number. And then we get to this part right here. Alright, let's go ahead and think for a second. If we go ahead and put int x, then we're going to allow it to pass in an integer, so this is going to work, but this isn't going to work. So I know what I'll do. I'll just put float x. Well, then this is going to allow me to pass in this number, but then this number isn't going to work. So how do we solve this little puzzle right here? Well, we do this through the use of something called function overloading. And function overloading is the idea that in C++ you can build more than one function with the same name. In this case, we're going to be building two functions called print number that take different types of data depending on what you pass in. For example, we're going to build a print number right here that takes an integer value, and just go ahead and see out I am printing an integer, and then go ahead and print out the integer x, and then end that line. Well, that goes ahead and takes care of the integers that the user might enter, and now we can build another function with the same name, which is print number. Again, if you double click it, you'll see the exact same name. The only difference is it takes a different type of parameter. This one takes a float number instead. So now, whenever we call this method and it has an integer, it's going to use this one. And whenever we call this method, and by method I mean function. Sorry I keep switching on and off, but I teach too many program languages to keep it straight. So whenever it calls a function with a float, it's going to use this one. It's smart enough to automatically know what type of data you're passing it in. So this one is going to print out cout. Now I am printing a float, which is x, and end line. So as you can see, these functions are basically identical. It just runs pretty much whatever type of data you pass in. It looks for whatever function is appropriate for that type of data, and it uses that function. So let's go ahead and build and run this and check out what we get. At first, we passed in an integer, 54, so that's why I used this one that took an integer, and it said I am printing an integer. And after that, we passed in the same function, a float, which was 32.4, so that's why it chose this one. Now I am printing a float, 32.4. So as you can see, function overloading solves the problem of having one function. So check this out. Instead of trying to explain to our boss that they need to use a bunch of different functions depending on what type of data, we can make them happy and say, alright, anytime you want to use a function, just go ahead and use this print number function and put in any number you want. This is going to be behind the scenes stuff that they don't have to worry about. They don't know that we had to make two different functions just because they were annoying and they couldn't understand that they needed to work with different types of data. So we're going to make it really easy for the user through the use of function overloading. Now, whenever the user enters a number like 54, we already have a customized function that is smart enough to realize that they are entering an integer and prints out that value. But if another user, like user B, enters a float, then we of course can handle that too, because our program knows it's smart enough to realize that we're passing it in a float, so that's why it chooses this. So basically, whenever you use a function, your computer program is going to do this. It's going to look for a function with that name, a print number. If it has more than one choice, then it looks what type of data are you passing it in. Well, if I pass it in a float, it's going to look at this one. Does this print number take a float? Nope, it takes an integer. Does this print number take a float? Yes, it does. So I'm going to use this one right here. So that's why whenever you create a function, you need to write the name and also the type of data that you're passing in. So then whenever the user tries to use it, it knows what function to use. So that is basically all function overloading is. It's basically making programs that are really simple for the user, even though they might take us a little bit of extra coding. Hey, when we want to build software and we want to sell it for $1 million, we're going to want to make sure that it's easiest for the user to use as possible. Because, I mean, when we become a millionaire, this extra function is not going to be a real big problem for us. So that is how you make $1 million, and also that is the basics of function overloading. Basically, many functions with the same name, just different data types. So thank you guys for watching. Don't forget to subscribe, and I don't know what I'm going to be teaching in the next tutorial, but I got a feeling you guys definitely want to check it out. So again, thank you. Don't forget to sub, and I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your 31st tutorial. And in this tutorial, I'm going to be talking about something that every single computer science student on Earth just absolutely hates, and that is called recursion. Now, this is a topic that's somewhat confusing, but I'm going to try to make it really simple for you guys. So, what recursion is the idea that a function can call itself. Pretty weird, huh? So you know how like in main we could call another function called Bucky and Bucky would print something out on the screen? Well, recursion is the idea that Bucky could call Bucky. That's interesting. So let's go ahead and take a look at this right now. Say we had a function called Bucky, and all it did was print something out on the screen like cout, let's print out something stupid, OMG, WTF, BBQ, oh my god, WTF, barbecue. And then it went ahead and it called the function again. So now you'd say, alright, well, isn't this function gonna go ahead and we're gonna run main first, and main's gonna say, okay, go ahead and run Bucky, and Bucky's gonna say, okay, print this out and then run Bucky. Okay, Bucky, print this out and then run Bucky again. Print this out, run Bucky. Print it out, run Bucky. And whenever we go ahead and run it, we can see that this is a function that basically never ends. It prints out, oh my god, WTF barbecue, until, check it out, Watermelon EXE. My computer just crashed and gave up on this. So I'm like, alright, so what's the point of using recursive functions other than don't use them? Because, you know, first of all, if you build a recursive function like this, your computer is going to crash just like mine has, and it's not the most useful way to go about things. So one reason that people use recursive functions is, first of all, let me mention this. Whenever you build a truly perfect recursive function, you need to have something called a base case. Now, a base case is pretty much an ending point for your function. So one example that I'm going to be showing you guys is how to calculate factorials. Now, if you remember from math class, factorials are pretty much when you say 5 factorial, and it's written like this, 5 exclamation point. This is pretty much the same as saying 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever factorial it is just whatever number times all the way to 1. So then the value of like 5 factorial is 120. The value of 3 factorial is 3 times 2 times 1, which is 6. So let's go ahead and write a program to do that, and this is one of the instances where recursion is actually a good idea. So let's go ahead and make a function called, we'll call it factorial find. So int, first of all, better spell that right, int, factorial finder, I think I spelled that right, and it's going to take a parameter, which is int x. Can I not spell int today? Int x. And the parameter it takes is what value do we want to find the factorial of. So if we passed it in 5, hopefully it would give us 120. If we passed it in 3, it would give us 6, so on and so forth. So the first thing we need to build is something called a base case. Without a base case, this factorial finder would never end. Just like Bucky, you know how it ran forever until my computer crashed? This is what this is going to do if we don't give it a base case. So we need to say, okay, if x is indeed equal to 1, then we want to go ahead and return 1. So whenever you return something, remember your function ends, and that's the point that we're trying to get to. So in order to do this, we're going to assume that they're going to be passing in numbers other than 1. So we're going to go ahead and do this. Else, if they pass in a number aside from 1, like 5 or 3 or 20 or something like that, go ahead and return the value of x, which is, 5, 3, 20, and then go ahead and multiply that by factorial finder x minus 1. So what it's going to do is, yeah, it's going to call the same function again, but it's going to call it with a different value. It's going to call it with 1 less than before. So if you go ahead and you pass in 5 to this function, what it's going to do is say, alright, I'm going to call 5 times the 4 factorial, or factorial 4. I don't even know how to say it. I'm not a mathematician. But anyways, what it's going to do is it's going to say this. I'm going to call 5 factorial 4. Well, what's the value of that? I don't know. The value of that is 4 factorial 3. What's the value of that? I don't know. 3 factorial 2. What's the value of that? I don't know. 2 factorial 1. What's the value of that? I don't know. Oh, wait. I do know. 1 factorial is 1. So now that it has that bit of information, it can go ahead and solve the rest of the questions that it asks. You know how I said, I don't know, I don't know. Well, now it can say, alright, Bucky, 1 factorial is 1, so now I know that 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. So that way, you can see that whenever we go ahead and run this, factorial finder, there we go, I didn't feel like printing out the whole thing. That way, when you print out factorial finder 5, and let me just go ahead and end that line, and we run this program, it says 120. Yeah, it was 120, but there is a lot of stuff going on behind the scenes that the user didn't have to see. What it did is said, alright, it ran this function like 5 different times searching for 5 factorial, and then it called it again searching for 4 factorial, then did again searching for 3, 2, and finally when it got to 1, it could answer all the rest of those questions. So this is how you can use recursive functions in a useful way. Again, a recursive function is just using the function inside the function body itself. And remember, whenever you do this, you need to have a base case. You need to have an ending point that actually answers that question. So in this case, whenever they got to 1, it could solve the rest of its questions, because if we didn't have that base case, like before when we printed out OMG WTF barbecue, it would just run forever and ever and ever without an end. So that's why you need to give it a base case, in other words, a point to get to, where if it solves that question, then all the rest of the questions can be solved. So again, you guys can probably see why people hate recursive functions, but why sometimes you actually need it, because there's a lot of stuff going on behind the scenes that we don't get to look at, but we just have to, assume in theory that this is going to work. So it's a little bit different than regular programming in the fact that you don't explicitly call a function like this, that a function is going to call a function for you however many times it needs to. So there's a lot of theoretical programming that you need to think of, and a lot of different things that can go wrong with recursive functions. So that's why I wanted to, show you guys a quick example of the bad way to use recursive functions and the useful way to use recursive functions. But now that I taught you guys that tutorial, we can finally, get over recursive functions. You will be happy to know that I don't use recursive functions a lot in programming, and we're probably going to be, done dealing with them for a while. But, it was a topic that we definitely couldn't skip, and now that you watched this tutorial, I'm glad I taught it to you guys. So thank you guys for watching. Don't forget to subscribe, and don't forget to put a base case in your recursive functions, or else your guys' computer is going to crash. So thank you guys. Don't forget to subscribe, and I'll see you in the next video. What is going on, guys? Welcome to your 30-second C++ tutorial, and in this tutorial, I am super excited because I'm going to begin talking to you guys about something called an array. So an array is basically one of my favorite parts of C++ because an array is basically a variable that can store multiple values, and you can do a bunch of cool things with them. And like I said, it's one of my favorite parts dealing with C++. So let's go ahead and get started. Like I said, an array is basically a lot like a variable, but instead of just storing one value like 8 or 20 or 87, it can store multiple values. So we're saying, alright, that's kind of weird, but let me go ahead and show you guys how to make one. In order to make an array, you first write what data type you're working with. Let's go ahead and make a simple integer array. Next, just like a variable, you type something you want to call it. I'm going to call my array Bucky because it's a pretty cool name. And now, right after this, with no space, in square brackets, you go ahead and you write how many numbers, in this case how many integers, do you want to store in your array. So let's go ahead and say 5. So what the compiler is going to do now is it's going to create an array that can store 5 integers. So whenever you run this, your compiler is going to set aside some space to hold 5 integers. So we're saying, alright, so now one array can hold 5 different integers. Pretty cool, huh? So here is how, well, there are a lot of different ways you can create an array, but probably the most basic and easiest to understand is called an array initializer list. And an array initializer list is basically just a list of numbers, and you have to put it in between these squiggly brackets. I don't know the technical name for them, but they're above the square brackets on your keyboard. And in between it, you write a comma separated list of 5 numbers. So let's go ahead and print out like 66, 75, 2, 43, and 99. And that is basically all it is to create an array. So we went ahead and we created an array called Bucky, and Bucky was able to hold 5 integers, and whenever we gave it its 5 integers, we had to put it inside something called an array initializer list. So we have 5 integers: 66, 75, 2, 43, 9, 99. So now, whenever we want to use those values, you're saying, alright, say I wanted to print out one of these values like 2 or something. So let's go ahead and see out Bucky. Okay, well, I can't do that because if I just say the array name, it doesn't know exactly what value I'm talking about here. So in order to let C++ know what value you want to use from that array, we have to use something called the array index. So let me tell you guys this first. When I said an array is made up of a bunch of different values, the technical term whenever you're working with array is called elements, and all they are is values, but you know, we have to be professional here, so we're going to call them array elements. So 66 is one element, 75 is one element, 2 is an element, so on and so forth. So whenever we want to index a specific element in our array, we go ahead and we write the index number inside our square brackets. So you might be thinking, alright, the index number for this one is 1, this one is 2, and this one is 3. So let's go ahead and try to print out Bucky 3 and see what happens. Let's go ahead and end that line, and we should be expecting 2 right here. So let's print it out and check it out. 43, what the heck? I thought it was going to be 2. Okay, so 43 is the 4th one, not the 3rd one. So what's going on, Bucky? Well, the reason that it printed out 43 is because whenever we're dealing with computers, I don't know if you guys know a lot about binary and zeros and ones, but you know how people start counting at 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I learned how to count to 10. Well, computers, they start counting everything with a 0. So whenever we create our array, this first element, even though it would be number 1 to us, to the computer, it's actually element 0. So let's go ahead and print out Bucky 0, and as you can see, whenever we run this, we get the number 66. So whenever we are referencing indexes, or excuse me, elements in our array, we have to remember that our array starts counting at 0. So 0, 1, 2. So this is actually the 2 index. So let's go ahead and print out Bucky 2. And now we go ahead and we get 2 right there. So again, the basic things I want you guys to remember is this. An array is basically a variable that can store multiple values. The easiest way to create an array is this. Write the data type, write your array name, and then write however many elements you want your array to hold. And we stored 5 integers in this case, so that's why we passed 5 integers in something called an array initializer list. So basically, whenever we create Bucky 5, we're telling our computer, alright, Bucky is going to be holding 5 different values, so compiler, go ahead and set aside some space in our memory to hold 5 integers. So that's what it did whenever it created this line. And aside from that, I want you guys to notice this. Each value in the array, I say value sometimes, but technically they're called an array element. And in order to reference one of those elements, we use something called an array index. And the first element in every array is index 0. So if you wanted to print out 99, it would be 0, 1, 2, 3, 4. So Bucky 4, whenever we ran this program, is 99. Pretty cool, huh? So that's basically the most simple way I can explain arrays to you guys. Again, I said that one way to create an array was to use an array initializer list. In the next tutorial, I'm going to show you guys a different way to create an array, and it's a lot cooler way. So if you don't quite understand arrays yet and don't quite understand why they would be useful, then just stick around and I trust me. What I say? I trust me. Of course I trust myself. And trust me, you guys will in the upcoming tutorial. So again, thank you guys so much for watching, and I will see you in the next tutorial. Alright guys, welcome to your 33rd C++ tutorial, and in this tutorial I'm going to teach you guys an easier and quicker way to create an array, and that's through the use of loops. So in the last tutorial I taught you guys what an array was, and also that we can create an array using something called an array initializer list. And this is actually pretty useful when you're dealing with smaller arrays, but whenever we're working with bigger arrays, say that store 100 elements or 1,000 elements, we're going to need a quicker way to create that array instead of making a huge long list. So let me go ahead and show you guys exactly how to do that. So in our very first line, we're going to declare our array. We aren't going to set it equal to any values just yet. So I'm going to make an array called Bucky, and Bucky can hold 9 integers. So in this line of code, we're pretty much telling our compiler, hey compiler, whenever you run this program, you better set aside some space in our memory, enough space to hold 9 integers. So our compiler says, yes sir. Now, what we need to do is, well, let me just go ahead and whenever I'm done with this tutorial, I'm going to print out the elements on one side and the value, so I might as well give it a nice little prompt now. Element and value. So what we're going to be doing is we're just going to print out the element on one side and the value on the other side. So let's go ahead and take a look at this right now. One space for elements, and I'm going to list those on this side, and right across from it I'm going to list their values right here. So if you're saying, alright, you talk to talk, now time to walk to walk. One way to create an array, like I said before, is the use of loops, and in this tutorial I'm going to be using the for loop. So let's go ahead and see what parameters we add for this. So we already know that whenever we create an array that holds 9 elements, every array starts at 0. So I think whenever we created this, int x, 0 would be a good place to start. And we also know that if we created an array that can hold 9 integers, the last index in that array, the last index in that array is going to be 8. Because count with me, get your fingers out. 0, 1, 2, 3, 4, 5, 6, 7, 8. I only counted to 8, but since we had 0 in there, that takes care of our 9 elements. Pretty cool, huh? So we only want to loop from 0 to 8. So that's why we write x is less than 9. We can make it easier. X is less than or equal to 8. Oops, not x comma. Less than or equal to 8. Either way works fine. X is less than 9 is a little bit quicker, but you know, what's one extra character? So now, of course, we want to use x plus plus to increment x by 1 each time. So now, whenever we see out x and line, just go ahead and run this real quick so I can show you guys. We get that 0 through 8, and you're saying that's pretty cool. So now we have the numbers 0 through 8, and those just happen to be the exact numbers that we need in our array. So now what we can do is something like this. Bucky x equals 99 or something stupid. So what this is going to do is it's going to go through your array, each element one by one, and assign it the value 99. So the first time it loops, it's going to set the Bucky 0 element to 99. The next time, the Bucky 1 element to 99. So it's basically going to set every element in your array to 99 until it gets to 8, and then it's going to do it one more time and stop at 9. So pretty cool, huh? So let's go ahead and print this out and see exactly what I did. So cout, first we'll go ahead and print out x, which is the element number, same as this. So this is going to be 0 through 8 on the left hand side. And now let's just go ahead and give us some space to work with. And after this, just go ahead and write the value of whatever element is stored in there. So this is going to be 99 if we coded it correctly. So let me go ahead and end this line, and whenever I run this, you guys will clearly see what's going on. So what we did is we looped through each array element one at a time. First Bucky 0, then Bucky 1, then Bucky 2, 3, 4, all the way to 8. And each time we loop through it, we set that element equal to 99. So now we have an array called Bucky that has 9 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, and each of those elements is equal to the value of 99. There are actually a lot of 9s in this tutorial, but it's a good number, so it feels appropriate. So let me talk you guys through this one more time in the code. In this line of code, we're basically declaring a 9-element Bucky array. We're telling our computer, make sure you set aside enough space to hold 9 integers in the array Bucky. So that's what it did in this line. In this line, all we did was print out a title, basically. And in our loop, we knew that since we were creating Bucky 9 array, that the indexes that it need was 0 through 8. So we made a simple loop that basically looped through the numbers 0 through 8. And with those numbers, we could reference the Bucky element and assign it equal to the value of 99 for each one. And then, of course, we just printed out the index, which was 0 through 8, and then the value, which was 99 each time. So simple enough. So that is basically 2 different ways to create an array. Again, whenever you're working with really big arrays, and I don't know, it's just a lot easier than using an initializer list, because if you created an initializer list with like 100 values, then you would go ahead and have to type 100 values in here, and it would just get messy really quick. So this is a faster way. It takes a little more thinking, but it's definitely worth it. So for now, that's all I have for you guys. Thank you guys for watching. Don't forget to subscribe, and I will see you in the next tutorial. Welcome back, guys, to your 34th C++ tutorial, and in this lesson I'm going to teach you guys how to use an array in calculations, and it's actually a pretty simple program, definitely useful, definitely something you want to stay tuned for. So let's go ahead and make an array right now. Let's call it tuna. I'm getting tired of using Bucky every time, and let's set the tuna array big enough to hold 5 integer values. Looks good enough. And now let's go ahead and use an array initializer list. Let's go ahead and throw in 20, 54, 76, 832, and whatever this number is right there. So now we created an array called tuna, and it has 5 different elements or 5 different values in it. So now what we want to do is, say our boss came to us, or our teacher, and he's like, build a program that calculates the sum of all of these elements. So we're saying, alright, the first thing we need is a variable to hold that sum, and by default, since it doesn't have any elements at first, we're going to set it equal to 0. So what we could do is this: sum equals, I tried to type Bucky again, tuna 0 plus tuna, oh, you know what, I'm getting a bunch of typos and this is just taking too long. Not very efficient way of doing it, although it would work. So let me go ahead and show you guys a much easier way to use an array in calculation. So instead of all that typing, let's go ahead and make a for loop instead. So now what we need to do is, just like before, find out which array indexes our array is going to need, and just use our for loop to loop through those array indexes. So of course, as always, we need to start at 0 because the first index in every array is 0. Alright, now let's do a little bit of thinking, but not too much. Tuna holds 5 values, so that means the last index in that array is 4. So if you write x is less than 5, what it's going to do is it's going to go from 0 to 4. It's not going to do 5 because 5 is not less than 5. So now when we press x++, we now have a for loop that loops from 0 to 4. So it's going to go 0, 1, 2, 3, 4. Those are going to be your x values. So what we can do now is just use sum plus equals tuna x. Now what this is going to do is this. The first thing it's going to do, the very first time it runs the loop, is going to say this: alright, x is equal to 0. So add tuna 0, which is 20, to the sum. Now the sum is going to be equal to 20. The next time it's going to be 1. So add tuna 1, which is 54, equal to the sum, which is 20. So now it's going to be 74. So it's going to go through each of these elements one by one and add each value to the value of sum. So let's go ahead and just print out this on the screen. Cout sum end line, and now you can see a better idea of what's going on. So like I said, one by one, the very first time it runs, it's going to add tuna 0 equal to sum. The next time, tuna 1 equal to sum. Tuna 2, tuna 3, tuna 4. So if you add up all of these values right here, you get the value of 1,528. So one last time, what we did is this. We created an array called tuna using an array initializer list that holds 5 integers. 1, 2, 3, 4, 5. Now what we wanted to do is we wanted to calculate the sum, so we made a variable called sum, and of course by default, since it didn't have any value, we set it equal to 0. Then we made a for loop using the value in here, the variable, to loop through each index of our array. So it started at 0, and since we know this one was tuna 4, that's what we put for here. X is less than 5. And of course we want to go one at a time. We don't want to skip, this one and this one or anything. So then what we did is we looped through each value and added it to the variable sum. And then we just printed out sum on the screen, and that's what we got. 20, 74, 150, 982, 1528. So that's a real simple program in order to use arrays and the array indexes and elements and values and calculations, yada yada yada, all that fun stuff. So now you guys know how to use arrays and calculations. You're ready to move on to my next tutorial where we're going to be talking. I'm going to teach you guys something else about an array that's actually pretty cool. So don't forget to watch that tutorial. Thank you guys for watching, and don't forget to subscribe. What's going on, guys? Welcome to your 35th C++ tutorial, and in this tutorial, definitely don't want to miss this one because I'm going to teach you guys how to pass arrays into functions, and there are a lot of weird tricks that you need to watch out for, so make sure that you pay attention to every single detail. So let's go ahead and make a really simple function. I'm going to make it really easy. The only thing it's going to do is print out an array, one by one. So if our array was like 43, 21, 8, it would print out 43, 21, 8. Really simple, but it's a nice clear example. So let's go ahead and make sure you're working outside your main function right here and call it anything you want. I'm just calling mine print array, and it's going to take some parameters. The first parameter that's going to take is the array itself that we're going to pass it in. So let's go ahead and say we're passing it in an integer array. Go ahead and write int and then give your array a name, the array. And whenever you pass an array into a function, you need to write those square brackets right after it. If you don't write those square brackets, it's going to think that you're going to try to pass it in a variable. And we want to tell our compiler, no, our first parameter whenever we use this function is going to be an array. Hence the square brackets. So what people typically do whenever they pass in array into a function, they usually want to pass in the size of the array too, because that's information that you definitely need to know later on. So just go ahead and name the size of array, and this is of course going to be how many elements are in the array. So now, like I said, this is the easy part. Let's just go ahead and build a function that prints out each element in the array. So for int x equals 0, because remember, we always want to start at 0, so that's never going to change. The only thing that's going to change is this second thing we need to pass in. X is less than size of array. So check it out. We can go ahead and write, later on when we create our array, instead of using size of array, x is less than 10 or x is less than 20. But now whenever we use this function, we can pass in any array in any size we want, and it's going to work perfectly. So instead of setting this equal to a number like 10, 15, 5, I like to set it equal to a variable because then it's a lot easier later on. And of course, x++ incremented by 1. So now whenever we pass in an array, it's going to loop through each of its elements 0 to the last element. So now let's just go ahead and print it out on the screen, the array, and of course for here we plug in x and end line. So now, once I fix this right here, what we built is a function that basically takes two parameters, an array and the size of the array. We needed this information because whenever we created our loop, we needed to know how long to make that loop last. And of course, for each line, all we did is we print out whatever element, whatever value that element is equal to. So now let's go ahead and prototype this function right now. Because remember, we're going to be using the function right here in the main, but whenever it tries to use this function, it's not going to know that it's a function that we built unless we prototype it. So let's go ahead and copy this, and if you remember from like, I don't know, the 10th tutorial, something around then, if we prototype it, now we don't get an error message whenever we try to use this function because it knows that it's a function that we created. So let's just go ahead and make two arrays to work with, int Bucky, and we'll set this equal to a 3 integer array. And go ahead and add any 3 integers you want. 20, 54, and 675 sound good to me. And actually, let's go ahead and make another array just to make sure our program is working fine. I like to name my arrays names, and I'm going to name this one Jessica, and she's going to hold 6 integers. So set this equal to, get that out of the way, and 54, why do I use 54 all the time? 24, 7, 8, and 9. And how many is that? 5, and another one, 99. Good to go. So now we have two arrays, Bucky, which has 3 integers, and Jessica, which has 6 integers. So whenever we want to use this function that we just created, just go ahead and type the name of your function, print array, and give it the 2 pieces of information it needs. But you know how at the beginning of this tutorial I said that there are a couple of tricky things that you guys need to watch out for? This is one of them. You might think in the first parameter you might type Bucky or Bucky square brackets or Bucky square brackets 3, but actually the only thing you type is the name of that array. So of course, well, how can I explain this? You already created an array called Bucky, so now whenever you pass it in, it knows it's an array. You don't have to tell it that you're passing in an array because obviously if it created it already, it's going to know. So that's why whenever you pass it into a function, you don't use those square brackets at all. And of course, the second piece of information it needs is how big is this array. So let's go ahead and make sure 3 and pass in 3 for here. So now let's go ahead and build and run this program and check it out. 20, 20, 54, 54, 675, 675. And now let's go ahead and use this for Jessica. Jessica array, again, with no square brackets, and 6. So let's go ahead and build and run this. And it looks good to go. 54, 24, 7, 8, 9, 99. Pretty good. So one last time, here's what we did. In the very first line of code, we built the function prototype because if we didn't have that prototype, let me just go ahead and comment this out, and we try to run it, we're going to get an error message. So this error message pretty much means this. Alright, I did this, and now you want me to do this? What the heck is print array? So when we do include that prototype and try to run it, it knows that, oh, print array is actually a function that you guys built. Alright, so now I'm going to run this and I know to look for a function. So anyways, that's what prototyping did. In the main, we just made 2 arrays. And in this line, we just called that function and passed in the array name and the size of the array. So then, whenever we called Jessica 6, it went down here to print array. For this parameter, it was Jessica, and for this parameter, it was 6. And then it looped through, pretty much looped through a loop 6 times. And it said, alright, for the array, which was Jessica, print out each index of that array 0 to 5. And that would give you your 6 elements. So this is basically how you use an array in a function. And the only couple things you need to watch out for is this. Don't forget to prototype your functions. Don't forget whenever you are making your function itself to include the square brackets. But whenever you use the function in your main program, do not include those square brackets because your compiler is smart enough to realize that whenever you use Jessica, it obviously is an array because you told it right above it. So as long as you remember those simple things, you will be good to go, and that is how you use an array inside a function. So it's kind of complicated at first, but if you just do it like 2 times, you'll be a pro at it. So that's all I have for you guys for this tutorial. Thank you guys for watching, and don't know what I'm going to be talking about in the next tutorial, but it's going to be cool. So I'll see you then. What's going on, guys? Welcome to your 36th C++ tutorial, and in this tutorial I'm going to talk to you guys about something called a multi-dimensional array. Now, a multi-dimensional array is basically an array inside another array. So yeah, think about that for a little bit and get freaked out. You might be thinking, whoa, this reminds me of Inception, a dream within a dream. What's going on? And you guys are thinking, oh man, this tutorial is going to be super confusing. I barely even understand arrays, and now you're going to say an array inside an array? Alright, well here is an easier way to think about it. If you ever, use Microsoft Excel or maybe use MySQL, think of it as a database or a table. A multi-dimensional array is basically made up of rows and columns. So this is the easiest way where you can think of it, and it's basically whenever someone has information and they want to organize it in rows and columns, they use a multi-dimensional array. So let's go ahead and create one right now, and I'll show you guys the syntax for it. Go ahead and pretend you're creating a basic array. I'm going to name mine Sally, and instead of a one square bracket, it actually takes two square brackets. In the first square bracket, you write how many rows do you want to have in your array. Let's keep it simple and say we want to have an array with 2 rows. And for the second one, it's basically columns. How many columns do you want to have in your array? So let's go ahead and add 3 columns. So now we have a row, now we have basically a table that's 2 rows by 3 columns, aka there are 6 elements in this array. So in order to create an array inside an array, it's basically exactly like you would think. Go ahead and make your array, and just to tell you guys this, CodeBlocks gets freaked out whenever you try to put squirrely brackets inside other squirrely brackets, so that's why it might be messing up when you try typing it. But anyways, go ahead and as the first element in your array, you actually add an array. So let's go ahead and add 2, 3, 4. So check it out. We have an array 2, 3, 4 inside another array, and this smaller array is the first row. So now let's go ahead and make our second row or second array. Add a comma, and like I said, CodeBlocks gets freaked out whenever you try to do it, so it might be weird. But let's go ahead and in this array put 8, 9, and 10. So we basically made 2 different arrays. One array is 2, 3, 4, and the other array is 8, 9, 10. So we said, alright, we're creating a multi-dimensional array consisting of 2 different arrays. Each array is a row, and each value is going to be a column. And remember to separate your arrays with a comma. So basically, this is an array made up of 2 smaller arrays. So let me go ahead and draw this for you guys visually. Like I said, there are 2 different rows. One is 2, 3, and 4, and the other one is 8, 9, and 10. So visually, this is what our array looks like. This is all one array that's basically made up of this array, 2, 3, and 4, and this array, 8, 9, and 10. 2, 3, and 4 is on top, 8, 9, and 10 is on bottom, 2 rows, 3 columns. Pretty simple, huh? So anyways, the basics of this is anytime you want to create a multi-dimensional array, go ahead and list number of rows, number of columns, and for the number of rows, that's how many arrays you create, and for the number of columns, that's how many values you add to each array. And then you end up with something like this. So if you're saying, alright, now how do I reference, how do I get to each element in that array? Well, let's go ahead and just print it out on the screen. Of course, print out Sally, and whenever you reference it, it just takes the 2 brackets. The first index you need is what row is it in, and remember, the first row starts with 0, so anytime we want to access an element in this first row, we need to go ahead and put 0. Now remember, 2 is going to be 0, 3 is going to be 1, and 4 is going to be 2. So if you write 0, 2, it's going to look at the 0 with row, which is the first run, and the second element, which is actually 0, 1, 2. So it's going to go 0, 2, and that's going to give us our 4. It's basically just like coordinates. I don't know why I didn't say that before, it didn't cross my mind, but basically multi-dimensional arrays are exactly like coordinates. You rest the coordinate here, start with 0, and the coordinate here. So if you want to reference 9, that would be 0, 1. So go ahead and type 1 for that. And 0, 1 right there. So that, let's go ahead and print that out, and I got my 9. So basically, a multi-dimensional array, just like Inception, is an array or more than one array inside a bigger array. It's pretty much an array made up of arrays instead of values. And what it does is it gives you the idea that you can create a table basically made up of rows and columns. And anytime you want to access one of the elements, you just go ahead and type in the coordinates, which would be the row number and then the column number. And you print it out, and there you go. So if you guys understand this, then you're ready to move on to my next topic. In the next tutorial, I'm going to teach you guys a really simple way to print out a multi-dimensional array. So instead of just having to comment this right here, you have a nice visual of what it looks like. So if you guys don't understand it, then go ahead and just go to my forum and ask me a question, and I'll explain it better there. But if you do, or maybe if you got any good Inception jokes, then leave them in the comments below. But for now, thank you guys for watching. Don't forget to subscribe, and I will see you in the next tutorial. Alright guys, welcome back to your 37th C++ tutorial, and in this tutorial, I'm going to show you guys a really easy way to print out multi-dimensional arrays. So let's go ahead, and first thing we need to do is create a multi-dimensional array. Go ahead and name it Bertha, and Bertha can be 2 rows by 3 columns, same as before. So now what we need to do is go ahead and make an array of arrays. So the first thing I do is put my 2 arrays in there, separated with the comma. So now we have 2 arrays, which would be 2 rows. And now put 3 values in each, like we'll just put 1, 2, and 3 in the first one, and 7, 8, and 9 in the second one. So now we have an array called Bertha that has 2 rows and 3 values in each row. So it's basically a table that's 2 by 3. So in order to print this out, what we need to do first is we need to loop through each row one by one. We're going to loop through the first row, and then we're going to loop through the second row. So let's go ahead and make a for loop, and well, we might as well name this row, and of course it always starts at 0 because the 0th index is the first element in your array. So row 0, and the second one is row is less than 2. So what this is going to do when we put row plus plus is it's going to go from 0 to 1. So row 0, then row 1. It's not going to go row 2 because of course 2 is not less than 2. So now we're looping through each row one at a time. And now, of course, you guys can probably guess what I'm going to do next. We need to loop through each column or each element in the row. So now, in order to do that, go ahead and make another for loop, and this is going to look really familiar. There we go. Int column, make sure I spelled it right. This one starts at 0 as well. Again, all arrays start at 0, even if they're inside another array. Column is less than 3 because that's how many columns you have. You basically write the maximum, the number of rows and the number of columns right there. Simple enough. You know what? That kind of looks like a heart. That's kind of cute. Anyways, moving on. Column plus plus. So now what we're doing is this. We're looping through each row one by one. The first time it loops through row 1, it's going to loop through each of those elements, 1, 2, and 3. And then it's going to loop through row 2, and then it's going to loop through each of those elements, 7, 8, and 9. So after we get through looping through each column, we want to move to the next line, cout end line. Because again, each row is on a different line, so that's why when we're done looping through the last element in the row, we want to move to the next line. So now we can just go ahead and print it out on the screen, like cout Bertha was her name, and you put the row number, which would be this, 0 or 1, and then you put the column number, which is going to be some value 0 to 2, and that would be these values right here. So let's go ahead and make sure you don't write end line on, actually what we do need to do though is add a space there, but make sure you don't write end line on this line right here because these are your column values. You don't want every single one of these numbers to go on a new line. You only want it to go to a new line after you're done looping through the last element in that column. So let's go ahead and print it, make sure I didn't forget any semicolons, which I did somewhere, and let me see what's wrong. Oh, I see. What I did here is I put a come on, highlight it. Put a comma instead of a semicolon. So now let me check, make sure to run it again, and there we go. In our first row, it printed out 1, 2, 3, and in our second row, it printed out 7, 8, 9. So this is a perfect way to visually see multi-dimensional arrays. So pretty cool, huh? So again, one last time, here's what we did. I'll just leave this down here. We made an array that was 2 by 3, and which that means is it was an array consisting of two different arrays with 3 values each, and what that means is we basically made a table that was 2 rows by 3 columns, as we can see right here. The first thing we needed to do is loop through each row. Loop through this row, the first one, and then loop through the second one, and we did that by writing row 0, rows less than 2, yada yada yada, all that fun stuff. You basically, the only thing you need to worry about is make sure this value right here is the same as this value right here. So we said, alright, for each row we loop through, we want to loop through each one of the elements one at a time. So that's why we wrote start with 0, 1, 2, one at a time. And why we had this little spacer right here is because if we didn't have that, it would put 1, 2, 3 real close together. So what it did is it basically printed out a row, one element at a time, and then when it was done, it said C out end line, and that's why it jumped to this next line and printed out 7, 8, 9. And it did that until it was done printing out all the rows, and then it just ended. So that is how you print out a basic multi-dimensional array. Again, of course, this is a whole lot to see visually. It's a whole lot better looking at than this right here. So that is why you actually use this quite a bit whenever you're programming. So that's all I have for you guys for this tutorial. Thank you guys for watching. Hopefully you understand how to print out a multi-dimensional array now, because we're going to be done talking about arrays for now. In the next tutorial, I think I'm going to be covering something called vectors, which is kind of like an array, but it's a little bit different. So thank you guys for watching. Don't forget to subscribe. If you have any questions, check out my website, and I'll see you in the next video. Alright guys, welcome back to your 38th C++ tutorial, and in this tutorial I'm going to be beginning to talk about something called pointers. Now pointers is something that confuses a lot of people, so I'm going to try to explain it really simple for you guys. Now you remember how we made some variables that contain strings of text, and we made some variables that contain integers, and we made some variables that contained floats. Well, a pointer is a special type of variable that contains a memory address as their value. Pretty weird, huh? So let's go ahead and the first thing we need is a plain old integer variable. So let's go ahead and make a variable called fish and set it equal to the value of 5. It doesn't really matter what the value is, to be honest. So anyways, we have a plain old variable named fish. Now let me go ahead and show you guys how to retrieve the memory address of this variable. So as you probably already know, this variable called fish is stored somewhere on our computer, somewhere in the memory, you know, who knows where. So sometimes we need to be able to access where indeed that memory is. So in order to do that, you go ahead and you write the and sign, and the and sign is called the address operator. And now whatever variable you type after it, this means the address in your memory of fish. So if you go ahead and print this out on the screen using cout, and might as well end that line. Hello, can't type end line today. End L, there we go. And we go ahead and build and run this. We see that we get this weird hexadecimal, who knows what this is. This is actually the memory address of where the variable fish is. So again, like I said, the first thing we need to find the address of something is of course a variable, because we need to find the address of something. And in order to find the memory address of the variable, you go ahead and you write the and sign right before the variable, and then those two combined pretty much tell your C++ compiler, alright, I want to print out the memory address of fish, not the variable fish itself. So this is of course the address of where your variable fish lives. Now you're saying, alright, well, you just went over address operators. I thought you were going to go over something called pointers. Well, let's get into that right now. A pointer, like I said, is a special type of variable that points to a memory address. In other words, a pointer is a variable that contains a memory address as a value. So let's go ahead and I'll show you guys how to make a pointer. In order to make a pointer, go ahead and write the type of data you're going to be pointing to. So we're going to make a pointer that points to an int value, or in other words, an int variable. So this is going to be an int pointer. Simple enough. Now, in order to tell C++ we're making a pointer instead of just another variable, we need to add an asterisk, that little star above the 8 on your keyboard. And now we can go ahead and name a variable like fish pointer, and this tells our compiler that we're going to be making a pointer instead of a regular variable. Again, if we just had it like that, our compiler would think that we're just making a regular variable, but we're not. We're making a pointer, so that's why we needed that little asterisk before fish pointer. So we went ahead and we declared a fish pointer right here. We're pretty much telling our program we're going to be making a pointer called fish pointer. And what this fish pointer is going to do is it's going to point to a memory address. So now we have to, of course, assign it a memory address. So let's go ahead and whenever you assign a memory address to a pointer, you don't need to include the star again, because you only do that whenever you're first creating the variable. From now on, whenever you use the variable fish pointer, C++ already knows that it's a pointer because you told it whenever you created the variable. So make sure you don't put star fish pointer twice, only one time. C++ is smart enough to recognize this. Now go ahead and set it equal to the memory address of a variable, and we only got one variable, fish. So now fish pointer is equal to the memory address of fish. It isn't equal to 5, it isn't equal to the word fish. Fish pointer is equal to the memory address of where the variable fish lives, that long hexadecimal thing. So now when we go ahead and see out print fish pointer and go ahead and end that line, now these two lines should be identical, because first we're printing out the memory address of fish, and next we just are basically printing out the memory address of fish. So let's go ahead and make sure these lines are the same so I don't look like a fool, and see, there we go. So basically we know how to print out the memory address of a variable using the memory address operator. That's a pretty nice name for it. So then I taught you guys how to create a pointer, and all a pointer was a special type of variable that had a memory address as its value. So again, whenever we ran this, we can't assign this to an int because it's not an integer. We can't assign it to a float because it's obviously not a float. So we have to assign it to a special type of variable called a pointer. So that's why you need to be able to use pointers. And of course, when we just printed it out the memory address. Pretty cool, huh? So that is your basics of what a pointer is, how they're created, and how you obtain the memory address of a variable. So now with all that knowledge, we can begin programming, and we're actually going to use these pointers and programs, and they're actually useful for something, believe it or not. So thank you guys for watching. Hopefully you understand everything in this tutorial. If you have any questions, don't forget to check out my website, thenewboston.com, and I'll see you guys in the next tutorial. What is going on, guys? Welcome back to your 39th C++ tutorial, and in this tutorial we're going to be covering pass by reference with pointers, and we actually have a ton of stuff to cover, so I don't even know if I'm going to have enough time in this one tutorial. I might have to break it up into two different tutorials, but let's go ahead and get started anyways. So we already know from our last tutorials that whenever we pass an argument into a function, passing an argument into a function basically means giving our function any additional information that it needs. Like, in order to calculate the square root of a number, you actually need a number, so you have to pass a value into that function. But believe it or not, it isn't quite that simple. There are two different ways that I'm going to be teaching you right now. There are actually more than that, but for now I'm going to be teaching you two different ways to pass arguments into functions. One of them is passed by value, and one of them is passed by reference. Now, what do I mean when I say that? What we've been doing is basically passing by value, and whenever we create a function and we pass it by value, we pass a copy of that variable into the function. So the original variable itself cannot be changed until we set it equal to another value. So that way the function only has access to the copy of that variable, not the original variable itself. Simple enough. Values pretty much mean passing in a copy. Okay. Now, pass by reference means this. Whenever you pass in a variable by reference, you pass in the variable's address. And whenever you do that, you basically give the function direct access to that variable. So in that sense, the original variable can indeed be modified inside your function. So why would you ever want to do that? It seems kind of dangerous. Well, the one benefit is it's basically less stress on your computer. Instead of passing by value where every time you call that function it has to make a copy of the variable, suppose you had 100 variables, that would be pretty stressful on your computer. If you pass by reference and you pass in the value itself, it doesn't have to make copies of every variable. So let's go ahead and let me start off by making two variables, int Betty, and I'll set this equal to 13. And let's make another person, int Sandy, and set this equal to 13 too. Now what we're going to be doing is passing this one in by value and passing this one in by reference and see how they turn out. So we're going to be needing to create two different functions. First, let's go ahead and create a function that we're familiar with, pass by value. So void pass by value, and let's just go ahead and create a basic function. It'll take a parameter of one integer, and what we're going to do is take this integer and set it equal to 99. So basically what we're going to be doing is Betty, pretty much x is a copy of the variable Betty. So then whenever we set x equal to 99, it doesn't set Betty equal to 99, it just sets this copy equal to 99. So that's what's going to happen. Now let's go ahead and make a function pass by reference. So void pass by reference. Hopefully I spelled that right. There are way too many e's in reference. 4 e's. I mean, come on guys, enough of these. So functions that receive a memory address, they need to have a pointer argument because they need to have a pointer because a pointer is the thing that receives the memory address. So now instead of int x, you need to type int pointer x because the pointer x is now going to be able to hold that memory address. So now whenever, whoa, one little extra thing there. So now what we can do is something like this. Pointer x is equal to 66 or something like that. So now instead of the copy of x being equal to 99, now the variable itself, Sandy, x is the address of Sandy, so Sandy is going to be changed to 66. So whenever we pass Betty in this one, her value is not going to be changed. But whenever we pass Sandy into this, we're basically passing in Sandy directly into this function, her address and everything. So now this is a direct access to the variable Sandy. So let me go ahead and first of all we need to prototype these functions. So copy this and paste. Did I copy it or did I just do something weird? I might have had an extra character somewhere. Better not get an error or else I'm going to be ticked off. So copy that and then copy this reference and paste this in. And now check it out. Before we go ahead and, well, let's go ahead and just use these right now. And then I'll talk to you guys about the thing I was going to. So let's go ahead and pass by value and we will pass Betty into this one. So we're going to pass 13 into that, but her value isn't going to be changed. Now let's go ahead and pass by reference Sandy, and we're pretty much giving this function direct access to Sandy, so that value is going to be changed. So now what we need to do is, here's what I'm going to talk to you guys about. Since we're passing in the memory address, of course you remember from the last tutorial, we need the ampersand because Sandy is the variable, and this function takes a memory address. So the symbol for the memory address of the variable is ampersand Sandy. This is basically equal to some long hexadecimal address of where that variable is located on your computer. So now let's just go ahead and print out the values and see what we get. Cout Betty is now, and then just go ahead and print Betty and end line. And now do the same thing for Sandy is now Sandy end line. So let's go ahead and run this, and I guess I can see if I messed it up anywhere. Nope, looks good. So as you can see, we basically built identical functions. However, when we passed in Betty, it stayed 13. And when we passed in Sandy, even though it was 13, it changed it to 66. So now you can see, whenever we pass, let me move this down right here. Whenever we pass a variable into a function, we can do it in one of two different ways. We can pass a copy of it like we did in the Betty case, pass by value, and what this does is it basically X is a copy of Betty. It doesn't have any access to Betty itself. It's just a variable with the same value. So then we set X equal to 99. It's just setting 99 equal to that copy, not Betty itself. So if we pass by reference, what we do is we take the memory address of that variable, and remember, your memory address is some part on your computer. It doesn't make a copy of it. It passes in that memory address itself. That memory address has the value of 13, and we're saying, all right, now take that memory address and set it equal to 66. So no copies involved here. It's taking that same address the entire time and changing the value of it. So now you can see the difference of whenever we use a function like this, it makes a copy, and whenever we use a function like this, it works with the direct variable itself. So that way, whenever we ran the two functions right here and printed it out on the screen, that's why Betty stayed the same, because that copy had no effect on the original, and Sandy changed because it did indeed change the value of that one address. That variable was only at one address, and we passed it in so it had direct access to it. So I am out of breath, and hopefully you guys understand at least the concept of pass by value and pass by reference. Just remember, when passing by value, you're passing in a copy. When passing in reference, you're passing in the variable's address. If you understand that, you're good to go, at least for now. So in the next tutorial, I'm afraid we're not done. Oh, I got like phlegm in my throat. I can't talk. I just had a milkshake from McDonald's, and anyways, moving on. So in the next tutorial, unfortunately, we're not done covering pointers yet. So yep, more about pointers. I'm sorry. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome to your 40th C++ tutorial, and in this tutorial we're going to be taking a quick break from pointers, and we're going to be covering something called the size of function. Now the size of function is actually a function that you use a lot when working with pointers, but for this demonstration, just to give you guys an idea of what the size of function does, I don't want to include pointers because that's too much information for one tutorial. So we're just going to be seeing a simple demonstration of the size of function, and then later on we can apply it to pointers. But for now, let's go ahead and check it out. So what the size of function does is it basically determines the size of either an array or maybe a variable or a constant. It pretty much determines the size of something in bytes. And remember, bytes is just the size of memory, like 4 bytes, 1 byte, yada yada yada. So let's go ahead and make a basic variable. I don't know if I taught you guys the char yet, but char just is a variable of character type. It basically stores a character. So let's go ahead and make a variable char, and we'll call the variable c. And let's go ahead and see how the size of function works. So you go ahead and you type size of, and then in the parameter you type what do you want to get the size of. Well, let's just go ahead and get the size of this variable right here, and then we'll just end that line. And that's it. You go ahead and run it, and it outputs the size of character, which is 1 byte. So any character we store in our computer, it takes 1 byte of memory. Alright, simple enough. So let's go ahead and make another type of variable, like an integer variable. So how many bytes do integers take up on our computer? Well, if you don't get the same number as me, don't worry, but because every computer is a little bit different. On my computer, an integer takes up 4 bytes of memory. So again, if you have like 2 or 8, or maybe you have 4, same as me, don't think you're running the program wrong. Every computer stores memory differently. Mine says 4. So anyways, we know that a char takes 1 byte, an integer takes 4 bytes, and now let's go ahead and see double. Well, we already know an integer can store numbers without a decimal point, and those take up 4 bytes. A double is pretty much a more precise integer, so that's why whenever we run this, we're expecting to see 8 bytes or something higher than 4. And the reason that doubles take up more memory than integers is because they're more precise. So anyways, what I want to stress is the more precise a value is, the more memory it needs to take up. So that's all I wanted to stress. And now let's jump into something else. Instead of these basic data types, let's say we had something like an array. Now, an array is basically like 10 integers strung together, or maybe 15 doubles strung together. So let's go ahead and make a double array, and we'll call it Bucky, and it can store 10 doubles. Now remember, a double took up 8 bytes on my computer. So we have an array of Bucky, and it has 10 doubles. We're expecting to see 10 times 8 bytes. So this entire array should take up 80 bytes of memory. So let's go ahead and see if our prediction is right. Size of Bucky, you go ahead and just write the name of the array in there, and then go ahead and end line, not ned line, end line, there we go. So now whenever we run it, check it out. 80 bytes right there, and that is because each double is 8 bytes, and we're going to store 10 of them, so that's why this entire array took up 80 bytes of memory. Simple enough, but you're saying, alright, so I know what the size of function does, but why would I ever need to know, the size of bytes? I mean, that's the computer's operating system's problem. I really am just a programmer. I don't have to worry about memory that much. Well, one useful way you can use this function right now, before I, jump into pointers and all that stuff, is maybe you want to find out how many elements are in an array. So, maybe you had the user make an array or something, and you don't know how many elements it had, and you needed to know how many elements this array had in order to make a calculation. Well, of course, we know that this array has 10 elements, but say we were trying to figure it out anyways. Something you can do is this. Cout. What you can do is get the size of Bucky. Remember, this would give you the 80 bytes. This is the entire size of your array, 80 bytes. And what you do is divide it by the size of one element. And to do that, just go ahead and write size of Bucky 0, which is the first element. And then whenever you print it out in line, you should get 10. So let's go ahead. Here's the 80 before, and now we get 10, which means 10 elements in our array. And again, why did this happen? What we did is we took the entire size of our array Bucky, which was 80 bytes, and we divided it by one element size, which was 8. So 80 bytes divided by 8 bytes gives us 10 elements. So again, anytime you want to get the number of elements in your array, say you couldn't see that line for some reason, take the entire size of your array and divide it by the size of one element, and your answer is how many elements you get in your array. So again, here's a basic example of the size of, again, all we did is find the size of different, data types, arrays, variables, yada yada. But later on, we're going to be using this to work with pointers, and it's actually a lot more useful than just finding how many elements are in your array. So, now you guys know the size of. Now, whenever I teach it later on, you won't get confused. So for now, thank you guys for watching. Don't forget to subscribe, and I will see you in the next video. Alright guys, it's time to jump back into pointers, and specifically in this tutorial, I'm going to be covering pointers and how we can use math with pointers. And even more specifically, I'm going to show you guys, how to add integers to pointers and why the result isn't exactly what you might expect. So let's go ahead and start off by building a basic integer array. I'll call mine Bucky, and it can hold 5 integers. Now we already know that each integer on my computer takes up 4 bytes of memory. On the older computers, they usually either take up 2 bytes or 4 bytes. On some of the newer computers, they might take up 8 bytes. So, if you're running this tutorial with me and it's not the exact same results, don't freak out. It's just how your computer stores integers. So let's go ahead and make a couple pointers. I'm going to make a pointer named BP0, and this is going to be equal to the address of Bucky 0. In other words, it's going to be equal to the address of the first element. So let's go ahead and print this out right now and see what the address is. So just give it a nice little prompt like BP0 is at memory address, and let's print out BP0. That'll print out the memory address, and of course let's end that line. So now let's go ahead and build and run this, and we see that BP0 is at the memory address FF08. Okay, simple enough. So since we built an array, and since we know that each integer takes up 4 bytes, we're expecting the next pointer Well, let's go ahead and build a couple more pointers first. And we're expecting the next pointer to be at memory address 4 away from that. So if that one was at 8, the next one will be at 12, and the next one will be at 16. So let's go ahead and this will point to the second element, and this will point to the third element. So now let's go ahead and print all these out on the screen, and when I do, we can clearly see what's going on. 1 and 2 and 2. So basically we're printing out the memory address of this, and then the memory address of this, and then the memory address of this. So let's go ahead and print this out and check it out. BP0 is at location FF00. And since we're storing integers and they take up 4 bytes, the next one is 4 bytes away, FF04. The next one is 4 bytes away, FF08. And if we were to go on, I'm not gonna, but we can clearly see that each integer takes up 4 bytes of memory on our computer. And since we're building an array, all these integers are stored one right after each other. So that's why each element in our array is stored 4 bytes after the next one. Basically, whenever you make an integer on your computer, it reserves 4 bytes of memory for it, and nothing else can go inside that memory except that integer. So let's go ahead and say we were playing around and we decided to do something stupid like BP0, and we decided to add 2 to this memory address. So let's go ahead and put plus equals 2. Well, now let's go ahead and print out the address of BP0 again and see what happens. Remember, before it was stored at the address FF00. So now when we added 2 to it, we should probably be expecting this to be at FF02. But let's go ahead and run this to see what happens. Okay. Like before, the first element was stored at FF00, then FF04 for the next one, then FF08 for the next one. But what we did is we took this first one, FF00, and we added 2 to it. So we should be expecting FF02, right? Makes sense. That's how it works in our brain. But our computer said BP0 is now at FF08. Well, that was the address of this one right here. So what is going on? What happens is because pointers don't work like math works in our head. Whenever you add integers to a pointer, it doesn't change the memory address of that pointer. It only changes what element it's pointing to. So for example, whenever we run this and we tried to add 2 to this pointer right here, it didn't change the memory address right here. What it did is said, alright, I'm going to take your pointer and add 2 to it, and basically I'm going to point to whatever is 2 elements away. So again, what I want to stress is, whenever you're working with math and pointers, you're not changing the memory address, you're only changing the element that it points to. So again, you're not changing this piece of memory right here, you're changing what element it's pointing to. Simple enough. Like, I have a really hard time explaining that, but you guys can see what's going on. So for example, if I put BP0++, it wouldn't change it to FF01. It would change it to FF04 because, well, let me go ahead and prove it to you guys first. So we added 1 to this. It didn't change the memory to 01. It changed it to 04 because 01, it would overlap this one, which would overlap this one, and cause a whole bunch of problems. So what it does is, instead of changing the memory address, it just says, alright, if you're adding 1 to this pointer, then you probably want to just point to this pointer right now. So that is basically how pointer arithmetic works. It basically, instead of changing the memory address, it just changes where it points. Again, you guys can clearly see in this example what's going on. So, just look at it and you guys can probably understand it a whole lot easier than me trying to explain it. So there you have it. That's how pointers work with math and why you might be getting a different result than you might expect. So thank you guys for watching. Don't forget to subscribe. In the next tutorial, no idea what I'm going to be covering, but I'm probably going to McDonald's, so you guys chill out, wait a couple seconds, and I guess I'll see you guys in the next tutorial. Alright guys, in this video I'm going to be showing you guys what the arrow member selection operator does and when you should use it. But I was thinking, and I was like, you know what, we haven't created a new class in a while and it actually would be kind of useful in this tutorial. So let's go ahead and start working with a new class. So just a refresher from, I don't know, I probably did this like 20 tutorials ago. In order to create a new class, press File, new class, and then you go ahead and name your class anything you want. I'm going to name mine Sally, and I don't think we covered destructors yet, so let's go ahead and uncheck those and make sure we're working in the same directory as our main CPP so everything looks good. Go ahead and click create, and of course it's going to give you these two confirmation. Yeah, of course I wanted to do both of those. And now we got two new files, a Sally header file and a Sally CPP file. And remember, the Sally header file is basically where we're going to be making all our prototypes, and the Sally.cpp is where we're going to be doing the actual coding. So in our main CPP, we need to do a couple housekeeping things first. Go ahead and copy these, and of course it's your IOStream and namespace, and go ahead and copy it right in here. And of course we need the Sally header. Oh, I forgot. I always try to right click and select copy, but there is no copy. So anyways, go ahead and get our Sally header and paste it in our main.cpp. So basically the beginning of main CPP and Sally CPP should look pretty much the same. So now a couple things I like to do. Actually, the only thing I like to do is this. Go ahead and take out this comment because useless comments annoy me. And I guess I might as well go over this one more time. Inf, def, and define, and endif, all this means, this stuff in green right here, they put that there in every class they automatically build for you, and it pretty much means don't include a header file if you don't need it. This literally means if not defined Sally header file, then define it. So basically whenever you're running it in main CPP, all these classes are going to have it in, it's like if you already included Sally header file, then don't include it again, because you only need to include it once, obviously. So that's what all that means. So now all my explaining, we can finally get to the tutorial. So in this tutorial, the first thing we need to be able to do is I'm just going to create a random stupid function in the Sally class. So in order to do that, let's go ahead, and it's not going to return anything, so I'll just put void and then write your class name Sally, and then we need that double colon operator and then print crap. Oh, it already have my my favorite function stored for me. So basically we need this double colon operator. Again, this is a reminder because without it, it wouldn't know what function print crap belonged to. So we're saying, alright, this belongs to the Sally class. And, you know, if we didn't have that, then we would get an error. So write your class name, double colon, and then your function name whenever you're building functions. So print crap, and all we're going to have this do is cout, write something stupid like, did someone say steak? And end line. So basically we have the Sally class, and we have our constructor function, which doesn't do anything, and we have this function called print crap that pretty much prints crap out on the screen. So now we can go ahead and prototype it, and remember, whenever you're prototyping in class, go ahead and copy that. And actually what we need to do is this. Don't even copy that. Just under your public, write void print crap, and that's all we have to do to prototype it. We don't have to copy it because this Sally is basically telling this header file it belongs to the Sally class. But whenever we're prototyping the class, it already knows that, of course, we're working on the Sally class. So that's why we don't write something like this. Sally, like that. So, you know, just a nice little note to keep track of. So now that we have basically a class made with one function in it, I want to talk to you guys about what I'm going to teach you in this tutorial, and that is the arrow member selection operator, and that's this little dinghy right there. You're saying, what the heck is that? What's it do? What's the point of it? Well, in order to explain to you guys what that does, let's go ahead and first build a Sally object. So Sally, make a Sally object called Sally object, and we know with our Sally object, then we can access the stuff inside the Sally class using Sally object, using the dot, and then go ahead and, you know, use whatever you want to use, a variable or function or whatever. So now when we go ahead and build and run this, it says, did someone say steak? Pretty cool, huh? So we know that these facts are true. In order to access stuff from the Sally class, we need to use a Sally object, and then we can use that by putting the object first, using a dot separator, and then writing whatever we want to access after it. So that is how we access stuff inside the Sally class. But now I want to teach you guys that there's a different way to access the stuff inside the Sally class. This is by making a pointer to the Sally object. So let's go ahead and see what I'm talking about. In order to make a pointer, you go ahead and write what type of data you're going to hold. I'm going to be holding Sally type of data because a class is actually a type of data that you create yourself. And now you go ahead and name your pointer using pointer, and I'm just going to name mine Sally pointer. And now we set it equal to the memory address of Sally object. So basically the Sally pointer is pointing to this object right here. Simple enough. So they're basically the same thing. I mean, I shouldn't even say that because a lot of people are going to be like, a pointer is the same thing as an object. But you know, they're basically the same thing. So now what we can do is we can use that pointer to access the stuff in the print crap class. I mean, excuse me, the Sally class. So let's go ahead and put Sally pointer, and you might be thinking, alright, so use the dot separator and then write print crap just like that, and I'll try to run this, it's going to work fine. But why am I getting an error message right here? And that brings me to the point of this tutorial. Whenever you're using a pointer to access stuff inside a class, you need to use something called the arrow member selection operator. So again, whenever we run this, it's going to work fine and dandy. So this is accessing it with the object, and this is accessing it with a pointer. Pretty cool, huh? So it's basically two different ways where you can access things inside a class. Right now I just want to show you guys how to do it, and then later on I'm going to show you guys when you would need to do it, but not in this tutorial. For this tutorial, I just want to make sure you guys understand this information. You have two different ways of accessing things inside of a class. One way is to use an object, and then you know the function name. And another way is to use a pointer and then the function name or variable name. Whenever you use an object, you use the dot separator. Whenever you use a pointer, you use the arrow. And that's actually pretty easy to remember because whenever you're using a pointer, it kind of looks like a pointer. So, I mean, can't get easier to remember than that. So that's all I want to teach you guys for this tutorial. Hopefully you understand the concept behind it. You probably don't understand why you would use one versus the other, but you will later on. So for now, just understand this, and don't forget to make sure that your beginning of all your .cpp files are basically the same. So that's all I have for you guys for this tutorial. Thank you guys for watching. Don't forget to subscribe, and I guess I'll see you guys in the next video. What's going on, guys? Welcome to your 43rd C++ tutorial, and in this tutorial I'm finally going to be explaining to you guys those things called deconstructors. You know, whenever we created a class and it said automatically create a deconstructor or whatever and we had it unchecked, well, I'm going to explain to you guys what they are, when they're used, and then, you know, when we're creating a class from now on, we can understand what they mean. So the first thing I want to say is a deconstructor is basically code that runs automatically upon the destruction of your object, and that's the technical term for it. But basically, at the end of your program, when all your memory is getting freed up and your program's ending and all your objects are getting destroyed and you want a little bit of code to run, that's when your deconstructor is going to run. So you know, as soon as you create an object, the constructor runs. Well, as soon as it's deleted, the deconstructor runs. So that's basically, you know, when that happens. So let's go ahead and first, before we even start talking about a deconstructor, let's go ahead and type some code into our constructor, like cout I am the constructor, and make sure you spell it wrong, and then end that line. So now we can see if we go ahead into main.cpp and create, come on keyboard, type regular, and create a Sally object. So Sally so, and then after this, we really, fire truck, are you really gonna run right behind me in the middle of this tutorial? No, that's not annoying. Well, that was kind of annoying, but anyways, continuing on. So we went ahead and we created a Sally object. Now, as soon as we create this object, our constructor is going to run, and all our constructor does is shout out, I am the constructor, on the screen. So now we go ahead and type another line of code like cout OMG, what DF is this on my shoe, or something stupid like that, and end that line. So let's go ahead and run our program so far. So our object was created and it shouted out, I am the constructor automatically. We didn't have to call a specific function, it just did automatically. And then our program ran that said, OMG, WTF is this on my shoe? So now let's go ahead and add a deconstructor. Now to create a deconstructor, it's as simple as this. The name of your deconstructor is the tilde, and that's above the tab on your keyboard, but under the escape, well, that's where it is on mine. If you look left of the one, you see that little squiggly sign? It's called a tilde, I think. At least that's what I call it. So go ahead and type that, and then type your class name, which is Sally. So basically, your deconstructor looks the exact same as your constructor, except it has that little squiggly tilde above it. So now let's go ahead and create the body of it. And again, it's the exact same as your constructor, except it has that little squiggly tilde right before it. So another thing I want to point out is this. Whenever you're creating a destructor, it has no parameters. No matter what, you can never give it parameters. Also, it never has a return value. You can't even give it void. And aside from that, there's no deconstructor overloading. You have one deconstructor and that's it. You can't have different versions of your deconstructor. So basically, it's a Really? Another fire truck? Are you serious? This is gonna run right past me. You guys hear that? Yeah, I'm just continuing on with my tutorial anyways. And I really don't feel like redoing it, so sorry guys. So basically, whenever your object is first created, your constructor is going to run. And whenever your object is automatically deleted or, destroyed, I mean, that's a technical term for it, your deconstructor is going to run. So let's go ahead and type some code and cout I am the deconstructor. And make sure you type that very wrong. And then go ahead and end that line. And let's go ahead and take a look at our main, and I'll explain to you guys what's going on. Our first line of code, we created a Sally object. So right after it, right around here, our constructor is going to get called, and our constructor shouts out, I am the constructor. So then, after this, it goes ahead and it runs the program. OMG, WTF is this on my shoe? So the next line of code is going to be this, excuse me. Now, after this line of code is running, it's going to see that it got to the end of the program. Whenever it gets to the end of your program, C++ automatically destroys all your objects. So, by default, automatically it's going to call your deconstructor for this object right here. So let's go ahead and build and run this and see what happens. I am the constructor, OMG, WTF is this on my shoe, and I am the deconstructor. So as you can see, it automatically called the deconstructor and constructor for us. So another thing I want to point out is when your program is finished running, that's when your deconstructor is going to get called. So again, your constructor and your deconstructor, you don't have to explicitly call them like you would another function inside your class. They get called automatically. And again, remember, whenever you're creating your constructor, it's basically a duplicate of the constructor, except you need a little tilde right there. And unlike a constructor, you can't overload it, it can't have parameters, it can't have a return value, and make sure you don't even put void as the return value. It's basically a dumbed down, very simple function. So that's the very basics of a constructor and a deconstructor, and later on I'm going to be showing you guys why a deconstructor is useful other than just printing out stuff on the screen. But for now, just understand the concept, and I'm going to go ahead and help these fire trucks put out a fire, so hopefully in the next tutorial they will stop running past me. But for now, thank you guys for watching, don't forget to subscribe, and I'll see you guys in the next video. What's going on, guys? Welcome back to your 44th C++ tutorial, and in this tutorial I'm going to be teaching you guys about a couple things, specifically about the keyword const, which stands for constant. Now, whenever you use the keyword const, it means that whatever you use it on, you typically use it on variables and stuff. It means that that variable remains constant throughout your program, aka it can't be changed or modified in any way. So let's go ahead and take a quick look at that. Say you have an integer variable x and you set it equal to 3 whenever you first make it. And then later on you want to change it to something like 5. Well, your program is just going to run fine, and whenever you try to print out x or use it in any other way, it's going to run perfectly fine as expected. So what the constant keyword does, and that constant keyword is const, Whenever you're creating something, you put the constant keyword in there, and it's pretty much telling your compiler, alright, now whenever I create this variable, I'm going to set it equal to value, and I don't want you to change it for the rest of the program. So now whenever you try to change it to something else like 5 and try to run this program, it's going to get an error because it's saying, hey Bucky, you called this variable a constant, you promised me you weren't going to change it, and now you lied to me right there. So that's why I'm giving you an error. So that's basically what the constant keyword does. It makes sure that whatever is constant is unable to be modified. So that being said, later on in your programming, you're going to learn that some objects you create, you don't want them to be able to be modified. Some objects are just regular objects, and other objects you want constant. You don't want them to be able to change. So you use this constant keyword whenever you create an object. So therefore, you have an object that can't be modified, and you might be thinking, alright, so I can just use it with normal functions. Not exactly. Whenever you have a constant object, you can't call regular functions with them. You can only call functions that they themselves are constant. So constant objects need constant functions. And of course, whenever you create a constant function, you need to make sure it's constant both in the prototype in the header file and in the definition, aka the C++ source file. So let's go ahead and just create a regular function first, and then I'm going to be running it aside a constant object. I'm going to be doing a couple things. So let's go ahead and make a Sally function, and we'll just name it like print shiz. And this is just a regular function. I'm not doing anything weird yet. So cout, just type I am a regular function, and then end that line. And then of course, since we created a function, we need to prototype it. So then it is void, I think I named it print shiz, just like that. So now we can see that we can just go ahead into our main program, create a Sally object, and then we can use that Sal object to call our regular functions such as print shiz, just like that. And whenever we run it, everything's going to go smoothly. It's going to print out I'm a regular function. So I did that, and we already know that. So let's go ahead and jump into constant objects. Now whenever you create a constant object, you do so doing this. Throw your keyword const before you create your object, and everything else is basically exactly the same. You type what class you want it to be from, and also what your object, like const object. Looks like a pretty good name. So you're saying, alright, all I need to do is const object, and then I can go ahead and call my other methods like print shiz. Well, whenever we try and do this, we get an error message because it's saying, alright, you created an object that it was constant, and you try to use a function that wasn't constant. See, this function isn't constant, it's just a regular function. So we need to build special constant functions whenever we create a constant object. So we're saying, alright, let's go ahead and do that then. So let's go ahead and create another method, another function. I'm talking in Java, another computer programming language. But let's go ahead and create another special constant function. So void Sally, let's just name this print shiz2. And in order to create a constant function, you go ahead and you type the keyword constant right after your function definition. So const. So now what happens is right after this, we build the body for it. So this is just going to cout I am the constant function, just like that. And of course, we'll end that line right there. And now, like I said before, we need to prototype it as a constant too. So we need to basically tell every single file that we're going to be working with constant objects. And in order to prototype it, here's what we do. Go ahead and just like before, type void print shiz. Yeah, that was called print shiz2, and you just write const right there. And now you're telling your compiler, alright, this is a constant object prototype. So a lot of people might think you do this, add the const before. Make sure you add it after the parameters, and you should be good to go. So now whenever we try and run this constant function with a constant object, remember, this is our constant object, and this is our constant function, print shiz2. Now whenever we try and run it, it should be good to go. I am a regular function, I am the constant function. Pretty simple. So as we can see, whenever we build objects, if we build a regular object, we can use the regular functions with them. whenever we build a constant object, we're telling our C++ compiler, alright, this object, we don't want anything to be able to modify it or change it. So it told us, alright, I can do that, but you need to build me some constant functions. If you do that for me, I'll run your program just fine. So that was our little deal we had with the compiler, and that's why this one ran with the regular function, and this constant object ran with the constant functions. So now you should understand how to prototype constant functions, how to create them, and also why constant objects need constant functions. And again, later on, you're going to be seeing why in like bigger programs, you need to be able to create some objects that you want to be able to make constant and why they're useful for your compiler. So for now, I just want to teach you guys the very basics. So in the next tutorial, we're probably going to be covering constants a little bit more because there's actually a lot to go over with constants in classes. So for now, that's all you get. Thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What's going on, guys? Welcome to your 45th C++ tutorial, and in this tutorial I'm going to be talking to you guys about member initializers. Now, I don't even know if I told you guys this, but a member is pretty much a fancy term for anything in your class. So when some people talk about variables, they call them members. It's basically anything in your class is a member of that class. So let's go ahead and let me explain this. We're going to probably have a bunch of variables in our class. Some of them are just going to be regular variables, and some of them are going to be constant variables. So we know constant variables have a couple of weird rules, and creating them is one of the weird rules. So remember, a constant variable is basically a variable that we can't change, and we also have to initialize it using a special it's a special syntax. It's called member syntax. Now the cool thing is we can also initialize regular variables this way, but you don't have that option of when using constant variables. You have the option of initializing regular variables this way or the way we learned before, but constant variables definitely need to be initialized using member syntax. So let's go ahead and first thing, let's go ahead and make two private variables. I'm going to make one just regular variable because it's going to be an integer variable. Reg var stands for regular variable, and I'm going to make another constant variable. So constant, just make this one integer as well, and we'll name this one const var. So now we have just a regular double variable and a constant variable. So now what I want to do is whenever we first create our object, let's go ahead and assign a value to this variable and assign a value to this variable. So our constructor is going to take two parameters, one value for this one and one value for this one. So go ahead and just type int a and int b, and we'll be tossing numbers in there later on. But now that we have values assigned to these variables, we're going to need a way to print it out on the screen. So go ahead and we'll make a function called print. Simple enough. So now we have a constructor that takes two values, assigns one to our regular variable, one to our constant variable, and then we'll print it out on the screen. So now we probably need to change our constructor around a bit. The first thing we need to make it do is take those two parameters, int a and int b. Now you're saying, alright, I probably go ahead and in the body, somewhere in here, I'm going to type all that syntax, that special syntax you've been talking about. But check it out. You actually don't write anything in the body. Yeah, think about that for a second. It'll freak you out. You actually don't write any of your code when initializing variables in the body. So you're saying, where the heck do you put it? And this is the weirdest place. You put it in between the parameter list and the beginning of the body. So between the parentheses and the curly brace, this is where you're going to put it. So that's what confuses the most people, and that's why they have a hard time understanding, because usually nothing goes here, but that's where we're going to be putting the syntax. Why they made it go here, I don't know. And the syntax for it was this. The first thing we need is a colon, and the colon tells C++ that we're going to be working with member initializer syntax. Now it's actually quite simple. All you need to do is write your variable name, such as regvar, and inside parentheses you give it an initial value, which this one we're going to be passing it in a. Now whenever you have multiple variables you want to set equal to, the initial value, you just separate them with a comma. It's basically just like a list. So our next variable is const variable, and this one is going to be equal to b. And what people sometimes like to do is put their variables on new lines, but it really doesn't matter. And another thing, make sure that you don't put a semicolon at the end of this. These aren't statements, it's just a list. It knows when you're done because the body is going to begin. So basically, start with a colon and make a list using this syntax: variable, value. If you have another one, separate with a comma, variable, value. So I know it's a really weird syntax, but what this is going to do is we're going to be creating a constructor that takes two values and it's going to be setting them equal to a regular variable and a constant variable. And like I said before, whenever you have a constant variable in your class, this is how you need to do it. Of course, we can set this variable equal to, initialize it like we had before, but, we might as well use this list since we're, learning this tutorial. So now let's just go ahead and make another function, void print, just to print this stuff out on the screen. So void, okay, there, void Sally print, and all this is going to do is be like cout regular var is, and then just put reg var, and then put constant variable is colon const var, just like that. And now let's go ahead and end that line, and you guys can't even see. Yeah, you guys still can't see. There we go. End line. Definitely spelled that wrong. End that line. So now it's going to print out our regular variable is 10 and our constant variable is 20 or something stupid like that. As long as I spelled this right, let me just double check. Alright, we should be good to go. So now all we need to do is create an object in our main. So let's go ahead and create a Sally object. Just name it SO. And remember, this is a constructor, so it's going to take two parameters. Just make like 3 and 87. Two random numbers. Just make sure they're integers. And now, as soon as we created that constructor, it's going to take 3 and assign it to our regular variable. And it's going to take 87 and assign it to our constant variable. So now regvar equals 3, constvar equals 87. So now when we call that print method, and I don't like typing stuff on the first line for some reason, so.print, it should print that out unless I forgot a semicolon or something. So let's go ahead and see and check it out. Regular variable is 3, constant variable is 87. Nice spelling right there. That actually does spell variable. Well, close enough. So anyways, one last time, here is what we did. We had a constant variable in our class, this pesky little thing right here. So whenever we have a constant variable in our class, we can't initialize it like before. We need to initialize it in a special way, and that's through the use of member initializers. Whenever you want to create a member initializer list, and basically this is just a fancy term for setting your variables equal to values, you need to make a list in between your parameters and the body of your constructor. And make sure whenever you're making that list to start with a colon. That tells C++ you're going to start making a member list. And just use this syntax, and don't forget to separate each variable with a comma. And then, of course, whenever you create your object, you need to pass it in the two parameters it needed, because right here it said it asked for two parameters. And then later on we can just use those variables in any old function just to print them out, like regular variables blank, constant variable is blank. And then, actually, I'm getting kind of sidetracked. You guys know how this function works. But actually, I want to ask you guys this now that I'm thinking about it. Is there a way to like word wrap? Because like whenever I'm working with this, you see I was going off the screen. Let me know if there's a way to automatically word wrap so you guys, well, I guess I'll just scroll from now on. I don't like my lines of code on new lines anyway, so forget that like the last 30 seconds of this tutorial. But anyways, now that you guys know how member initializers work, yeah, I'm just gonna quit this tutorial now. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome to your 46 C++ tutorial, and this tutorial might be a little longer than normal. I might even have to split it up into two tutorials because I'm going to be talking about a subject called composition, and I'm going to need to build a few classes. So anyways, composition is the idea that You know, whenever you build a class, it has members, aka variables, and usually a class just has some regular functions in it and some regular integer variables, maybe a couple string variables. Well, aside from just functions and regular variables, a class can also have objects of another class as its member. So you can stick objects inside classes as well. So you know, like whenever we created an object, we always created it in main right here. Well, you can actually have it inside other classes. So let's go ahead and take a look at that. And again, composition is what it's called. So the first thing we need to do is create a couple new classes. So file, new class. I know you can't see that, but I already showed you guys before. So what I'm going to be doing is I'm going to be creating one class called birthday, and that's pretty much just going to be storing a birthday, which would be mine, like 12/28/86. That's its only job. So go ahead and create that and go ahead and press yes and okay. So now we have a blank birthday class with nothing in it except, the template. So now what I want to do is build yet another class. So file, new class, and I'm going to name this class people. Now go ahead and uncheck that and go ahead and press create. And of course, yeah, I want to add it to my project and go ahead and whatever that thing said. So what I'm going to be doing is every single person who's live has a birthday. So wouldn't it be cool if inside this people class we can store a birthday or a date as one of its members? So I'm basically going to be taking an object from the birthday class and storing it inside the people class and then running the main program from main. So let's go ahead and get started first. So in your birthday header file, go ahead and delete protected because I didn't teach you guys that yet. But in our private, we're going to have three private variables: int month, which was the month of the birthday, int day, and int year. So that's, oh man, I cannot talk. I keep saying for some reason. Anyways, this birthday class has three variables. It has a month, a day, and a year. And what we're going to be doing is in our constructor, we're going to be passing in that information. So let's just go ahead and pass in int m for month, int d for day, and int y for year. So we're going to go ahead and set the birthday whenever we create the object. So now it's going to have one more function in it, and that's void print date. And all this is going to do is print out the birthday on the screen. Simple enough. So now let's go over to birthday.cpp, and it already includes birthday header, but we already know that we need to include this stuff as well. So go ahead and copy this and paste it right under here. So now it includes everything we need it to include. So of course the first thing we do is delete this comment because I hate comments. And in our birthday constructor, remember, it takes three pieces of information: a month, a day, and a year. So let's go ahead and just actually steal this from over here, copy that, and paste it right in there. So now it has three pieces of information that we passed in: a month, a day, and a year. So what we can do is use those values to set equal to the variables we needed. We have a month variable, a day variable, and a year variable, and all of those variables need a value. So go ahead and for month, set it equal to the value you passed in for m. For day, set it equal to the value you passed in for d. And for year, set it equal to the value you passed in for y. So as you can see now, whenever we pass in our three pieces of information, it sets m to month, d for day, y to year. And this is going to be 12 equals month, 28 equals day, and 1986 equals year, because that's when I was born, so that's what I'm doing. So aside from that, we already know that we have to create this one extra function called print date. And all this function does is print a date out on the screen. So let's go ahead and make that right now. Void birthday print date. It already knows that we needed it. And of course, it doesn't take any parameters. And all it does is print out something on the screen. So cout month, day, and year. And well, might as well go ahead and add a end line for that. So what it's going to do is print out the month slash day slash year slash. And I know that this format's kind of weird. I think it's different in England and Great Britain, but for those of you overseas, yeah, this is how we do things here in America. We also measure like lengths with 12 instead of 10. So yeah, that makes it a whole lot easier, like 12 inches in a foot. Who the heck decided there should be 12 inches in a foot instead of just, 10? 10 would make things a lot easier, but we have this stupid American system over here. But anyways, there's my little rant for the day. Now I can go ahead and work in my other class. So after we're done working with the birthday class, and check it out, we go ahead and we made everything here and everything here. We are done with it. Let's hop over to our people class, and the first thing that we need to do is include a couple of things. Whenever I'm making a people object, I'm going to be giving it a name like Bucky Roberts. So since we're going to be passing it in a name, we need to be able to work with strings. So include string, and that'll include the string class. And aside from that, we also need to include this birthday header file. So go ahead and copy and paste. And the reason we need to include this birthday header file is because as one of the members, aside from just regular variables, we're also going to be storing a birthday object in this class. So if we don't have this birthday header file, it will think we're just trying to make a weird variable or something, and we'll get an error. So that's why we need to include the birthday header file. And aside from that, we need using namespace standard to get all our standard, people header, there you go. All our standard crap. So let's go ahead and start working on the people class. So the very first thing, well, I should probably tell you guys, is what information is going to be in this class. Well, as I said before, everyone has a name and everyone has a birthday. So go ahead and put string name, and go ahead and there's a birthday. We're going to go ahead and use a birthday object as a member of this class. So whenever you want to use an object of another class inside this class, you go ahead and first type the class name, birthday, and then you go ahead and give it a variable like date of birth. So now this class, people H, every person in this class is going to have a name and a date of birth. But we're not just going to pass it in the date of birth, we're going to pass it in a date of birth object. Pretty cool, huh? So aside from that, we might as well go ahead and we're going to be passing in the constructor. So we're just going to pass the name in as a variable x, and we're going to pass the birthday in as a birthday object, so we'll call it BO. So whatever name we pass it in for x is going to set it equal to name, and whatever birthday object we pass in at BO is going to set it equal to date of birth. Pretty cool, huh? So now let's hop over to people.cpp, and I think I'm going to wait to do this until my next tutorial because this one's getting kind of long and I hate long video files. They always mess up if they get too long. So in the next tutorial, I'm going to show you guys how to write your people.cpp class and also how to tie everything together in main so the program works fine and smooth. So thank you guys for watching. That's all you get for now. So hopefully I'll see you guys in the next tutorial. Alright guys, welcome back to your 47th C++ tutorial, and this tutorial is just a continuation from the last tutorial. So what we did in the last tutorial is we pretty much were working on the people.h header file, and now we're going to hop over to the people.cpp to start actually building our functions. But now that I think about it, let's go ahead and hop back over to the people header file, and aside from just the constructor, let's go ahead and build another function just so we can print it out. It'll make everything a lot easier to see. So let's go ahead and make a function called, what was this one called? I want to make sure I don't name the same thing. This one was called print date, so we'll call this one print info, I guess. So print info. So this is pretty much going to create our object, and this is going to print out the information. Simple enough. So now that we have this people class created, in our constructor we said it was going to take two things. Every person needs two pieces of information, a name and a birthday. So what we need to do is we need to assign the name that they passed in and the birthday that they passed in to the private variable's name and date of birth. So in order to do that, what we need to use is a member initializer list. Anytime you're working with a class inside of another class, you need to use a member initializer list. So go ahead and remember, don't put it inside your body right here. You put it between your parameters and your body. And again, all a member initializer list is, it's basically setting name equal to x, and it's going to set the variable date of birth equal to what do we pass in? BO. So BO. And also remember that you don't put a semicolon at the end of this. It already knows it's done because the body will start. So that's all we need to do for this right here. So again, we're going to be passing in two pieces of information. We're going to be passing it in a string and then a birthday object. It's going to take that string and set it equal to name, and it's going to take that birthday object and set it equal to date of birth. So now this class has a name, and now it has a birthday object that you can use. So let's take that information and we can use that whenever we're building this other function, print info. So let's go ahead and yeah, I guess I don't need to do anything before that. So let's go ahead and put void people print info, and of course this print info doesn't take any information, but it's just going to print something out on the screen. So what it's going to do is see out your name variable, which would be Bucky Roberts, and then go ahead and write something like was born on, and then make sure you don't end the line because I want all this to be on one line. And then after this, in order to print that date, remember, we have a function inside our birthday class that prints the date right here. And we already passed in a birthday object inside this class. So now this class has access to the birthday functions. So we can go ahead and use this date of birth object right here that we created in order to use this print date function. So let's go ahead and just write date of birth right there dot print date. Pretty cool, huh? So now whenever we print the info, it's basically going to say Bucky Roberts was born on 12/28/86. Pretty cool, huh? So now let's go over, ooh, wait a minute, I almost forgot to do this. We need to include a bunch of stuff inside this people class. I'll talk you guys through it. The first thing we need to include is our IO stream and STD because, you know, we need to include those basically in every class. And aside from that, we also need to include this birthday header right here. And the reason we need to do that is because whenever you're working with another class, you need to include the header. So, yeah, I definitely just messed that up. Accidentally highlighted something. So, one more time. Okay, let's not copy and paste it in random spots this time. Alright, so let's go ahead and in our main.cpp, everything looks good to go so far. Actually, what we need to do is, since we're going to be working with birthday objects and people objects in this one, we need to include those headers as well. So go ahead and grab this and include it right there, and go ahead and grab this and include it right there. So basically, you see, whenever you're working with the object, you need to include it. Simple enough. So check this out. Since the people class, in order to create an object, you need a birthday object. Whenever we run our main, we need to create that birthday object first. So remember, in our birthday object, when we first create it, our object needs three pieces of information: a month, a day, and a year. So let's go ahead and create a birthday object, if I spell it right. Birthday, and we'll just name it birth object, and it needs those three pieces of information: a month, a day, and a year. So now we have a birthday object created called birth object, and this birthday object pretty much took month, day, and year and set it equal to 12/28/86. So now we can go ahead and create a people object. People, I'm just going to name mine Bucky Roberts. And you're saying, alright, well, what information does the people class need? Well, whenever we create a people object, it needs a string as the name, and it needs a birthday object right there. So first, let's give it a name, Bucky the King, and the second piece of information it needed was a birthday object. Well, it just so happens that we created one up here, so let's go ahead and pass that in right there. So after this, what we need to do is might as well just print out the info right here. So remember, in the people class, we had a function called print info, and it just printed out the name and the birthday. So go ahead and type your object name, Bucky Roberts dot print info. And remember, it doesn't take any parameters. And let's run this and see how many errors I got. 1. So hold on one. And alright, I see what's going on. Alright, see this, whenever we created this constructor, we forgot to pass it in the parameters. So just go ahead and copy these parameters, copy, and paste. So hopefully that's the only errors we got, and it looks good to go. So Bucky the King was born on 12/28/1986. Works awesome. So let me talk you guys through one last time what we did. We just created a basic birthday class, and this birthday class had 3 variables: a month, a day, and a year. So whenever we created a birthday object, it took that month, day, and a year and assigned it to the 3 birthday variables: month, day, and a year. So we got the birthday class taken care of, and then we decided to build another people class. Now the people class, whenever you built a person, it needed 2 pieces of information. It needed a string, which we gave it Bucky the King, and it needed a birthday object. So when, for example, whenever we had a birthday object right here, we could pass it in second. And what it did is, in the main program, it took the name and set it equal to the variable name, and it took the birthday object and set it equal to the object date of birth. So that basically gave us access to the birthday class. So from there we were able to use date of birth and the function in the birthday class to print out the birthday. So basically whenever I run this, this is a function from the people class, and this is actually a function from the birthday class. We just tied them together in one function right here. Pretty cool, huh? So that is basically what composition is. Composition is basically using other classes inside your class, using objects of other classes inside your class. That's all I'm going to go over for composition now. Hopefully you guys understand it. If you don't, definitely go check out my forum and just type in whatever question you have, and a ton of people are willing to help you. But for now, that's all I have for you guys. This was a pretty long tutorial, so go take a break, go grab a milkshake or something, and when you're done, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Welcome back, guys, to your 48th C++ tutorial, and in this tutorial I'm going to be going over the keyword friend. So basically every class can have friends, and a friend of the class is something that's totally separate from the class, but it still has access to the stuff inside your class, like your variables and your functions. So in other words, if a class wanted to have a function, it can make that function its friend. And now that function had access to the variables and the functions inside the class. Pretty cool, huh? So let's go ahead and take a look at it. So the first thing we need is a class, and I'm going to name this class Stankfist. So let's go ahead and make our class right now. The first thing I like to do is get everything set up. So public and private. So this class is going to have one private variable, an int stinky variable. So now the only thing that has access to the stinky variable is whatever is already inside this class. So first of all, let's go ahead and build a constructor for this Stankfist, and all this constructor is going to do is take that stinky variable and set it equal to 0. So now as soon as you create a Stankfist object, and make sure I capitalize that, consistency on my fist, it's going to take this stinky variable and set it equal to 0. Simple enough. So now what we need to do is we need to build a function. So let's go ahead and build a function outside. Actually, let's go ahead and make it right here. So in order to make a function your friend, the very first thing you need to do is prototype it inside your class. So go ahead and put void. We'll name this function Stinky's friend, and we'll go ahead and as a parameter, it's going to take a Stankfist object. So Stankfist, and we'll just name this object SFO for Stankfist object. So as a parameter, it's going to take an object of this class. So you're saying, alright, so that's all you do in order to make it your friend, prototype it inside your class? Well, no. In order to make this function a friend of this class, before the prototype, you need to type the keyword friend. Now this function has access to everything inside this class because it's its friend. So now, when we go ahead and copy this, and paste it and create it, we can use the Stankfist object to access all the stuff inside the Stinkfist class. Pretty cool, huh? So first of all, let's go ahead and change this stinky variable equal to something. So using our Stinkfist object, let's go ahead and access the stinky variable and set it equal to 99 or something different than 0. And now let's go ahead and just print it out on the screen. Cout SFO stinky variable end line. So basically what this does is, even though there is a function right here, you can see that it's totally different, totally outside this class. But since this class said, you know what, I trust this function, it's my friend, now this function has access to the stuff inside the class, such as stinky variable. And another thing I want to point out before I go on, a class has to give away its friendship. For example, this function and this function can't demand to be friends with this class. That's why you don't have the friend keyword right before it. This class needs to give away its friendship. Other places just can't take it. It's kind of like real life. You can't make someone be your friend. They have to accept you into being your friend. Make sense? Trust me, I tried it. Didn't work out too well. So let's go ahead, and now that we got everything set up, we can begin using this in main. So our inner main, what we need to do first is create a Stinkfist object. So Stinkfist, and I'm just going to name my object Bob. And now we can use that stinky's friend function right here. And of course, this function takes a Stinkfist object as its parameter. So let's go ahead and as its parameter, type in Bob. And now we'll go ahead and run it and check it out. As long as I didn't forget anything, it should print out 99. Pretty cool, huh? So even though we were using this function, and this function was outside this class, it was able to access this stinky variable and print it out on the screen. Pretty cool, huh? So basically, to recap one last time, we wanted to build a function that can access this class, but we didn't want to put it inside the class itself. So instead, what we decided to do was make this function a friend of the class. Now, whenever this function tried to use the variables and functions inside this class, it was able to because this class said, you know what, you're pretty cool, you can be my friend. So then we made a function that took a Stinkfist parameter as its object. So the first thing we need to do is create a Stinkfist object, and we pass it in as its parameter, and then it had access to the Stinkfist class. So that is basically the the lesson behind this tutorial. Whenever a class wants something to be its friend, it can access the members of that class. And aside from that, a class has to give away its friendship. Other functions can't just demand to be friends with it. It has to give it to them. So there you go. That's what friend means, and that's why it's useful. Again, this is a real simple example, but later on, I'll show you guys how it's really useful. So just stick around and you'll see. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What is going on, guys? It's Bucky, and welcome back to your 49th C++ tutorial. And in this tutorial, I'm going to be talking to you guys about the this keyword. But before I get into that, let me tell you guys, I'm sorry it's been a couple days since I made a tutorial, but I had to upload 200 PHP videos to YouTube. And do you guys have any idea how long it takes to upload 200 videos to YouTube? Quite a while. So anyways, that's my excuse. So now we can get back into C++. So let's go ahead, and for this example, I'm going to be making a new class because if I put it all in the same file, it's going to get a little clustered. So I'm going to name my class Hannah. And actually, I already messed up. Yes, okay. I actually made a deconstructor and I didn't want to. So let's go ahead and just delete that right there. And now we can get coding our project. So let's go ahead and first let's do a couple housekeeping things. Take this Hannah.h and paste it in here. And now I'm going to take this and paste it in here. So basically your .cpp files, see this one and this one, should basically look the same at the very beginning. And what I also like to do is get rid of this protected crap right there because we didn't learn that yet, so no use using it. So basically what this Hannah class is going to do is it's going to have a private variable, and we'll just name that int h. Now whenever we create an object, we're going to pass it in a value, an integer value, and all that's going to do is, say we pass it in 20, it's going to set h equal to 20, so that's all we're doing in the constructor. And then we have another method to print out the h variable on the screen, so we'll name that print crap because that's my favorite name for a function if you couldn't tell already. So basically what we're doing is we have a variable called h and we're going to print it out on the screen. And you're saying, alright, then what the heck's the point of this tutorial? Well, I'm going to be printing out this variable in three different types of ways. The first way is normal, like we talked about before, and the two different ways are using the this keyword. Now we don't know what those mean yet, so that's why you need to watch this tutorial. So now that I got you hooked and anxious, let's go ahead and start coding this constructor. So again, as I talked about, we are going to pass it in a variable, and we're going to be passing in a value. There we go. I got a little tongue twisted, and we're going to set the variable h equal to that value. So it will say we pass it in 66. It's going to take h and set it equal to 66. Simple enough. So now let's go ahead and start coding our print crap method right here. So let's go ahead and make void Hannah print crap, and it's not going to take any parameters. Like I said, it's just going to print some crap out on the screen. And let's go ahead and make a template first, and inline. So this is what I do whenever I code by myself. I probably shouldn't do this whenever I'm making tutorials, but I basically make a shell of whatever I can and then fill in the blanks. So the first thing we were going to want to print out is what h equals, and it's just going to be, h. So say we passed in, so say h is equal to 99. It's just going to print out h equals 99 on the screen. So now let's get into the good stuff, the meat of this tutorial, and that's the this keyword. Now I'm actually going to be doing this tutorial a little bit different than before. In order to teach you guys the full concept, I'm actually going to make my entire program first and then walk you guys through it. I usually, walk you guys through what I'm doing as I'm typing, but it's going to be easier to understand if I actually make my whole program first. So this h equals this h. This is going to print out another kind of h, which I'm not going to tell you yet, but trust me, you guys will know by the end of this tutorial. And actually, this weird kind of h is also gonna, let me add my equal signs. I know you guys are anxious to see what this all is, but I'm not going to tell you guys yet. So now we're basically printing out h in three different kinds of ways. This way, and this way. Get it? This way? It's a cheap little joke, but anyways, let's go ahead and now we have to create an object to actually call those functions. So Hannah, HO, and let's just pass it in like 23 or something like that. So first, what this is going to do is it's going to take the value of 23 and set it equal to the variable h. So whenever you run this program, it's going to print out 23, 23, 23. So now, after that, we of course need to call print crap right like that. So let's go ahead and build and run this and see if I got any errors, which I did because I forgot a semicolon. Let's run it again and check it out. H equals 23. Makes sense. We already knew that. Now this arrow h equals 23. Alright, we're not exactly sure what that means. And whenever we use parentheses star this dot h, that equals 23 too. So basically we can see that these are three different ways of printing out the same variable. So we already know that whenever we print out a private variable, we can just use that private variable name and it prints out the value. So we already know what that one does from the last 80 tutorials. So let's go ahead and skip right on down to this one, and that's this arrow h. Well, remember in tutorial like 42 or something, I told you guys whenever you use the arrow, it means you're going to be working with a pointer. So that's kind of weird. So that means this is a pointer? Well, yes it does. In a C++ program, whenever you use the word this, it's actually a keyword that identifies a special type of pointer. The keyword this stores the address of the current object that you're working with. Sounds kind of weird, huh? So that's why I actually needed to build this entire program first, because I needed to build an object, and the object we're currently working with is HO. So whenever we use that object HO, it took the address of it, and by the way, HO is stored somewhere on our computer in memory deep down, some weird location. But it took that location and it stored it in the keyword this. So now the this keyword identifies a special type of pointer, like I said, that stores the address of HO. If we made another object called BO, it would then hold the address of BO. So whatever object you're working with, it's going to take that address and store it in a pointer called this. So basically it's saying the address of HO, use that object, and that object has a variable H. So that's why this and this are basically the same thing. And you're saying, alright, so if they're the same thing, why does this work and why does this work? This, whenever you print out H, it's just implied that whenever you're working, whenever you're, here, let me say it like this. Whenever you print out this variable right here, C++ assumes that you're working with a cur object. Whenever you print out like this way using the keyword this, it's basically explicitly telling C++. So this is, just assuming that you're working with the cur object, but this is explicitly telling C++ you're working with this current object. It's just, a different way to do things, but actually this keyword is pretty important. I'm going to show you guys why it's actually useful aside from just printing out variables. So basically what I want to stress you guys in this tutorial is whenever you use the keyword this, it stores it as a special type of pointer, and that pointer stores the address of the current object, in this case was HO. So this is saying the address of HO, get that object, and that object has a variable H, and H is equal to, what did we say, equal to 23. So that's why this prints out 23. Now that I confused you guys, let's move on to this one down here. Now this is basically a different way to access the object. The this with a weird pointer and then surrounded by parentheses, this is called dereferencing a pointer. And what this means is it's literally taking the memory location of the current object, which is, some long hexadecimal X0J42 yada yada, and it's taking that memory location of the current object and calling the variable's value right there. So this is basically saying, alright, whatever current object we're working with, which is HO, that HO has a variable called H. Now print out the value of H. And this, just assumes we're working with HO. Right here, we're saying we're going to be using the this keyword to talk about HO. And right here, we're using the explicit memory location of the object HO. So this is basically implied, explicit, just two different weird ways of doing it. So now that I taught you guys that, in the next tutorial I'm going to show you guys why you would use the this keyword, and it's not just something that you can use to show off that you know more about C++. It actually is useful in some programs. So maybe the next tutorial will be a little bit more useful, but for now, that's all I got for you guys. So hopefully I confused you guys. If you need some more information, check out my website, thenewboston.com, and you can ask me a question there. But for now, thank you guys for watching, and I'll see you guys in the next tutorial. Alright guys, welcome back to your 50th C++ tutorial, and I know in the last tutorial I told you guys I was going to be building a program using the this keyword, but I was building it and I noticed that there was a lot of concepts I didn't teach you guys, so we're going to have to come back to that after I taught you guys a couple new concepts. So we'll get back to that, but for now I want to talk to you guys about something called operator overloading. Now operator overloading is a weird feature with C++. What operator overloading is it allows you to use C++ operators like, plus and multiply, and it allows you to take these operators and change the way that they're used. So for example, maybe you have a class and you want to add two objects together. Well, how the heck does C++ know how to add your two custom objects together? Well, that way you can use operator overloading to specify what you want this operator to do. So what I did already is I made a new class called Sally, and I also included the Sally header in here, and I included IOStream and namespace in here. So now my .cpp files look the same, just to save this tutorial some time. So now let's go ahead and get into the coding. So let's go ahead in the Sally header file, and notice that I took out both private and protected because we're just going to make everything in public. It's going to make everything a whole lot easier. So the Sally class is going to have a couple things in it. The first thing it's going to have is a variable called num, and this is the only variable it's going to have. It just needs a variable. Pretend this is like Sally's age or something. I just named it num because it's easier to work with. Now let's go ahead and create two constructors. The first constructor is pretty much just going to be empty constructor. We're going to be building a Sally object, and whenever we don't pass any parameters to it, it's just going to create a blank Sally object. And we're also going to be creating another constructor, and whenever we create a Sally object and we pass an integer into it, what I want to do is, well, let me go ahead, I guess I can code this right now. Whenever we create a Sally object and we pass an integer into it, called like integer a or something, what this is going to do is, I like it right up there. What this is going to do is take that num property and set it equal to a. So we're going to create Sally objects in two ways: a blank Sally object or a Sally object that already has a number. Simple enough. So now let's get to the last thing in the Sally class, and that is, what I've been talking to you guys about, this thing called operator overloading. Now again, like I said, operator overloading allows you to use C++ operators in a special way inside your classes. So in order to use an overloaded operator, you need to make a function and you need to give it a special name. So whenever you build a function in C++, you need to first give it a return type. Now this function is actually going to return a Sally object. So go ahead and type Sally right there. And now you have to name your function. And you have to name it this. Whenever you're using an overloaded operator, you have to start it with the name operator. And then right after it, you write what operator do you want to overload, and this can be multiply, divide, but we're going to be overloading the addition operator. And what this is going to do is take two of these number properties and add them together. So let's go ahead and write operator plus. This is the name of our function now. And this is also going to take a parameter. What this function is going to do is it's going to take one Sally object's number and add another Sally object's number to it. So we're going to need to pass it in another Sally object to add to it. So let's go ahead and call it like Sally. Well, all we have to put is that, Sally. So now let's go ahead and build the function itself. So let's go hop over to sally.cpp, and let me make sure I didn't forget any semicolon. Looks good. So now let's go ahead over to sally.cpp and start building this function. Again, the very first thing you write is the return type. This is like void int. Well, we're returning a Sally object, so go ahead and write Sally right there. And now we have to go ahead and write what class are we working with? Sally. What's the name of our function? And remember, that's operator plus, since we're overloading the plus sign. And what parameter does it take? Well, it takes a Sally parameter, and just name this variable like ASO for another Sally object. So now what we want to do is this. We're going to be returning a brand new Sally object. So let's go ahead and make a new Sally object right now. Sally, and name this object brand new. Simple enough. So now let's go ahead and add the number property to this brand new object, because we created a brand new object, but it doesn't have anything for its number property right here. So let's go ahead and put brand new dot num, and what do we want to set this equal to? Well, what we want to set it equal to is the current object's number value plus another Sally object's number value plus another Sally object's number value. So basically, we're going to have two Sally objects already. We're going to have a Sally object that, say, has a number of 20 and another Sally object that has a number of 30. And whenever we create the brand new number, it's going to have a value of 50. So that's where we're going to be returning the brand new Sally object. So in order to do that, all you do is this: return brand new, just like that. And what this is going to do is return the brand new Sally object. So basically, we're going to be calling this on a Sally object that already exists. And what it's going to do is, this line is going to create a brand new Sally object. Right here, we give a number value to the brand new Sally object, and right here, we're just returning that brand new Sally object. Simple enough. So let's go ahead and, well, I guess now we can hop over to main, and I can actually, show you guys what's going on. So the first thing we need is two already existing Sally objects with the number property that we can add together. So Sally we'll call this object A, and we'll give it a value of like 34. Now we need another one, Sally B, and we'll give this value 21. Now we need a blank one because whenever we call this value, remember it doesn't have a number property yet, so that's what we're going to be giving it. So let's go ahead and create a blank Sally object with C. And now all we need to do is this. You might be thinking, alright, whenever I wanted to before, like give a number property to the C value, I would do something like C equals A dot add, and then you would add B to that. And I mean, what that would do is whenever you wanted to add a number property to C, it would take A and add B, get some integer, and add it to the property of C right there. Well, with this overloaded operator, you don't have to do that anymore. Here's what you need to do. C equals A plus B. And that way, whenever we use the plus sign, C++ already knows that we have a special meaning for it right here. So whenever it sees the plus sign called on one of these objects, it's going to know to run this function right here. So let's go ahead and run this, and now that we use that plus sign, the C object has a num property. So let's go ahead and see out c.num, and then let's go ahead and end that line. And let me go ahead and run this real quick, and I'll show you guys that it says 55. So what it did is basically this. It took this number value, 34, added this number value, 21, it gave us 55, and through the use of our overloaded operator, that's where we got the Sally num. So let me talk you guys through one last time what's going on. Maybe this will clear things up for you. In our very first line of code, we created a Sally object, and the num had a value of 34. So we know whenever we created a Sally object and we passed in an integer, then it assigned that integer to the property of num. So we have a Sally object, and A Sally object is num 34. B Sally object is num 21. And then we created a C Sally object, and remember, whenever we created a Sally object that we didn't pass in a parameter, it just created a blank Sally object right here. So we said, alright, with our blank Sally object, we want to use A plus B. So it said, alright, I know this plus, since you're trying to do something weird, I know that you're trying to use this overloaded operator. So it said, alright, C equals A plus B. That means you're trying to use C, the Sally object, with this function right now. So what it did is it took the current object, which was A, right there, and this B was treated as the parameter, another Sally object. So what it did was it took the current object's number, which was 34, it added another Sally object's number, which was 21, and it returned a brand new Sally object with 55 as its number. So as its return value, we set equal to C. So C now equals a brand new Sally object with 55 as its number. So that way, whenever we printed out our brand new Sally object with its new number, that's why it printed out 55 on the screen right there. So again, like I said, operator overloading is a little weird because it basically takes your plus sign and you don't have to use a function name anymore. So instead of this, it pretty much changes that all into a plus sign. So I know it's kind of a weird syntax at first, and to be honest, I don't use it a whole lot in my programming. So if that gives you confidence that you're probably not going to be seeing this a whole lot, then you can relax. But I just want to give you guys the idea of what operator overloading is, because whenever you're at a job and people are talking about it, you don't get lost or whatever. So that's what it is, but you won't be seeing it all too much in my programs. So now that you guys understand the concept of it, thank you guys for watching. Don't forget to subscribe, and you're probably going to have to rewatch this video a couple times and do some examples of your own. And if you have any questions, don't forget to check out my forum, thenewboston.com/forum, and hopefully I can answer them for you. So anyways, one last time, thank you guys for watching. Don't forget to subscribe, and I'll see you guys later. Alright guys, welcome to your 50-second C++ tutorial, and in this tutorial I'm going to be talking about something called inheritance. Now, inheritance is a topic that confuses a lot of people, but I'm going to be giving you guys a really simple explanation and showing you guys a really simple example of what inheritance is. Now, inheritance is the idea that you can inherit things from another class. For example, say you have a class that has a couple functions in it and a couple variables in it, and you wanted to make a new class that also had the same functions and variables in it. Well, instead of, copying them all and pasting them all into your new class, you can just inherit from the other class, and whenever you inherit from another class, you get all the stuff. You get all the functions and variables. So let's go ahead and make two classes. File, new class. I'm going to make one class named Mother, and this class is going to have a couple things in it. Well, it's going to have a function in it for the sake of this tutorial. So let's go ahead and create this, add it to project, and I'll press OK. And now I'm going to create a new class called Daughter. Now what the daughter is going to do is inherit the stuff from the mother. So go ahead and press create, yes, and OK. So the first thing we need to do is go to our .cpp, copy this, paste it in our main, and also go to our daughter, copy this, paste it in our main, and then copy all this and paste it and paste it. So now all our .cpps look the same. That's what I like to do in all my tutorials. So let's go ahead in our mother header, and actually in both our header files take out protected and private, because I didn't tell you guys what those mean right now, so let's forget about them for now. They're actually pretty important when we're talking about inheritance, but like I said, in this tutorial I just want to give you guys a really simple example. So before I go on, let me give you guys the technical terms. See, we're going to be inheriting all the stuff from mother, and we're going to be putting it in the daughter class. But now the technical terms, if you're on a test or if you're working for a job or something, whenever you inherit from a class, this main class that you're inheriting from is called the base class. So in this example, mother is going to be the base class. Now the stuff that does the inheriting, the daughter that gets the stuff, this is called the derived class. So the base class is the class with all the stuff in it, and the class that is going to get all the stuff is called the derived class. So let's go on and start typing our example. So let's go ahead and throw one function into the mother class, and we'll just, void say name. So this is the Roberts family we're dealing with, so let's go ahead and build this function right here. Alright, we don't have anything in the constructor because the constructor is annoying. Now let's go ahead and build this void mother say name function. And all this function is going to do is cout I am a Roberts, because that's what my mom shouts all the time, and she doesn't know how to spell, so that's why I have to add some typos in there. So now if we go ahead in our main CPP, we can build an object called like mother, name it mom, and what mom can do is say name, and of course it would say I am Roberts on the screen. And say you wanted to build another object, a daughter object, and we'll name this Tina, and you wanted Tina to have that same function because, I mean, she's a Roberts too, she should be able to say it. Well, right now whenever we build it, it doesn't work because Tina doesn't have that function, only the mom does. So you're saying, alright, I know what to do in this case. Go ahead and copy this, put it in the daughter header, then copy all this crap, put it in the daughter CPP, and it should work fine. Well, yes, you can do that and it'll work fine, but I got an easier way to do things, and that is through inheritance. Now, whenever you want to use inheritance, all you have to do is this. In the header file, whatever class you want to inherit the stuff from, right after the class name, put a colon, and then right after this, write the word public, and then write the class you want to inherit from, which is mother. Now we're going to be talking about this keyword, why I put public right there. Basically it means all this public stuff is going to be public in here. But we'll be talking about it later. There's a couple of weird things, but just put public for now. So basically what I'm saying to C++ is this. Alright, in my daughter class, include all the stuff from the mother class. So what it's going to do is go over to this mother class, go ahead and grab this function right here, It's not going to grab the constructor. That's another silly rule, but it's going to grab any public variables and any public functions. And right now we only have one public function in that same name, and it's going to throw it inside this daughter class. So now this daughter class is inheriting from the mother class. So now, check it out. Even though we didn't explicitly write that same name function in here, it inherited it, so it's there even though we can't see it. So now, let's say we want to take away this part right here, and we try to run this. We don't get any errors, and now the daughter is able to use that same name function. So again, what inheritance is this. Whenever you have a class and you want to inherit the crap from another class, you can write a colon and then public and then that name of the class. And what this does is it takes everything from this class and it sticks it in this class. So this is called the base class, and this is called the derived class. Whenever you inherit, everything from the base class gets thrown in the derived class. So now, even though we can't see the same name function, it's there. So that way, whenever we created a daughter object, the daughter object was able to use the mother's functions, even though it wasn't explicitly written in the documentation or the .cpp file, whatever the heck you want to call it. So that's why we were able to run this daughter object and use the same name function on that. So that's what inheritance is. It's basically inheriting stuff from another class. But you know how I said that there are a couple weird rules, like you needed this public thing, and whenever you inherited, it grabbed all the stuff from this mother class and threw it into the daughter class? Well, that's not exactly true. I don't want to say I lied to you guys, but for the sake of this tutorial, I just wanted to make it simple. There are a couple weird exceptions in whenever you inherit from another class, it doesn't actually grab everything. It only grabs a couple things. And also, you need this public keyword or else some weird stuff will happen if you try to use protected or private. And that's what I'm probably going to be talking to you guys about in the upcoming tutorials. But for now, what you have to remember is this. Inheritance is basically grabbing another class and throwing all the stuff into a derived class. So this is called the base class. This is called the derived class. That's what inheritance is. Pretty simple, huh? You inherit the stuff from another class. That's all it is. So now that I talked about that, we're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe. Hopefully you'll understand the concept of inheritance. If you don't, watch the video again, and I will see you in the next tutorial. Alright guys, welcome to your 53rd C++ tutorial, and if you've been following these tutorials, you know that I've been gone for like a week, and I might be kind of rusty with C++, but I'll get the hang of it. I've actually been planning something, and I'm not going to tell you guys what it is, but I will say that it's awesome, and it's going to happen in about a month. So that's your little teaser. So now let's get back into C++. Let me get my head straight. I actually just opened this program. So I think what I was supposed to teach next was about protected, because that's what it's looking like. So I think in the last tutorial I just covered basic inheritance. I probably should have, watched the last video before I started doing this one, but who has time for that? So let's go ahead and talk about what a protected member is. Whenever I first made a class like this mother class right here, automatically it's stuck in public, protected, and private, those three variables, or those three code words, and you're supposed to put all your functions and variables in there. And I usually just deleted private or protected, and I'm like, don't worry about that, we'll worry about this later. Well, now is the time to worry about it. So let's go ahead and in our mother class, let's throw in those keywords again. So public, we already know what this does. Let's go ahead and make a variable for each one. So we already know what public means. Anywhere inside this class has access to this stuff, and also outside this class can also access this stuff. Whenever you write something in public, it pretty much means anywhere in the program you can access this crap. So we'll just name it public v for public variable. So now let's go ahead and talk about protected. Well, before we talk about protected, let's talk about private, because, might as well get out of the way the things we know already. We already know that whenever we make something like a private variable, that this means that only inside this class has access to this variable. For example, if we wanted to go in another class or in this main CPP class, this class would not have access to these private variables, and that's why we need to build methods inside this class that are public to access those private variables. So basically what we know so far, whenever we make something public, any other file has access to it. Whenever we make something private, only this file or only this class has access to it. So you're saying, alright, this is A, this is B. So what the heck is this one? It's kind of like sitting in the middle. Is it like a combination of both? Well, yes, it is. Listen very closely. Whenever you make something protected, here's what it means. Anything inside the class has access to it, just like public and just like private. Any friend has an access to it, and remember we talked about friends earlier. Pretty much just things outside the class that has access to stuff inside your class. And also your base classes. Remember, a derived class inherits from the base class, right? So any class that is inheriting from this class has access to it. So if we were to make a private variable in this mother class, and then the daughter class inherited everything from mother, well, it wouldn't inherit the private variables. These private variables are still private to mother. Even though daughter inherited from mother, daughter does not get these private variables. Daughter would in fact get public and protected. So it would inherit these two, but not private. So that way you can kind of see it's a mix between public and private. It doesn't let anything inherit it like public, and it doesn't just stay in this class like private. It's kind of like in between. So let me go ahead and make a protected variable, protected v, and I'll go ahead and show you guys an example. So let's go ahead and build a function inside daughter, and we'll just name this, go ahead and make it a public function, of course, public, and we'll just name it like do something. Did I spell that right? Close enough. So now let's go ahead and build this method right here, and I keep thinking like I'm forgetting something, but I guess it's just because I haven't programmed in a while. So let's go ahead and put void daughter. Hopefully I'm doing this right. Alright, and what was that? Oh, do something, and got it right there for me. How nice. So now we'll just go ahead and do this. Well, actually, I might as well do this one at a time. This will probably show it to you very clearly. So let's go ahead and before we even start coding this function right here, let's go ahead and build a daughter object. So daughter, I think her name should be Tina. That seems appropriate for this tutorial. And Tina dot do something, right like that. So now hopefully when you run this, nothing happens because nothing's in this function right now. So let's go ahead and see just if we have any errors right now. Nothing happens, good. So let's go ahead and do this. Let's say we want to access that public variable, and we'll just like set equal to a number or something. We just want to try and access it. So let's go ahead and try to access that public variable and do something to it, like set it equal to 1 or something stupid. Well, we go ahead and run this, and no errors. So we know whenever we do that, that we do indeed have access to the public variable. And just a reminder, this daughter class is inheriting everything from this mother class, and that includes a public variable, a protected variable, and a private variable. Now we already know that daughter can access that public variable in this line of code right here. So now let's try and step it up a notch. Now let's go ahead and try to access that protected variable, protected v, right there. Well, if we go ahead and try and set this equal to 2 or something like that, and we build and run it, it works perfectly. So therefore we can see that the derived class can indeed access the protected members of the base class. And remember, mother is the base class, daughter is the derived class. Whatever does the inheriting, aka the daughter, is the derived class. The core class that has the crap we want to inherit from, that's called the base class. So now we know that we can indeed access public and protected members from the base class. Now let's go ahead and do something that we know we're not allowed to do and try to access a private variable. And let's go ahead and try to set this equal to 3. And now we'll go ahead and try and build and run this, and it says, Bucky, I don't think so. You know the rules. You are not allowed to inherit private members. So that's why we're getting an error whenever we try to inherit for a private variable. So the concept behind this tutorial is not to build a stupid program that does nothing, but it's this. Whenever you're inheriting from a class, you can inherit all the public stuff, you can inherit all the protected stuff, but you cannot inherit the private stuff. So remember, whenever you have a base class, you're going to get this crap, and you're going to get this crap. But you ain't getting this class, biatch. I meant crap. Oh, that's embarrassing. But I'm not going to redo this tutorial just because I messed up that one sentence. Okay, got it. Alright, so let's, you know what, that's enough of me talking for this tutorial. I think you guys understand the concept by now. Basically, at the heart of this tutorial, you can inherit everything except private variables. I could have made this tutorial real short, but I didn't. So thank you guys for watching. Don't forget to subscribe. And by the way, if you guys want a nice organized playlist, I don't really like doing them on YouTube because it's not really easy to organize that way. But if you go to my website, I have all my videos laid out. You can watch one right after the other from clicking a button. Everything's nice, laid out in a nice playlist for you guys. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome to your 54th tutorial, and in this tutorial I want to talk to you guys about the derived class constructors and deconstructors. Basically, I want to figure out this riddle. Whenever you have a constructor and a deconstructor in the mother class, does the daughter class also inherit that constructor? Well, it inherits everything else, so is that constructor and deconstructor included? Well, your short answer is no. It does not inherit the constructor and deconstructor from the mother class. Or does it? I guess you're going to have to watch and find out. So let's go ahead and first make a constructor and a deconstructor in the mother class. So let's go ahead and remember, in order to do that, just create a function with the same name, mother, and tilde mother for the deconstructor. Now let's go ahead and set this up, and I guess we'll build the constructor first. Mother, and all we're going to have this constructor do is like cout I am the mother constructor, exclamation point, emphasis on that crap. And now let's go ahead and do the same thing. Let's copy this because I'm lazy, and remember to add your tilde, so that's the deconstructor, and just write mother. Let's get rid of the I am the, it's tacky, she's a mom. Mother deconstructor. So now we have a mother class that has a successful constructor and a deconstructor. So now whenever we create a mother object like mother ma, it should build the object. So, and I messed up something right here. So mother, let's see what I messed up. Oh, here it is right here. NL. You need that because end is not a keyword. So let's go ahead and run this again. And now whenever I create a mother object, you can see that the object gets created. I am the mother constructor. And whenever the program comes to an end, the object gets destroyed. Mother deconstructor. So our mother object works as expected, I guess you could say. Whenever the object gets created, this runs. And whenever it gets destroyed, this runs. We already know what a constructor and deconstructor does. So now let's go ahead and build a daughter object. Now remember, at the beginning of this tutorial, I promised you guys that the mother constructor and deconstructor, even though the daughter is inheriting all the stuff from the mother, I promised you guys that it is not inheriting the constructor and deconstructor. So let's go ahead and build a daughter object. If I can type daughter, and we'll just name this like Dina because that's a nice name. So let's go ahead and build and run this and see what we get. Whoa, Bucky, I think you lied to me. It said I'm the mother constructor. I am the mother constructor. Bucky, you mofo, you son of a bee. You told me that the daughter is not inheriting the constructor from the mother class. So why on earth would it run this constructor twice? Well, let's go ahead and actually build a daughter constructor, and we'll see exactly what's going on. We'll see if I actually did lie or if I didn't. So in order to build a daughter constructor, let's go ahead and build daughter, parentheses, and also tilde daughter for the, whoa, what the heck is that? Escape. What the heck is that? I do not know how that got there. Anyways, let's go ahead and do that, and actually, instead of having to copy this, I'm just gonna, you guys should not do this, by the way. Just close your eyes for this part. And just going to change this to daughter and copy this. always bad programming practice because you always usually mess up something. But hopefully that should run just like that. And now the mother class has its own unique constructor and deconstructor, and the daughter class has its own constructor and deconstructor. So now whenever I run this, you're saying, alright, so you lied to me. Obviously, the daughter did in fact inherit the mom's constructor. So now that it has its own constructor and deconstructor, I should see just two constructors and two deconstructors, one from the mom, one from the kid. So let's go ahead and build this in. What the heck is this crap? 6 things popping up? Alright, Bucky, you need to take a timeout and explain to me what's going on. Well, in order to do that, I'll make it real simple for you guys. Just comment this out right here and run this program again. And now we see, once we just built this one daughter object, actually let me go ahead and take this out completely. And now X this out and build it and run it again. Now we see that even though we built one daughter object, it's still running that mother constructor and the daughter constructor. So what the heck is going on, Bucky? Alright, now let me take a time out, take a deep breath, because I got some explaining to do. When I told you at the beginning of this tutorial that the daughter does not inherit the mother constructor, I wasn't lying, I was telling the truth. Even though the daughter is not inheriting the mother constructor still runs. So basically, here is how your program works. Whenever you start this program, it says, alright, I have one daughter object that I need to make. So the very first thing I'm going to do before I do any of my own crap in this daughter class, the very first thing this program is going to do is it's going to invoke the base class's constructor. So it says, alright daughter, you have one base class called mother. So let's go up to mother, and we're gonna invoke the mother constructor before we even do anything with the daughter. So that's why the very first thing we did was invoke the mother's constructor. And then after that, we were able to invoke the daughter's constructor. So basically, whenever you use a class, it sets up all its base classes before it does anything on its own class. So that's why whenever we're running this daughter object, it sets everything up on top of it before it, did the daughter stuff. And another thing I want to point out, say you weren't only inheriting from a mother, but say there was a grandmother and a great-grandmother, and there was a huge hierarchy. Well, it's still the same thing. If that was the case, then the great-grandmother would get done first, and then the grandmother, and then the mother, and then the daughter. Basically, the very top class is going to get done, the constructor is going to get finished executing first on the topmost class. And this is because, like I said, whenever you have a class that inherits from another class, it needs to set up the class above it in order to make sure everything is going to work inside it. So the daughter is going to say, alright, I need the mother in order to work. And the mother is going to say, alright, I need the grandma in order to work. And the grandma is going to say, alright, I need the great-grandma in order to work. And that's the very top. So that's why the great-grandmother would be set up first. But in this case, we only have a mother and a daughter, a very simple explanation. So that's why the mother gets set up first, because in order for this daughter class to work, the mother class needs to be working first. So that is why the mother constructor gets called first. Like I said, the daughter class isn't inheriting, it's just setting it up. So that's why this mother constructor gets ran. Simple enough? So that's why the mother constructor gets ran, and then the daughter constructor gets ran. But then the daughter deconstructor gets called first, and then the mother deconstructor. That's kind of weird. You're saying, alright, if you're going to set this class up first, then you might as well destroy it first, right? But that's not the way it works. It goes mother, daughter, daughter, mother. It's kind of gets sandwiched in there. So here's what's happening with the rest of the program. Whenever an object gets destroyed, and remember we only had one daughter object in this program, then here's what happens. Whenever an object gets destroyed, its deconstructor gets called. So Dina's deconstructor got called first, and whenever your program saw that this deconstructor get called, it sets off a chain of deconstructors that get called after it. So if there were, a huge family, the daughter would die first, and then the mother, and then the grandma would die, and then the great-grandmother. So it gets kind of built in reverse order, then it dies, but that's how it works. So basically, one last time, whenever you're first, say you had an object like the daughter, all of its base classes, the topmost base class gets instantiated first. It takes care of the uppermost class first because it needs every class needs a class on top of it to work in order for that object to work. So that's why mother got called even though we weren't inheriting it. We needed to set it up before daughter could get set up. Now, whenever this program ends, the first thing to die is this daughter object. And once this daughter dies, it's going to set off a chain of death throughout the family. The mother's going to die, then the grandma's going to die, then great grandma's going to die, then Osama bin Laden's going to die because that's what happened yesterday. And that's what day it is. In case you guys are watching this like 3 years in the future, that's what day it is today. May 3rd, Osama bin Laden was declared dead yesterday or 2 days ago, whenever they announced it. So, anyways, I think I'll just end on that note because I'm getting way off topic now and I probably confused you guys enough. So, thank you guys for watching. Don't forget to subscribe. And again, if you want to check out my tutorials in organized fashion, check them out on my website. They're all nice and laid out for you guys. So, thank you guys for watching. Don't forget to subscribe, and I'll see you guys later. What's going on, guys? It's Bucky and welcome to your 55th tutorial. And in this tutorial, I'm going to be beginning to talk about something called polymorphism. Now, polymorphism is a subject that gives a lot of students and a lot of people problems because whenever someone tries to explain it, they make it really confusing. So let me give you guys just a basic example, not through code or anything. I just want to talk to you guys for a second. So say you wanted to make a computer game and you know that your computer game you wanted to include a bunch of enemies like monsters and ninjas and, just a bunch of different types of enemies. Well, all of these enemies shared a common function. Say they all had an attack function to try to attack you. However, they all attacked you in kind of different ways. Maybe the ninja threw a sai at you, and a monster tried to scare you from under your bed. And, all these different enemies, even though they had the same function, they worked a little bit different. Well, what polymorphism allows you to do is it allows you to call that same attack function on many different objects. And since all of these objects, like ninjas and monsters, since they're all enemies, this is why it's valid. So since they all inherit from the same class, you can call attack on each different object. And even though ninja has an attack and monster has an attack, even though you're calling the same function on different objects, they all know what to do. They all know that they're supposed to attack you in some way. So what polymorphism basically allows you to do is use the same function and have many different outcomes. So that's the basic idea behind polymorphism, but there's actually a lot to understand. So let's go ahead and get to it. So let's go ahead and start making that computer game now. So go ahead and make a class, and we'll name it enemy. And don't forget, put your semicolon at the end. And now let's go ahead and let's say that we're going to have a ninja and a monster, and they're each going to have an attack power, how much they're going to hurt you. So let's go ahead and, well, since we learned what protected is, we can go ahead and use that. And we'll put int attack power. So now every enemy has an attack power. So now let's of course make a function in order to set that attack power. So we'll make it public, of course, and we'll just make it void set attack power. And this is going to take one parameter, of course, some number. And using that number, we're going to set the attack power. And again, this attack power doesn't really mean anything. It's just a made up number. So attack power equals A. So we're going to pass it in like a value of 10. And, the ninja's attack power is 10. Whatever the heck attack power means, right? So now let's go ahead and make another class. Let's go ahead and make class ninja. And this ninja class is going to inherit from public enemy. So all ninjas are enemies. We already know that. So now let's go ahead and add some things that are specific to only ninjas. Well, in each of these classes, let's go ahead and make an attack function. So public void attack. There we go. And now what we can do is, I guess I'll just throw everything on one line. This is the part that's going to be specific to the ninja class. So right here we're saying, alright, we're going to have some ninjas, but a ninja is still going to be an enemy. I mean, an enemy is an enemy. So whenever a ninja attack, what do I want them to do? Just see out on the screen. I am a ninja chop, and it'll be like minus not Ninja Cop, come on, Ninja Chop, and it'll be like minus, and then you'll write the attack power. Because remember, since it's an enemy, it has that attack power attribute that it inherited. Hopefully you guys watched my last couple tutorials and aren't like, what the heck does inheritance mean? And then just go ahead and end that line right there. So now we have a ninja class that has all this crap from enemy since it inherited from enemy, and it also has its own specific attack function. So whenever a ninja attacks, it's going to say, I'm a ninja, ninja chop, minus 10. Like it did 10 damage to you or something. So let's go ahead and copy this, and we'll make another class right here. We'll call this class, actually I'm about to scroll off the screen, so let me just bump this up, and we'll make, this a monster class. Now a monster is also an enemy, so you have two enemies. You have a ninja and a monster. However, when a monster attack, it says monster must eat you, exclamation point, and it'll be like minus 25 or something. Like eating you doesn't kill you, it only does 25 damage. So basically what we have here is three classes. We have an enemy class, which is common to all enemies. So all enemies are going to have an attack power. However, each specific enemy attacks in a specific way. A ninja is going to chop you, and a monster is going to eat you. So let's go ahead and start coding and making all these objects. So in our main right here, let's go ahead and make a ninja object, ninja, and I'll just name this N, and a monster object, and I'll just name this M. So you got a ninja and a monster. And now what we need to do is we need to make two enemy objects. So let me go ahead, enemy, and make a pointer, and we'll just name this enemy1, and we're going to set this equal to the address of our ninja object. Now before I go on, let me say this. Because this ninja object is of type enemy, remember, all ninjas are indeed enemies, all monsters are indeed enemies. That's why we can do this. That's why we can set the address equal to the pointer. So anything that an enemy can do, a ninja can do. Does that make sense? It should. And also anything an enemy can do, a monster can do. So let's go ahead and just, I shouldn't do this. You should never copy and paste because you always mess up stuff. Enemy 2, we'll set this equal to monster address. So basically what we can do now is this. We can use that enemy 1 object, and remember, whenever you're working with pointer functions, you need that little arrow, and you see it already pops up attack power. So our program already knows that any enemy object you can call attack power, because even if it's a ninja, a monster, they all have an attack power. So that's why this is valid. So whenever you set your attack power to, a ninja can do like 20 damage or 29 or whatever, it already knows that it's supposed to apply this to the ninja object. So even though we're setting it enemy attack power 29, it knows that indeed, since it's pointing to the ninja object, that means the ninja's attack power is 29. So basically, before I go on, because a ninja is a type of enemy, this is valid, this line of code right here. Anything that ninjas can do, or excuse me, anything that an enemy can do, a ninja can do, because a ninja is just a more specific type of enemy. So every how should I say this? Every enemy has an attack power, so that's why we're able to do this. Every enemy has an attack power, and the reason it knows whose attack power to set is because it's a ninja object right here. Enemy 1 equals a ninja object. So let's go ahead and just copy this. Again, you should never copy, ladies and gentlemen. And we'll set enemy 2, which is the monster. We'll set this attack power equal to, 99 or something stupid. So now we can go ahead and with each of these objects, we can call attack, and it will give it their own custom attack. So N, attack, I already filled it in first, and M, attack. So we kind of used a combination of, two different classes. Using the general enemy class, we set the attack power, and then whenever it attacks, it's going to use that attack power like I'm a ninja, ninja chop 29. So let's go ahead and run this and see if I forgot any semicolons or anything, and I did, so hold on 1 second. Oh, I see what I did wrong. What I did wrong is I actually just tried setting the attack power, and the method was called set attack power. So let's go ahead and copy this, and we'll set attack power to 29 and set attack power to 99. Now if we go ahead and build and run that, there we go. It says I am a ninja, ninja chop, minus 29. And the reason it knew minus 29 was because of this line right here. And whenever we set the enemy to, which was an enemy object, but it knows that it's supposed to be working with that monster object, whenever we set that attack power equal to 99 right there, had to find it. It knows that whenever the monster attacked, it was supposed to have an attack power of 99. So that is basically how you can do that. And I guess I'll see you guys later. Alright guys, welcome back to your 56 C++ tutorial, and in this tutorial we're going to be talking more about polymorphism because I know I kind of cut off the last tutorial abruptly, and that's because I understood that I wasn't making a couple things clear, so I wrote some comments here, and read these line by line, and hopefully they can make you understand the basics behind, inheriting and using these pointers with different types of objects easier. And also, I wanted to stress one thing that you guys may not quite have understood. Now, if we go up to, the ninja class and the monster class, you saw that each of these specific classes had a function called attack. So a ninja could attack and a monster could attack. However, if we scrolled up to the enemy class where they both inherited from, there was no attack function right in here. So that is why we had to switch back to using the ninja and the monster attack after we set the attack power. So that's why the enemy object, see, let me go ahead and, like, if enemy object was to try to attack, you would get an error message because an enemy object can't attack because this enemy class has no attack. Only these specific classes do. You see what I'm saying? So that's why we could use the enemy object to set the attack power, because every class inherited this set attack power, but we couldn't use those enemy objects to attack because only these specific classes can attack. So you're saying, alright Bucky, that's I understand it now, but it's still kind of, a dumb way to program because first you make a ninja object, then an enemy object, then you use the enemy object here, then you have to switch back to the ninja object right here. Well, wouldn't it be nice if we could just have these enemy objects? Come on, I keep hitting that dumb plus sign. Wouldn't it be nice if we could just have these enemy objects attack as well? That would make our lives a whole lot easier if we didn't have to switch back to this ninja and monster class. If these enemy classes, or excuse me, these enemies objects could just set the attack power, attack, move around, do whatever an enemy needed to do. Well, check it out, guys. That is the core concept behind polymorphism, and it's going to make your programming life a whole lot easier. So let me go ahead, and I'm going to go ahead and delete all this crap right here, and I'm going to clean out all my classes. So I just have a blank monster class, a blank ninja class, and a blank enemy class. Now I'm going to teach you guys how to do what I was just talking. How to call the attack function on every single enemy object and have it work beautifully. Now, before you're saying, oh, MG, you deleted everything, I just followed the tutorial and now I'm going to have to retype all that code. Why would you delete everything? Well, I deleted everything because the code for this is actually a whole lot easier than what we've been doing before. So before, I wanted to stress you guys, how you inherit, and indeed you can, use different addresses with different pointers. And once you understood the last tutorial, come to this tutorial and look how easy I'm going to make this for you guys. So we want every enemy object to be able to attack. So let's go ahead and make a public function, and we're going to name this void attack. So now every enemy has the ability to attack. So now what we want to do is, before we start coding the rest of the stuff, we already know that whenever we build a specific class like ninja and monster, that they're going to have their own specific attack functions. A ninja is going to be like karate chop, and a monster is going to be like, roar, I'm coming out from under your bed. Well, we already know that each of these classes is going to pretty much overwrite this attack function. So what we want to do is we want to make this function virtual. Whenever you make a function virtual, it means that you're going to be using it polymorphically, and that way, whenever later on we're using like enemy 1 attack, enemy 2 attack, it knows that it's supposed to look in the specific class for that function instead of using this function right here. So now when we go ahead and, public, make our attack function using void attack, and we'll just, whoa, easy backslashes. Now whenever we write something like void, and just write, ninja attack, end line, and let me just go ahead and code this real quick. Copy this, paste it right there, and the monster attack can be like, monster attack, ah. So now, whenever we go ahead and use, well, I might as well just code the rest of this program, because, instead of telling you what I'm going to code, I might as well just shut up and code it. So we have a ninja object, and we have a monster object. Now we know from the last tutorial that what we can do is, since a ninja is just a specific type of enemy, we can go ahead and make an enemy object, like enemy object, and make a pointer to enemy 1. Get my cursor out of the way. And we can set this equal to the address of ninja. We can do the same thing with monster. And this is valid again because monsters and ninjas are just more specific types of enemies. So anything that you can do to an enemy, including attack, you can do to a ninja and a monster. If an enemy can move around, a ninja and a monster can move around. If an enemy could stab you with its sword, a ninja and a monster could stab you with a sword. So that's why we were able to do this right here. So now what we can do is, since we made this virtual function, we can now go ahead and do stuff like this. Enemy 1 attack. And let's just go ahead and copy this right here. And now we can go ahead and write enemy 2 attack, and if we run this, it works perfectly fine. Ninja attack and monster attack. So basically, whenever we use virtual functions, we're telling C++ this. Alright, so C++, let's sit down and have a conversation. We're going to be building a computer game, and we're going to be putting enemies in it. Now each of these enemies is going to have its own specific attack function. Now whenever I call an enemy object, I'm going to have an attack. I don't want you to use this attack function right here. This is just a template telling you that each class that inherits from enemy is going to have an attack function. Whenever I use an enemy object that has an attack function, I want you to find out which address, aka which type of enemy, has that attack function and call that attack. So basically it said, alright, enemy 1 attack. Okay, let's go ahead and I'm going to call attack from enemy. Hold on. Enemy 1 is indeed a ninja object, so I'm going to ninja attack. And then it said, alright, enemy 2 attack. Well, I know that enemy 2 is an enemy object, so I'm going to go ahead and call attack. But hold on. This is a virtual function, so I'm going to go ahead and see, oh, that is a monster object, so I'm going to go ahead and monster attack you. So virtual functions are basically template functions, and any class that inherits virtual members, whether it's variable or a function or anything virtual, is a polymorphic class because, well, not because, that is the idea behind polymorphism, that you can call this same function. I mean, check it out. We're using an enemy object and we're calling the same attack function, but it has different results. So that is the beauty behind polymorphism, that you can use the same function and produce different results. So hopefully I didn't confuse you guys too much. I think this tutorial is a lot more clear than the other one. That's, what polymorphism is. That, well, first of all, in order to have polymorphism, you need this virtual stuff right here. And also, the idea behind polymorphism is that you can have different functions from the same type I'm doing those little quotation signs with my fingers, you can have the same function with the same type of object, but you produce different results based on what address it's pointing to. So, that's it. I don't want to confuse you guys anymore. Anything I have left to talk about, I'll talk about in the next tutorial. So hopefully you guys understand this a little better than the last tutorial. If you don't worry. We're going to be covering it more in the future. But thank you guys for watching. Don't forget to subscribe, and I guess I'll see you guys in the next video. Alright guys, welcome to your 57 C++ tutorial, and in this tutorial I'm going to be going over a couple things. I'm not going to be doing a whole lot of coding, so you guys just might want to put away your keyboard for this tutorial and just, sit back and watch and learn. I'm going to be talking about something called a pure virtual function and also abstract classes, and actually they both go hand in hand, so, you aren't really learning, two totally new concepts. But let me go ahead and before I talk about a pure virtual function, let me explain to you guys what a regular virtual function does. So let's go ahead and before we even start, let's notice that this enemy class has an attack, and this ninja class has an attack, and this monster class has an attack. So let's go ahead and actually code something in this enemy class attack, and let's code something like cout I am the enemy class. I don't know, that's good enough. And let's go ahead and end that line. So let's go ahead and run this program and see what happens. It says ninja attack and monster attack. It works as we expected. So basically what a virtual function does is this. Whenever we're programming and using polymorphism, for example, if we made an object from the enemy class, it would go up. Let me explain this one more time. If we made an object from the enemy class and tried to use that attack function right here, what it would do is it would go up to the enemy class and call this attack function. But since this attack function is virtual, it would go back down and say, alright, it was a virtual function, which means I need to check what I'm pointing to, and if one of these derived class overwrites this attack function, then use that one instead. So that's why even though we inherited this attack function that says I am the enemy class, we overrode it in these derived class. One of them says ninja attack and one of them says monster attack. So since we overrode it right here, and since we're using polymorphism with virtual functions, that virtual function checked and saw that we were indeed overwriting it, and it used those more specific functions. So now let me talk to you guys about what a pure virtual function is. So let me go ahead and maybe this will be easier if I saw. If I go ahead and take out this attack, actually let me just go ahead and cut this from the monster class. Well, this monster class is already inheriting an attack function from the enemy class. If it doesn't implement its own specific attack function, it inherits the default general I am the enemy class. So let's go ahead and run this, and it says ninja attack had its own specific attack function, but the monster attack did not. So that's why I inherited the more general enemy class one. Simple enough. So basically, whenever you have a virtual function, you have the option of overriding it, but if you don't, it's no big deal because we already have a function right here that we inherited. But with a pure virtual function, and before I start talking about that, let me go ahead and paste this code right back in here. A pure virtual function doesn't give you the option of inheriting from the base class. In order to make a pure virtual function, you don't have a body at all. And instead of a body right here, what you have is equals 0. So basically you're saying this virtual function, which we see equals 0 instead of a body, is now a pure virtual function. And as you can see, a pure virtual function has no implementation whatsoever. And by implementation, I mean body. And by body, it means, it doesn't do anything. So a pure virtual function doesn't do anything at all. And one rule that you have, any derived class that inherits from a class that has a pure virtual function in it, it needs to, no exceptions, it needs to overwrite that function. So remember, the last example I told you, we had the option of taking this out, and if we took it out, it was no big deal. It just used this attack function. Well, now whenever you run it, it says, you get an error message right here, and the reason is because you made a pure virtual function in C++, and the programmer made a deal. He said, alright, programmer, whenever you make a pure virtual function, you need to override it. That's our deal. So in this class, alright, you did a good job. But in this class, you didn't override it at all. So whenever I try to call this attack function right here, nothing's happening, equals 0. So that's why whenever we use pure virtual functions, we need to override it. So that can be good and bad depending on what you're going to try to program. If you want to make a game or something that, if you don't want a monster to have a specific attack, it can just inherit the enemy attack, that's fine, then you don't want to use this. But if you want to make a game with a bunch of different monsters or something, and you want each of those monsters to have a specific way of attacking, then you would want to use a pure virtual function, because whenever you use a pure virtual function, it's going to make sure that you overrode it. So now that we overrode in both the ninja class and monster class, we're going to go ahead and run this, and it's going to work just fine. And you're saying, alright, so I understand what a pure virtual function is, but what is an abstract class? Well, this is like the easiest thing you ever learn. An abstract class is just a class with a pure virtual function in it. Pretty easy, huh? So it took me like 5 minutes to describe what a pure virtual function was, and then, like 5 seconds to describe what an abstract class was. So let's go ahead and recap one last time. Alright. Abstract classes are just classes with pure virtual functions in them. Now, whenever you make a pure virtual function, you don't have a body, you don't have curly braces, you don't have any implementation whatsoever. It's just a function that says any derived class needs to overwrite this function. It's just kind of checking to make sure you overwrite this function. Now, regular virtual functions have the option of being overridden in the derived class. So if this was just a regular virtual function, then we can go ahead and take this attack out if we want, or we can go ahead and include it. But a pure virtual function, we need to overwrite this attack function and give it, some code to run. We just can't, run this equals 0, or else the computer is going to flip out. So basically, before you can make an enemy object that use attack, wait, let me think how I'm going to say this. Well, basically I just said all I needed to say. I'm just gonna, tell you guys how it works in my program, but I think I just said everything I needed to say. So basically, well, I'm not even gonna do that because I just explained it like 5 times. So anyways, that is what a pure virtual function is, and all abstract classes is a class that has a pure virtual function in it. So I don't know if in the next lesson I'm gonna be showing you guys how to make a how to put polymorphism to use, or we're going to be moving on to another subject, but either way, it's going to be amazing, so stick with me, and yeah, we're almost done with polymorphism either way, so if it's stressing you out, just take a deep breath, and the end is near. So thank you guys for watching, don't forget to subscribe, and I will see you guys later. Alright guys, welcome back to your 58th C++ tutorial, and in this tutorial, I'm going to be talking to you guys about something called a function template. Now, before I actually, just give you guys a definition and show you guys an example, let me go ahead and throw a quick scenario at you guys. So say you're working for Microsoft and your boss Bill Gates comes up to you and he's like, Bucky, I need you to create the world's perfect calculator. So you say, alright Bill, let me be, I will do this. So the first thing you would probably do is this. You're going to create a function maybe to add 2 numbers together, add 2 integers together. So you're going to write int is your return type, name the function add crap because, it's the most professional thing I could think of. And then you'd write like int a and int b for your 2 numbers. And then all you need to do in the body is, add them together and return them. So like return a plus b. So there's your function right there, add crap. It adds 2 numbers together. So whenever you want to use it in your main, you would need, 2 integer variables like int x equals 7, y equals 43, and we'll store the answer in a variable called z. So now we would put z equal to, what do I name it, add crap, and we would just throw our 2 variables in here. By the way, I got a new keyboard the other day, and it's really different, so I keep like hitting, the wrong keys that are only 1 off, so, just deal with me if I have a lot of typos in this tutorial. So anyways, what we do is go ahead and throw our 2 variables in there, and then, just print it out on the screen, make sure I didn't mess anything up. So cout Z end line. So let's go ahead and build and run this and make sure we didn't get any errors, and we get 50. And upon checking, we find out that 43 plus 7 is indeed 50. So that is our function add two integers together. But he didn't say I want a program to add two integers together. He wants a calculator. So we're saying, all right. So we have a bunch of different, types of numbers besides integers. We have a float, a long, double, every, you know, some with decimal points, some just with basic integers. So we're going to need to take this function and, copy it and, basically make the same exact function, but make this one using doubles, make this one using floats, make this one using long, and as you can see already, this program is going to get huge and it's going to get messy. And if we ever decided that we messed up something, like we put minus here instead of plus, we're going to need to go back on every single function and fix them all. And it's just going to be a big pain in the butt. So you're saying, alright, since this function pretty much is doing the exact same thing, wouldn't it be nifty if we could just, instead of this int right here, just replace it with like a generic data type and throw in any information we want? Well, that would be a little bit too easy. Or would it? Is there a way that we can indeed build functions that could handle multiple types of data? Well, you guys are in luck because that's exactly what I'm going to be teaching you in this tutorial. Instead of building a function that can only handle one type of data, if we're building a bunch of different functions that did the exact same thing, why not code this to handle multiple types of data? Well, in order to do that, we first need to build something called a template definition. And what a template definition is going to do is we're going to be building a generic type of data. Basically, all we're going to be doing in this line of code. So let's go ahead, and in order to do that, you first write the name template. And now, inside angle brackets right after it, you write class. And then you give your class a name like Bucky. Now Bucky is pretty much a template. It's not, an integer. It's not a float. It's not a character. It's just a generic type of data. So then we can use that generic type of data. Let's go ahead and copy Bucky. And instead of, having int or double or long, we can just go ahead and type in our generic type of data anywhere we would use, a specific type of data. So now your return value is Bucky. Instead of passing it in an integer called a, you're passing it in a Bucky called a, and instead of passing it in an integer or a float or a double called b, we're just passing it in a Bucky called b, whatever the heck a Bucky is. So now let me go ahead and run this, and I'll show you guys that this works beautifully, just like that. So what's happening is this. Instead of building functions that take, that take two integers and return an integer, we can just throw in generic data types instead using this template definition right here. So your template definition is pretty much building a generic type of data, and then instead of, taking a function that, works with one type of data, you can just use that generic type of data to work with any different type of data. So, we used integer right here, but say we wanted to use double. And remember, a double is just something with a decimal point, like 7.65 or 43.54. And now, whenever we go ahead and, yeah, I just accidentally pressed something. Let's go ahead and, yeah, now my computer's freezing. That is, yep, and that's just great. Not responding, and X that out. Now just go ahead. I'm not in the middle of a tutorial or anything. I can wait for you guys. You know what? Minimize you. You can stay there if you want. Let's go ahead and build and run this. OMG, are you flipping kidding me? Must be stopped to do a rebuild. Yes, I want to stop it. See, that's what you guys get when you buy a new keyboard and all the keys are like all over the place. I swear, this is like a keyboard. Oh, wait a minute. Oh, it was upside down. Okay, it's fine now. Okay, so as you can see, instead of integer, if we throw a double in here, it calls the exact same function and it works fine. So basically, whenever we make function templates, we're doing this. We're making first a generic type of data, and instead of making a function specific to one type of data, we're going to use that generic type of data. And now whenever we call that function, C++ is going to automatically see that x is a double and y is a double, So you must be working with doubles here. So instead of Bucky, it's going to substitute the word double. That's literally what it does. It puts double right there, and double right there, and double right there. And it runs it just like that. And now if we go ahead and we had an integer like 7 and 43, it would take anywhere where it said Bucky and it would change it into int, int, int. So as long as we have that generic type of data like that, it's going to go ahead and it's going to work with any data we have. The one thing that you can't do is you can't have an integer x and a double y. You can't have two different types of data. Well, actually, talking about that, there is a way that you can make template functions that take different types of data. But for now, I just want to cover whenever you have a function that does the exact same thing and you want it to be able to work with multiple types of data, you can build a template function. And what that means is you're pretty much building a generic type of data, and you're going to be using that generic type of data inside your function instead of, integers or doubles or anything like that. So then whenever you use your function later on, you can use it with integers, doubles, or you can even build it to work with like strings and characters if you want, but you can't really do that using addition. So anyways, in this tutorial we learned how to work with one type of data using a function template. In the next tutorial, I'm going to show you guys how to work with multiple types of data, like how to add an integer and a long together, or a double and a float, and all that good stuff. So thank you guys for watching, and I'm going to go take a keyboarding class with this keyboard, and hopefully when you come back I'll be a little bit better. So one last time, thank you guys for watching, and don't forget to subscribe, and I'll see you in the next video. What is going on, guys? It's Bucky and welcome to your 59th C++ tutorial. And in this tutorial, I'm going to be teaching you guys how to use function templates, but instead of just a single parameter like last time, we're going to be using a multiple parameter. So let me go ahead and explain to you guys what the heck I'm talking about first. In the last tutorial, I taught you guys how to build basically a generic function to add like two integers together, or to add two doubles together. Well, in this tutorial, we're going to be able to work with two different data types. For example, we're going to be able to take an integer and a double and add those together. Or maybe, a long and an integer and add those together. So they don't have to be the same data type. All the parameters we pass in, we can work with two different types of data in the same function. So we're going to need to set this up a little bit different than we have before. So let's go ahead and first get two different types of data to work with. So let's go ahead and make an integer variable x and set this equal to 89, or any integer you want. And go ahead and make another, double variable. It really doesn't matter the data type as long as they're different. So pass it in a double y and set this equal to, some 56.78 or something like that. So now what we're going to be doing is we're going to be building a function to compare these two numbers and just return whatever number is smaller. So in this case, it would return 56.78. So let's go ahead and pass in those two numbers, x and y. And hopefully, if we build our function correctly, it'll print out the smaller number right on the screen. So let's go ahead and set up this function template right now. So like before, whenever we're building a function template, we always need the keyword template, but we need to spell it correctly. Template, just like that. And now, unlike before where we just had one generic class and we named it Bucky or something, we're going to be working with more than one generic class. So make sure you name your classes something that you can work with later on. I like to just name mine first and second. And by the way, I might as well mention this to you guys. You guys are going to see this a lot, like capital T and capital U. It's like kind of a programming standard to use one capital letter whenever you're making a template class, but I really don't like doing that. I like something a little more descriptive, like first and class second. If you're in like a programming class, or you're watching this because you forgot how to do this for your job or something, you typically want to use one capital letter, but whenever I'm programming, you're just going to have to deal with it. So now that we have a template, this line is pretty much saying this. We're going to be working with two data types, but we don't know what those data types are yet, so we're going to be giving them generic names. So first and second. So whenever we're building our function, you first write the return type, which is first. And now our function name was smaller, and it took two parameters. One number, and we'll call this one A, and another number, and we'll call this one B. And all our function itself does is hello. And all our function does is it takes two numbers and returns whatever one's smaller. And we can do that by writing one nifty line of code. If A is less than B, then return A. If not, return B. So it's going to be saying, alright, is A less than B? If it is, return A. If it's not, return B. So it's basically going to return to you the smaller number. So now, let's go ahead, and now that our function is working properly, let's go ahead and test this and make sure it works. As you can see, we compared 89 and 56.78, and it turned that double 56.78 into an integer. And you're saying, alright, we just compared two numbers, so shouldn't it be giving us just 56.78? Why did it chop off the 78? That's because of this. Whenever we built our function template, it pretty much saw what type of data we were passing in. So we're saying, alright, we want to get the smaller of two numbers. We want to first pass you in an integer, 89, and then a double, 56.78. So I said, alright, make first, in anywhere you see first, change it to an integer. So it said, alright, I'm going to change this to int, this to double, and I'm going to return an int, because that was the first thing we passed in. So since this return type was the first type of data we passed in, it converted this double to an integer, because remember, anytime you saw first, it converted it to an int. We could have changed this around. We could have, passed this one in first, so it was yx, and whenever we did that, we would get 56.78. In that way, we could have it more precise, because in this case scenario, the first thing we passed in is a double, and the second number we passed in was an int. So whenever it's looking at your template, wherever it sees first, it's going to replace it with double, and that includes the return type right here in the first parameter, and the second parameter would of course be an integer. So it would take a double and an integer, and since it returned a double, that's why we got back the double. So basically what I'm saying is this. Whenever we're working with two different types of data, you need more than one generic classes, or pretty much placeholders. Basically a generic, a generic class is just a variable for the type of data instead of the value itself. Does that make sense to you guys? So instead of having a variable for this, you have a variable for this. Simple enough. And these variables can only be types of data like int, double, long, yada yada yada. So basically, people usually build these templates to work with. You usually don't see more than 3 or 4. It's usually 1 or 2. But yeah, that's basically how it works. Anytime you want to build a function template that takes more than one type of data, you need to separate them into more than one generic classes. And then you can use those generic classes just like you would any other type of data. So hopefully you guys understand what that means. Again, if this is just too confusing and you don't want to keep track, you can go ahead and build a lot of overloaded functions, and it's going to work, just fine. But if you want to use this, it's going to save you a little bit of coding, and it's a little more confusing to look at, but once you got it down, it makes your life a whole lot easier. So thank you guys for watching. Don't forget to subscribe. If you have any questions, just ask me on my forum, and I'll try to answer them for you guys. Sometimes I'm busy, but I can usually answer them for you guys. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome back to your 60th C++ tutorial. And in this tutorial, I want to talk to you guys about class templates. So before we learned about function templates, but in this tutorial, I want to tell you guys, aside from just functions being able to use templates, entire classes can use templates as well. And again, by template, all I mean is a generic data type. So let's go ahead and build it right now. So just like before, the way you make a template definition doesn't change. You go ahead and write template, and then inside your angle brackets you write class. And I might as well, start good programming practice and use what people typically use, and that's just one capital letter instead of, a word. You can use a word. I like using a word, but since I'm teaching you guys, might as well get into a good habit. So now, after this, now we basically made a generic data type. We can begin making our class. So go ahead and make a class. I'm going to name mine Bucky, and let's say that, well, let me add my semicolon before I forget. Bucky is going to have two variables. Now we don't know what those variables are yet, whether they're ints, doubles, so I'm just going to name them T, my generic data type. One's going to be named first, and one's going to be named second. So now let's throw a couple functions inside Bucky. So they're both going to be public. Might as well go ahead and make our constructor Bucky, and in our constructor, let's just go ahead and for two numbers set first and second equal to whatever numbers we pass in. So TA and TB. Basically, we're passing it in two numbers, which we don't know what type of numbers they are yet. So now let's just go ahead and set first equal to A and second equal to B. So now these two numbers in Bucky are going to have a value. So that's what's going to happen whenever we first build a Bucky object. So now after this, we can go ahead and, just add another method like T bigger. And all this is going to do is it's going to find out which number is bigger. We'll actually keep this constructor definition right in here, but we'll take this bigger function and we'll build it outside, because there's a couple of different rules I want to teach you guys. Whenever you build a function template, what did I say? Function template? What the heck is that? Whenever you build a function member outside the declaration of the class template. So let's go ahead and do that right now. Let me make sure I have all my semicolons in the right place. That looks good, that looks good. One down there. Looks good so far. I guess we'll find out later on when I run it. But okay. Now the first thing I want to note is that even though we made a generic type of data right here, whenever you have a function member outside the declaration of the class, and remember, we said we're going to be building a function called bigger that belonged to the class Bucky, but we're going to be doing it outside the class, we always need to have that function definition again. So go ahead and copy this and paste it. I don't know why they made it where you needed it again, but they did. So before every single function, you need to have that. Now here is how you start out building your function members outside the declaration of the class template. You first write your return type, and our return type is of course T, just our generic return type, and then just like before, you write what class you're going to be working with. So I'm going to be working with Bucky, and I'm going to be building a function called bigger. But we just can't go ahead and type, the function body right here. We need to do something first. Right after your class name, you need to add angle brackets and add your T right here too. And this is because we need to tell C++ that the function's template parameter is the same one that we're going to be using for the class. So in order to do that, we need to specify that T inside angle brackets right after the class name. If you're saying, that's kind of weird, well, I agree with it. It is kind of weird, and it's kind of stupid too, but if you think this is stupid and complicated, you're going to have to take it up with the people who made C++. I just teach it. For the record, I don't think it should be made this way, but after the class name, you need to include that function template parameter. Again, I think it's a stupid way of doing it, but hey, I didn't make C++, I just teach it. So now we can go ahead and, well, of course, this function called bigger is just going to take the two numbers that are in the Bucky class, first and second, and it's going to find which one is bigger. So it's basically going to be the opposite of what we did last time. So just go ahead and return, and we'll compare. If first is bigger than second, then return first, else return second. So this looks good to go right now. Well, I think that's all we have to do for a class. So basically, we have a class called Bucky. Now, Bucky has two variables in it, a first and a second variable. Now whenever we make a Bucky object, that's when we give the first and second variable their values. So first is going to be like 10 and second is going to be like 20. And now we have another function just to find out which number is bigger. So whenever we call the bigger function, it's going to take the first number and the second number, which would be like 10 and 20. If 10 is bigger, it's going to return 10. If 20 is bigger, it's going to return 20. So now let's go ahead and make our Bucky object and run this, and let me show you guys how it works. So if you think you guys know how to do this, you don't, because there's one other little weird thing that you have to do. You go ahead and make your Bucky object just as you think you would, making Bucky object, and since this is a constructor that takes two parameters, first and second, we need to give it its two numbers like 69 and 105. And now after this, we can go ahead and see out bo dot bigger, and remember, this bigger doesn't take those two numbers as parameters. Since this class already has two variables in it, it's just going to go ahead and grab those variables. So as you can see in this bigger function, we don't need to pass it in those two numbers, it already has it. So let's go ahead and build and run this, and you say, alright, what the heck is this? Why are we getting an error message? That's because whenever, well, let's read the error message. I'll show you guys what it says. Missing template arguments before BO. Whenever we're working with the class template, we need to explicitly tell it what type of data we want to substitute for t. And we're going to be working with integers because 69 and 105 are integers. So between your class name and your object, you need to pass in I and t in angle brackets. So like I said before you go ahead and start making these objects, if you think you know what you're doing, you don't. This is what people typically forget. So in the last couple tutorials, we could have done this and it was optional. I decided to exclude it. Well, in this tutorial, we absolutely need to have it. And whenever we do this, we're basically saying, alright, this is what we're going to be substituting for t. So if this was double, and we made our class object, anywhere this class saw a t, it would plug in double right here. These two numbers are doubles. When our constructor is made, we're going to be passing in two doubles. Whenever we run the function, it's going to be a double instead of a t. Well, since we're going to be working with integers, we're basically telling our class, anywhere you see a t, substitute integer for it. So that way we can work with, different types of objects, and maybe we'll make one class an integer and one class a double. And well, let me go ahead and first run this and show you guys that it indeed works. 105 is indeed the bigger number. And if you don't believe me, I'll just change this to 258 and run it again and show you guys that our program is working correctly. So basically, there are a couple weird rules. The first rule I want to tell you guys is every single function you build, you need to precede it with this function template. It's kind of weird, but it's what you need to do. Also, you need to have the blank generic data type after your class name, and this pretty much tells your function that we are indeed working with the class's template parameter, which is this one. And also, the last thing you guys got to watch out for is whenever you make your objects, you need to explicitly tell your object what type of data to substitute for t. And you do that between your class and your object declaration right here. So there are a couple of weird rules. Again, I want to say this. If you guys are stuck on templates and this is just way too confusing for you guys, all the substitution, forget about them. You don't need to build it. It's just if you want to build a program that takes less code and makes it a little bit easier, then you have the option of doing this, but it isn't a requirement. So if you don't completely understand it, don't worry about it. You can move on, and you're not going to be lost on C++. So anyways, thank you guys for watching. Don't forget to subscribe. Don't forget to check out my website, and I will see you guys later. What's going on, guys? Welcome to your 61st tutorial, and in this tutorial, I'm going to be talking about something called template specialization. There we go. Might take me a few times to get it, but basically what template specialization is it's a way to make a class that has a different implementation when a specific type is passed into it. For example, if we made a regular old template like before, we could pass any data type into it, like integers, doubles, characters, and it's going to be able to handle any of that data. Well, in this tutorial, I'm going to be showing you guys, say for example, you want to build a template to handle all numbers, but you want it to do something a little different when it handled characters because, let's say you wanted to build a class that handled numbers and it added them together. Well, you can't use all these same functions whenever you're adding letters together, or else you're going to get a bunch of errors. So it's basically a way of working with a specific type of data in a different way than you would regular. So let's go ahead and the first thing I'm going to do is build a regular template and I'm going to compare it to this new specialized template. So our boss came up to us and he's like, Bucky, why is he talking to us and only using my name? I'm not sure, but he's a little weird. So he's like, Bucky, I want you to build a template to handle all types of data. However, if the user passes in a character, which is this one specific type of data, I want you to work with it in a different kind of way. So one class or one template is going to take integers, doubles, floats, any type of data we pass into it, but whenever we pass it in a character, it's going to handle it a little bit differently. So after me talking for 2 minutes, it's finally time to start coding. So let's go ahead and build a regular template, and this is named class T. So remember, T can be any type of data, and I'll just call this class Spunky because, kind of in the spunky kind of mood. Did anyone ever used to watch Rocko's Modern Life? What was that dog's name? I'm pretty sure it was Spunky. But anyways, let's go ahead and make a public. And the only thing I'm going to be making in these classes is just a simple constructor because I don't need to demonstrate a whole lot. I just need to demonstrate the concept and, not build a huge functional class. So in order to make a constructor, you of course write the class name, which is Spunky, and pass in any type of data, and we'll name a variable x whenever we first create an object. So all we're going to do is we're going to create a class, pass it in an object, and print it out on the screen. So cout x, and then go ahead and write something like is not a character because we're going to be passing in any type of data like a number, and it's going to make 5 is not a character or 6.17 is not a character. So this class is going to handle everything besides characters basically. So let me go ahead and make sure I got all my semicolons in the right place, and let's go ahead and see a quick example right now. So actually I'll wait to show you guys an example. Not yet, I'll make you guys wait. So this is how we build a basic template. It can take any type of data we want it to. Integers, characters, floats, doubles, and it could say whatever thing we passed in, like J is not a character, 4 is not a character, 8.76 is not a character, and it's going to work fine with any type of data. That's the beauty of templates. So say whenever the user passes in a character, we want it to be able to do something differently. Well, that's where template specialization comes in. And in order to do this, go ahead and type template with empty parameters right there, or empty angle brackets. This is the line where we tell C++ we're going to be using template specialization, and in the next line we're going to tell it what type of data this class should handle. So this, again, we can name it the same class as before because the main implementation doesn't really change. It's only the data type in concept. And the class, or excuse me, and you write your class name, and in between the angle brackets after your name, you write what type of data should this class handle. Alright, this is a special class that I want to handle characters. Characters only. Nothing to do with numbers or any other data type, anything like that. This class is only going to be for characters. So again, one last time, the only thing that's really going to change is this line, which tells C++, we're going to be using template specialization, and this class that says, alright, since you're using template specialization, what type of data should this specialize in? And this class is going to specialize in characters. So let's go ahead and make that constructor public. And of course, it's the same, Spunky. However, in your parameters after it, you don't write tx because remember, t is a generic data type. Since this class is only for characters, go ahead and write character right there. And now the body is just like before. Let's go ahead and copy this, copy right there, and paste it right there. Except we can't have x is not a character. We can write x is indeed. Oops, no more explanation points needed. is indeed a character. So basically how our program is going to work is this. We're going to be creating objects, and we're going to be creating objects of a bunch of different types: integers, doubles, characters. Whenever our computer program comes across the character, it's going to handle it with this specialized template. Any other type of data besides character is going to go to this generic template or generic class. So, any numeric data such as integers, doubles, floats, yada yada yada, this is going to handle it. But once it sees it's working with a character, it's going to handle this class right here. So it's going to be like 4 is not a character, 8.0 is not a character. But if we throw in something like J or Z, it's going to say Z is indeed a character. So don't believe me? Well, let me go ahead and prove it to you guys. So the first thing I want to mention is, I know I didn't tell you guys this, but you can explicitly, well, let me say this. Whenever we passed in a data type before, C++ already automatically recognized what type of data type that was, but you can also do something like this. You could throw in your angular brackets the data type right after the class name, and this helps C++ out. And oh great, there's a motorcycle driving by right now. And this helps C++ out by, it basically changes this to T, or it substitutes T for the data type. It's kind of just a a nice little hint for Objective C. So let's go ahead and make object 1, and since we're going to be working with integers, we'll go ahead and pass in 7. So now let's go ahead and copy this, save us some typing. And now let's create 2 more objects. So 2 and 3. In our next object, we're working with double. And remember, a double is basically something that you can use decimal points like 3.154. And now for our third one, let's go ahead and use that character. And remember, a character is just a letter. So Q or something like that. So basically what's going to happen is this. It's going to come across this, sees it's working with integers, and use this generic template right here. When it gets to here, it's going to be working with doubles, and it's going to use this generic template right here. When it comes across this, it's going to be working with characters, and it's going to say, hold on a second, you have a special class right here just made for working with characters. So on this one, I'm going to print Q is indeed a character. So let's go ahead and build and run this, see if I forgot any semicolons, and it looks good. So 7 is not a character. 3.154 is not a character. Q is indeed a character. So as you can see, these first 2 lines right here use the generic template class, and the last one, whenever we had a character in there, it used that specialized character template class. So there you can see the beauty of specialized, or excuse me, they're called template specialization. So there you go. It's basically specialization with one data type. In other words, you have a different implementation when a specific data type is passed in this case, character. So there you go. I hope you understand it. If you don't, just go ahead and ask me on my forum, or leave a comment below, and I'll try to answer it for you guys. So thank you guys for watching. Don't forget to subscribe to my channel, and I will see you guys in the next video. What is going on, guys? Welcome to your 60-second tutorial, and in this tutorial, I'm going to begin talking about something called exception handling. Now, an exception is a way of handling an error that might occur when your program is running. For example, if you built a calculator and the user is trying to divide by 0, that may be an error that occurs when the program is running. Or if you made a game and you need a user to register. If they try to use like 999 as their age, that's unacceptable, so that may cause an error to occur. So let's go ahead and take a look at the syntax for this. Now, the first thing we need is something called a try block. Now, in this try block, this is where we write the code that we want to try, aka the code that we think an error might occur. So let's go ahead and make something like, I'm going to be making a simple program that takes 2 ages, the mother's age and the son's age. Now, we all know that a son cannot be older than its mom. So whenever the son's age is greater than the mom's age, this would of course cause an error. So let's go ahead and make 2 variables, int mom's age and int son's, actually might as well set them equal to values right now. Int mom's age equals like 30, and int son's age, we'll set this equal to 34. Now we all know this is impossible, so let's go ahead and test it right now. So if the son's age is greater than the mom's age, then we want to go ahead and we want to do something called throwing an exception. Now, it's basically this. Whenever you have something that occurs that shouldn't occur, we need to tell the computer that an error did occur, and we do this by throwing an exception. And in order to throw an exception, go ahead and type throw and then type an error number. And you can make this any number you want. You can actually do other things besides numbers, but just throw a number because later on, say we made a program that checked for 20 different types of errors, we want to know what error got caught. So let's go ahead, and we already know that in our little manual, 99 means that the mom is younger than the son. So it's pretty much just a reference number. So anytime we get an exception, and remember, anytime this line of code is going to run, it basically means that an error occurred. So now that we know an error occurred, we need a way to handle that error because we just don't want our program to freak out and shut down. So in order to handle the error, we do something called catch the error. Catching the error allows you to pass in that number, which is 99. So now x is equal to 99, and we can handle it a certain way. For example, we can just output to the user something like this: son cannot be older than mom. And then for reference, we write error number, and this is where we write that x right there, end line. And just scroll ahead so you guys can see what I'm typing. So now, if we go ahead and run this, we can see, alright, whenever this program runs and the kid is older than the mom, then we have an error message that pops up that says son cannot be older than mom, error number 99. So, this is pretty much just for our reference, this error number. But let's go ahead and say that the mom was indeed older than the son. The mom was like 50 and the son was 34. Well, this is going to work fine, and this is never going to happen. So no error is going to be thrown. No exceptions are going to be thrown. So this catch block is just going to be skipped. So let's go ahead and run this, and we don't get any error messages. This program works perfectly. So basically, the concept of this tutorial is this. An exception is a way of handling errors that may occur when your program's running. For example, if the user tries to divide by 0, or pretty much if the user does something they aren't supposed to do. Now in the try block right here, this is where you write the code where the error might occur. And right after it, you need a catch block. Now the catch block is basically what to do if there is indeed an error. And if there is no error in this try block, then the catch block is skipped altogether. And just like a function, a catch block takes parameters. So it can take an integer, in this case, such as 99. And that's pretty much just like an error number. Whenever you're just playing on your computer and Windows messes up, you know how like the error message pops up? Well, that's pretty much what we're doing right here. It's like error message, yada yada yada. Do you want to send to Microsoft or do you don't want to send? And by the way, does anyone ever send those? Do they really get those error messages? I don't think so. But anyways, now you guys know the basics of exception handling. And by the way, if you guys are saying, you know what, Bucky, I could just have used an if statement and made a separate function for this. Well, I know that we can do this a different way, but exception handling is useful whenever you're trying to do computer stuff like allocate memory. I just want to show you guys a real easy example for this case, but I know that you could have probably made this program just by using a basic if statement and maybe a simple function or something. But I wanted to demonstrate the try and catch block and how to handle an error message. So these are useful for a lot more than comparing two variables, and there are some instances where we can't just make a simple program, that we need to use this exception handling. So for now, I just want to tell you guys that. So I guess in the next tutorial, I'm probably going to show you guys another example and show you guys how you can use a different parameter for this catch block right here. But for now, that's all you guys get. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What's up guys, welcome to your 63rd C++ tutorial, and in this tutorial I'm going to be showing you guys another example of exception handling. So let me go ahead and I want to cover one other little inky dinky thing. It isn't a main concept, but if I don't cover this I'm going to it's like OCD. I need to cover it or else it's going to bug me for the rest of my life. So let me go ahead and first, what I like to do is this. Whenever I'm working with exception handling, I like to set up the framework first. So I like to go ahead and put try right there, and after this put catch with my parameters right like that. And that way, whenever we get type in a bunch of code in here, I don't have to go search and be like, alright, what's this curly brace go to? What do these parentheses go to? It's really easy if you set up the outside first and work your way in. Then that way you don't get confused. So let's go ahead and in this program, I just want to build a really simple calculator. I'm going to have the user input two numbers, and I'm going to make sure that the bottom number is not 0, because remember, you're not allowed to divide by 0 or else your computer is going to blow up. So what I like to do first is well, before I even do that, let's go ahead and just start with the program. So let's go ahead and make two variables, int num1 and I'll save int num2 for later. So let's go ahead and give the user prompt like cout, and we'll just say something like enter first number, end line. And now let's go ahead and give them a way to enter that number into num1. And by the way, I read this a couple days ago, and maybe this will help you guys understand this arrow and this arrow. The arrow shows the direction that information is flowing. Now, whenever you output something, it goes to your computer screen. So this text is going to your computer screen. Now, whenever you input something, it gets inputted and stored as a variable on your computer. So the text that you enter is going to be stored in a variable in your computer. You see where the information's flowing? To your computer screen, to your computer. Basically, the information is flowing to the user and back into the computer. Pretty cool, huh? So I probably should have said that in like my second tutorial, but 63 tutorials in, I guess is better late than never. So now the user entered a number and it's stored in the variable number1. So now let's, well, might as well just copy this right here and copy this and paste it right over here, and we'll change this to 2. So enter 2, it's going to be stored at 2, and enter second number. Pretty good. So now after this, what we want to do is, it really doesn't matter what number they enter for number 1, as long as it's a number. But number 2, it does matter, because the second number cannot be equal to 0, because if you remember from 5th grade math class or whatever, you can't divide by 0. It's illegal. The math gods will not allow it. So let's go ahead and have an error message pop up whenever you try to divide by 0. And we can just go ahead and put a simple if statement. If num2 is equal to 0, let's go ahead and throw an exception. We'll just throw the number 0. And now what we want to do is, remember, if number 2 is not equal to 0, that means that the numbers that they entered were valid. So we'll just go ahead and print out the answer on the screen. Num1 divided by num2, and in that line. So basically, if they enter 0 as a second number, we're going to get an error. If they enter two valid numbers, it's just going to print out the answer by dividing the top number by the bottom number. So if we do indeed get an error, remember, in the last tutorial I taught you guys that you can pass in a number to use as like an error reference number, and you can just write something, cout, you can't divide by x. And that way, whenever we throw 0, it's going to pass 0 in as x, and it's going to say you can't divide by 0. So let's go ahead and run this and see what happens. Enter the first, I'm going to first run a program that works perfectly. Enter 32 for my first one, enter 16 for my second one, and 32 divided by 16 is indeed 2, as we can see here. So my program is working beautifully. But let's go ahead and say that we have an idiot that's gonna, never knows how to use a calculator and is gonna try to divide by 0. Okay, 32. Okay, everything's going good so far. But then I'm gonna try and enter 0 as my second number, and whenever I try to hit this and solve this riddle, we can see you can't divide by 0. So as you notice, as soon as you get an error message, it basically just jumps right down to this catch block right here, and it says, hold on, you did something wrong, here's your error message, you can't divide by 0. So now the little itty bitty thing I want to cover in this tutorial is this. You can have multiple catch blocks to catch different types of error messages. Right now the only type of error message I showed you guys is an integer error, but you can catch a double, you can actually catch a character if you want, you can catch any different type you want. Now, aside from covering that, I don't need to show you guys, the different types of error messages you can catch. But what I do need to show you guys is this little thing right here, ... You're saying, what the heck type is this? A ... Okay, I understand that I can catch, ints and characters. Whenever you just want any error message to be caught, for example, you don't know what error message is going to happen in this try block, but anytime any error message occurs, you just want it to be caught right here. Then you can use the ... So ... is pretty much the all-encompassing, the default catch. So basically, if you have anytime an error message is thrown, it's going to be caught by the ... no matter if it's an int, character, yada yada yada. So with that being said, this is the catch that you see most often. I just wanted to throw you guys the piece of information that you can indeed catch specific types of error messages, but this is the one you're going to see more often. So let's go ahead and try and run this, and it says, alright, and 1 second, I did something wrong. Oh, I see what I did. I actually tried to pass an X, and X is no longer existing. So I'm going to go ahead and try to run this one more time, and you see it says, enter first number, 32, and then we try to divide by 0, get an error message, and we get that default, you can't divide by error message. So typically you would want to write something like this. It would probably make more sense, but anyways, I just want to stress to you guys that aside from catching different types of error messages, you can also catch general error messages, and that's what we're going to be doing most of the time. So now that you understand most of everything there is to know about exception handling. There are a couple other things that I don't even know if I want to cover or not. There's like passing in objects that you can catch, and also inheriting from exception classes and default messages and stuff, but I really don't know if I want to get into that. I mean, we understand the basics. So in the next tutorial, don't know if I'm going to be covering more about exception handling or, jumping into the next topic. But either way, it's going to be amazing. So if you have any questions, check out my forum, thenewboston.com/forum. And yeah, I guess I'll see you guys in the next video. What's going on, guys? Welcome to your 64th C++ tutorial. And in this tutorial, I'm going to be beginning to talk about files. Now, we need to be able to work with files because files are what you use to save data on your computer. And you're saying, hold on, Bucky, I know what to use to save data. You can just, store the data in variables or something like that. Well, we can't exactly do that for permanent data. For example, whenever we store data in a variable and we close out of the program, or maybe we want to shut down our computer, that data is going to get wiped out. Now, in order to save data permanently, what we need to do is we need to store it on a file on our computer. And what this does is whenever we're working with files, it stores it to your hard drive. It permanently etches it in there. So then whenever we shut down our computer, we can go ahead and pull it back up and everything is going to be working fine. For example, if you were playing a computer game or if you had to write an essay for school, you wouldn't want to just store all that information in a variable because then the user would have no way of saving that data. So what we're going to be doing is we're going to be working with files, storing them on the computer's hard drives, and that gives our user a permanent solution to save data. Very useful, and well, you're probably going to be working with files in every single program you're using unless you're just making a cool animation or something. So let's go ahead, and the first thing I need to show you guys is we need to include an additional header file. So let's go ahead and copy this, save us a little bit of typing, and instead of IO stream, we're going to put F stream right here. Now this is the header file that we need for file input and output. Without this header file, we won't be able to work with files at all, basically. So that's your main file, I guess you could say. So let's go ahead, and now that we got everything included we need, again, this is to work with files. This is to input and output data, or basically how to add data to the file and read data from the file. So there we go, and let's go ahead and start coding now. So here is how you work with files in C++. The very first thing you need to do is you need to build an object. Since C++ can't work directly with the file itself, it needs to be able to go through objects just because, you know, whoever made C++, that's how they made it. So the very first thing we do is we need to write OF stream, right like that. And this allows us, well, there are different types of file streams. Basically, this is how you create a file object. And right after this, you give your file object a name, any name you want. I'm just going to name mine Bucky's file. Now we have a file object, aka access to a file. So now the first thing that we want to do after this is we need to associate this object with a file itself, because if we're just working with this object, it's like, alright, you have like a billion files on your computer. How am I supposed to know what object this one, or excuse me, what file this object is supposed to, you know, represent? Well, that's what we do in the next line of code. And in order to do that, we go ahead and type the name of our object and we open a file. And we just do that using the open function without the star right there and without this right there. We use the open function, and inside is a string. We pass in what file do we want to open. Now I'm going to go ahead and open tuna.txt, and you're saying, alright Bucky, I don't have a tuna text file on my website, or excuse me, sorry, I've been making web tutorials way too often. But if you're saying, alright Bucky, I don't have a tuna text file on my computer, so is it going to crash whenever it tries to open it? Well, no. Whenever you're working with files in C++ and it opens a file that doesn't exist, it's going to see that it doesn't exist and it's going to automatically create one for you. For example, my file is going to get created right here. Now as you can see in this directory, there is no tuna text file. So whenever I try to open it, it's going to look for a tuna text file and it's going to say doesn't exist. I'll create one for you. So it's going to get created automatically, and it's pretty cool because it saves us, you know, a line of code from having to create it. So basically what we're going to be doing so far is creating a file object. That way we have access to some file. And in this line of code right here, we're going to say what file do we want to be associated with this object. Well, now tuna text file is associated with this Bucky's file object. So now basically any input and output that we make to this object is going to be input and outputted in this file. We just can't, you know, input and output directly to the file because C++ won't let us. Basically, Bucky's file is the exact same thing as tuna text file from now on. So now we can go ahead and, you know, output characters to that file or whatever we want to output. For example, you're saying, alright, how do you output to a file? What are you talking about? Well, just go ahead and instead of outputting things to your computer screen like we have before, we use that operator right there, those two little less than signs, and we just write some text like I love tuna and tuna loves me. And we won't end that line. Actually, go ahead and put a new line just like that. And now you're saying, alright, before I had cout right there and it outputted to my computer screen. Well, now I'm going to go ahead and have Bucky's file right there, and all this text is going to output to a text file instead of the computer screen. So nothing's going to show up on the computer screen. What this means, this little operator, is output this data to this location. So before we were outputting the data to the computer screen, and now we're just outputting it all to a file. Simple enough. I mean, the operator is pretty cool and it works in that way. So now, like I said, we basically associated a file with an object in these two lines, and now anytime we use this object name, it pretty much knows it represents this file. So it knows whenever we want to output this text, it's really outputting it to this tuna.txt file right here. So that's going to run perfectly, but At the end of all your programs, when you're done working the files, you always want to close that object. And what that does is any, little memory or buffers or any resources that the computer was using when it was working with this file right here, it's going to close them out and it's going to free your computer's memory. So it's just good programming practice to do this. So let's go ahead and type our file object, Bucky's file, and just go ahead and type close with no parameters. So let's go ahead and run this program, and as you can see, nothing happens right here because we didn't output anything to the computer screen. But if we go ahead and take a look at that directory, we now have a tuna text document that got created. So if we go ahead and double click that, the content of this is I love tuna and tuna loves me. Pretty cool, huh? So as you can see, this would be useful whenever you're, creating a computer game and you have a character with a bunch of statistics like health and, happiness and hunger. They can go ahead and play the game for, an hour, store all their data, shut off their computer, go to school, go to work, whatever, come back, and all their data is going to be right there for them. It's not a new computer game every single time you start because that would be kind of a waste of time. So that is how files are useful in computer programming and how to work with a simple text file. So if you think you're done with files yet, you got a long ways to go. So in the next tutorial, we're going to be covering more about files, and trust me, there's a lot more information that we need to learn. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, welcome to your 65th C++ tutorial, and in this lesson, I'm just going to be giving you guys a couple tips when working with files, and this is, something that can save you time as well as some good programming practice. So it's going to save you a lot of headaches in the future. So let me go ahead and get started. So in the last tutorial, I told you guys that in order to work with files, you first need to do two things. You need to create a file object, and then you need to associate that object with a file itself on the computer. So let's go ahead and instead of doing that in 2 lines of code, let me show you guys how to do it in 1 line of code. So of course you need your OF stream because that's what object we're going to be making in order to work with files, and then you give your object a name like Bucky's file, and then you might be thinking, alright, just go ahead, put a semicolon, go to the next line of code, put Bucky's file, open the file you want to work with. But there's an easier way to associate this object with a file. Now, whenever you create a file object, it takes an optional parameter in the constructor. Actually, the entire constructor is optional, but if you want, you can go ahead and do this all in 1 line of code by associating a file by passing it into the constructor, and then whenever you create your object, it's going to associate that file with this object. So, for example, let's go ahead and make a file name beefjerky.txt. And now, instead of creating your object on 1 line of code and then associating the file with this object on another line of code, we can just go ahead and pass the file name into the constructor, and now this file is associated with this object. So it's probably better to get used to this syntax unless you're making a program where you don't know what file is going to be associated with this object whenever you're running it. So usually I like to do it this way just because it saves you a line of code, and again, this constructor is optional, but trust me, it's going to save you a whole bunch of time in the future. So now you can do things like Bucky's file, and then just go ahead and output something stupid like I love the beef. And it says, ooh, I love the beef, but good enough. And then go ahead and might as well add a new line and end that. Get my cursor out of the way. And then, of course, it's good program practice to have Bucky's file.close to free up any of our computer's resources. So let's go ahead and actually watch this file get made. So I'm going to go ahead and press run. And oh man, it closed it out. But anyways, you can see now that we have a beef jerky text file. So let's go ahead and click that, and it says, ooh, I love the beef. And I do love beef jerky. Can't lie about that. So let's go ahead and before I let you guys go, I want to tell you guys one more thing. A function that you're going to be seeing a lot if you're working with a team of developers, or if your teacher gave you an assignment working with files, is some function called isOpen. Now, isOpen is a function that you can use on a file object, and it's going to return true if the object is currently associated with a file. And this is a way that you can check basically if a file is open and, it's ready to be worked with. So in order to do this, go ahead and write if, and then you do this. Write your file object, which is in this case Bucky's file, and then write your function right after it is underscore open. Now this isn't going to take any parameters, and just go ahead and write something. If the file is open, then we'll just output on the screen like okay, the file is open. Good enough. And then might as well go ahead and end that line. And we'll say else, if the file is not open, then let's just go ahead and output like Bucky, you messed up. And we'll spell everything wrong, and looks good to go. So go ahead and end that line. So now what's going to happen is this. Alright, we coded this line correctly, and it did indeed open this beef jerky text file. So whenever we check if the file is open, this is open really isn't a good name. It really should be like if object is associated with a file. That might be a better name for this, but that would be a lot of text. So what this line is going to do is it's going to check if this object is associated with a file. If it is, which it is, it's going to output, okay, the file is open. If it's not and we did something wrong, it's going to say, Bucky, you messed up. So let's go ahead and run this, and indeed we get, okay, the file is open. So you're saying, alright, so when would be the case scenario when the file wouldn't open? Well, for example, if you go ahead and you made, your file object correctly, but you forgot to associate it with a file right here, then whenever you try to run it, it's going to say, hold on, Bucky, you messed up. You forgot to associate your object with a file. So that is a case scenario where we would want to check if the file is open or not. And basically, in programming, well, in the real world, how it works is this. You make sure it's open first, and then you write all your code right here. So it's a nice little check before you just start writing code like this. This is probably would be better if we threw it inside here, you know. So if you wanna, impress your boss or your teacher, just make sure your files are open before you start doing a bunch of crap to them, or else, it's gonna save you a lot of headaches. So with that being said, in this tutorial, I just want to stress to you guys that there is indeed an optional constructor where you can associate a file with the object instead of putting it on two lines of codes. And also, what you can do is it's a better programming practice to make sure your file is open, and by that I mean make sure your file is associated with the object before you start doing a whole bunch of crap to it. It's going to save you some time and save your computer a whole lot of headaches. So with that being said, that's all I have for you guys for this tutorial. So thank you guys for watching. Don't forget to subscribe, and if you have any questions still, check out my forum, thenewboston.com/forum, and yeah, I'll see you there. So thank you guys, and I'll see you next video. Alright guys, welcome to your 66th C++ tutorial, and in this tutorial I'm going to be teaching you guys how to make a custom file structure to work with your program, because whenever you build your own custom program, you just don't want to use any file format, plain off-the-shelf format. You want to build a custom file structure so that it makes it easier for your program to work with your files. And I know you guys don't know what I'm talking about now, but trust me, you will by the end of this tutorial. So the first thing we need is an idea. Actually, before we get started, let's go ahead and say that we wanted to make a game like SimCity or whatever, where we had a bunch of different players or a bunch of different characters, and we wanted to store all the character information in a text file. Well, the first thing we need is, of course, a text file. So go ahead and put OF stream, and we'll just name it like the file. Good enough, I guess. And we'll just go ahead and create a file called players.text. Now remember, if this file already exists, then C++ is going to it's going to open that one. But if it doesn't exist yet, which it doesn't, let me go ahead and pull up my directory. See, no players.txt. Since it doesn't exist already, C++ is going to automatically create one once it sees that it indeed does not exist. So let's go ahead and the first thing I want to give is we're going to be making a program basically to enter the character information. Say we wanted to build a bunch of characters ourselves. Well, let's go ahead and give the user a nice little prompt about what we want them to do. So cout, not mm, close, but not close. We'll just go ahead and put enter players ID, and then maybe they have a name for each player, and maybe they have like a bank account, money or something. Simple enough. And then go ahead and end that line. So this is just going to print some text out on the screen telling them what to do. So we're going to enter a number, a name, and another number. The first one's going to be the ID number. The second one's going to be their name, like Bucky. And third one's going to be like $48 in their bank account, something stupid like that. And now what we want to do is we're going to be working with something called an end of file marker. Now before I go on, let me say this. Every file on your computer, when C++ opens it, it's going to look for the end of file marker. This is pretty much the end of your file. It's, I mean, no weird complicated explanation. It's just a little symbol that goes at the end of your file to tell C++, how long your file is. Whenever it's reading your file and it gets to the end of file marker, that's where it knows where to stop. It's pretty much telling C++ where the end of your file is. Simple as that. Now, what we can do is we can explicitly enter an end of file indicator, and I'll show you guys how to do this later on, but basically whenever you hit control, hold down control and hit Z on your keyboard, if you're working with Windows, this inputs an end of file marker. And I know it's kind of a weird way to do things because if there was an end of file marker button on your keyboard, it would be a lot easier to see, but if you're working with Windows, then hold down control and hit Z, and this puts the end of file marker in. So we'll just go ahead, and they probably don't know that, so we'll just go ahead and press Control plus Z to quit the program and stop inserting characters or whatever. So go ahead and end that line. And I know that's a little weird, but we need it or this program would just keep running forever. So now we need 3 variables that are temporarily going to store this information. Just go ahead, we'll make the ID number an integer, and we'll make the name a string, of course, and we'll put the money, since it has decimal points like $48.87, we'll go ahead and make it double. So we have 3 variables: ID number, name, and money. Now what we need to do is we, the user, want to be allowed to enter this information whenever this program is running. So let's go ahead and make a while loop because we really don't know how many characters the user is going to enter. And here's what we do. Remember, anytime you want to get information from the keyboard, aka from the user, you use CIN. And then the first thing they type in is going to be stored in the variable ID number. The second thing they type in is going to be the character's name. And the third thing they type in is how much money the character has. So the user is going to be able to type characters information, maybe 5 different character informations, and then we want to be able to store it in a file. So this basically, the user is going to be able to type in as many characters as they want. So this loop is going to be true as long as they don't get to the end of the file. And how do you know you get to the end of the file? Because of this weird Control Z thing. So basically, whenever the user enters information, we now have an ID number, a name, and some amount of money. So now the only thing we want to do is we want to insert it into the file. So of course, remember, just like before in the last tutorials, we write the file object, and this is pretty much a synonym for players.txt. So they can be used interchangeably. Well, they can't be used interchangeably, but whenever you're looking at it, just assume that this means players.txt. So anything we insert it just gets directly inserted into the file players.txt because that's the file associated with this object right here. So the first thing we want to insert is the ID number, and then just so it looks nice and pretty, just go ahead and insert a little space. And then the next thing, what did we have? A name, and then a little space after that. And then the last thing is money and line. And let me make sure I got number, space, name, space, money, and line. Okay, so it's good to go. So basically, well, let's go ahead and run this program and see what we get. It says, alright, enter player's ID, name, and money. So let's go ahead and make a couple players for this, SimCity social community game, whatever the heck game we're making. So the player's ID is going to be like 1, and the player's name is going to be like Bucky, and the money I have is like $65.47. Go ahead and press enter, add another character. The ID is 2, The name is Sarah, and she has $43.21. And let's make one more. 3 is Sophie, and she has $2.54. Now let's go ahead and press, well, we can just go ahead and press Control Z right now. And sometimes you have to press enter and then your program is going to stop. Sometimes you can just hit Control Z and it's the end of file. Sometimes you need to hit Control Z enter. So anyways, I hit Control Z, that signified the end of the file. And of course, when I got to the end of my file, I couldn't insert anything else. So my program quit, as you can see right here. So now, if you go up to your documents, you can see that you have a text file created called players.txt. So let's go ahead and click that, and you can see at the, well, basically it inputted exactly as we inputted. Does that make sense? No? Well, too bad. You can see that it wrote to the file exactly what we wanted to, exactly in the format that we wanted to. So basically what was going on is this. We first created a file that we opened, and whenever we open it, we have access to that file. We then gave the user a nice little prompt, showed them how to input the data, and we then made 3 variables so we could temporarily store the data. Now, the user was allowed to fill in the variables ID number, name, and money. And whenever we had those variables populated with values, we just stored them in a file using whatever format we wanted to. And the format we wanted to store them in was the ID number, space, name, space, money. And then once you got one character or one player inserted, just go to the next line and do it again. So that way on the next line, it was ID number, name, money. On the next line, ID number, name, money. So that is how you can have, a way of storing data into a file formatted how you want it. So you're saying, alright, why would I want to format it like this? Well, maybe you wouldn't, but whenever you know the structure of how your file is formatted, that way whenever we open the file to read all the information in, we know what format it's going to be in. So that's why you want to create custom file structures, because custom file structures make it easier for your program to work with files if they know where the data is going to be and also what type of data is going to be there. For example, in our game, we knew that that first row was always ID numbers, that second row was always names, and that third row was always, and by the way, row, I mean column, that third column was always the amount of money. So, I mean, it just makes it really easy to program this way. So that's all I have for you guys for this tutorial. I know this was kind of weird with this Control Z thing. I probably should have made it without it, but hey, you guys learned something new, I guess. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What is going on, guys? Welcome to your, let's see, 67th C++ tutorial, and in this tutorial I'm going to be teaching you guys how to read custom data. So in the last tutorial what we did is, let me scroll to my desktop, Watermelon, we created this players text file, and what it did is basically allowed us to create our own custom file structure. And what we did is we were making our computer game with a bunch of different players. We gave them an integer as the ID number, a name, which was a string, and their bank account, which was of course a double. So now we have all our data right here, and it's laid out in a very specific way. No other program could really understand what this data is used for except our program. So now that we have that data, we need to be able to read it specifically in our own custom way. So it's a little bit different than writing it for a couple of reasons, which I'm going to be talking about. So the first thing I want to stress to you guys is you can't use OF stream. OF is for outputting data to a stream. For example, when you have text and you want to output it to a file or write it to a file. Whenever you want to read data in from a file, you need IF stream. This allows you to take data from a file and read it into, the computer's memory or whatever. So it's the opposite of OF stream. OF is for writing data to a file. IF is for reading data from a file. So then you go ahead and create your file object. I'm just going to name mine the file. And then, of course, is a constructor, optional constructor. It can take the name of that file. So players.txt was the name of that file. Again, you can either create the text file document, or excuse me, what am I going to say? The file object on one line of code or break it up into two. I always like to put it on one line of code, just like when we were writing to a file. So aside from that, what we're going to be doing is we're going to be reading the data from that document. So remember, that document had three pieces of information in it. On each row it had an ID number, a name, and the amount of money. So let's go ahead and make variables to hold that data. Int ID, and then we'll make string name to store their name, and double money to store their, bank account information. So basically, how we're going to do that is this. We're going to create a while loop, and the while loop is going to loop through each piece of information, whether it's their ID number, their name, or their money, and it's going to store it in a variable. And whenever we have that information stored in the variables, we can do, whatever we want with it. We can load it into our computer game. We can just go ahead and print it out on the screen. We can go ahead and send it to a database on the internet. But basically, what we have to do first is take that data from the file, and we need to store it on variables in our program. So I want to talk to you guys about how we're going to do this. Remember I said in the last tutorial that every file has end of file marker, and C++ pretty much is going to run this program until it gets to the end of file marker, and then when it gets to the end, it's going to return something called a null pointer. So let me go ahead and actually code this, and then I can explain what I'm talking about. So just like before, whenever we were, whenever you use like CIN to get information from the keyboard, and then you could store it in variables like this, well, now we're getting information from the file. So we go ahead and type the file, and that's where the information is coming from, and we're going to store in ID, the first piece of information, and the second piece of information we're going to store in name, and the third piece of information we're going to store in money. So it's basically going to loop through this while loop, and it's going to look at the file each time, and every time it gets to a new piece of information, it's going to store an ID, name, and money. Now, let me say this. Whenever you're working with files, there's something called a file pointer. And let me go ahead and open my document again, and I could probably show it to you guys really easily. Where's it? Watermelon players. So whenever you're working with files, you have something called a file pointer. Now the job of this file pointer is to keep track of where in the file C++ is working with. So what it's going to do is this file pointer, let me go ahead and skinny up my program a little bit, is going to start at the very beginning. And by the way, the end of file pointer is what right there where my cursor is. But anyways, your file pointer always starts at the very beginning. What this loop is going to do right now is it's going to read the first piece of information. So it's going to see right there, that's the first piece of information. That number 1 right there is what I want to store in ID. So next it says, alright, this next piece of information store a name. So it's going to scroll, the file pointer is going to go to this next piece of information, and it's going to see this one right here, Bucky, should be stored in name. And then it's going to say, alright, now the next piece of information, which is this right here, I'm supposed to store this in the variable money. So that's what's going to happen the first time this program loops through. So the next time it loops through, the file pointer is going to be right here. So that's why we didn't have to change any line of code right here, because we're working with the same object, yet it knows the next piece of information is this too, because the file pointer, the next time this loop runs, is going to be at the beginning of the next line, or at the end of this line, pretty much the same spot. So that is how the file pointer is going to be working. And by the way, it actually is called the file pointer, so I'm not making that up. So that's why this loop is going to run fine each time. So now that we have the correct pieces of information stored in ID, name, and money, we can just go ahead and, if we were making a game or something, we would want to load them into the game. But for now, let's just go ahead and print them out on the screen. So cout, print out ID, and then go ahead and I'm going to make a comma separated list instead of, spaces, because, if you're working with Excel, well, never mind. They use comma separated list, but anyways, I just like how it looks. So the next piece of information is name, and I'm just going to add a comma right there. And lastly, what is it? Money. So after this, I'm just going to go ahead and end that line, and whenever we run this program, it should work just fine. So what it did is it read that file from the text file 1 Bucky 65.47, and it did what we wanted with it. And in this case, what we wanted to do with it is just output it on the screen. So we said, alright, now that we have the information, output the ID, and then a comma, and then Bucky, and then a comma, and then money, and then end of the line. So it goes to a new line. So then, where this is working in the file is, it's at the end of the file, so whenever you run this loop again, the next ID it jumps down to is number 2. It runs the entire loop, it's at the end of that line, and then whenever you run this loop again, it jumps down to the ID number 3, and it runs that line of code. And how does this while loop know when to stop? Because whenever the end of file marker has been reached, C++ knows already, without us having to type any extra code, that a null pointer is returned. Basically, it changes this boolean to false. So whenever this is working, this is true. Whenever it gets to the end of file, C++ already knows that this loop should be false. We don't have to explicitly, write an if statement in here to check it or anything. It's one of the cool features with C++. It automatically knows when to end. So that's one cool thing that we don't have to worry about. Another cool thing that we don't have to worry about is whenever we're working with this ifstream or ofstream object, whenever the file reaches the end of the file and this goes to false, this object is going to get deleted automatically in the deconstructor. Remember when we talked about constructors and deconstructor? The deconstructor is going to call the close file method. So remember, like in the first file tutorial, I told you guys that you need to close your files in order to free up resources. Well, what this ifstream deconstructor is going to do is, as soon as this file object gets deleted, this file is going to close automatically. So that's two things we don't have to worry about. Whenever we get to the end of file, this is going to go to false, and the loop is going to end automatically. And also, whenever it gets to the end of file, the deconstructor is going to close the file automatically, so we don't have to explicitly write the file dot close. So pretty much everything is handed to you. You just gotta remember how to use it. C++ made it really, really simple to work with files if you really think about it. You don't have to do all the background stuff. So there you go. That's how you write and read a custom file. And again, your file structure is going to be different depending on the type of application you make, but that's the basics of it. So thank you guys for watching. Don't forget to subscribe. I know you guys probably have a lot of questions. Just ask me on my forum, thenewboston.com/forum. And I'm going to go to McDonald's, get an extra large milkshake, and well, check out my next video. So thank you guys for watching, and I'll see you then. Alright guys, welcome to your 68th C++ tutorial, and these next couple tutorials are going to be a chain of tutorials. I can't teach you guys what I'm going to teach you in one tutorial, so it's probably going to be like a 3 or 4 part series. But anyways, what I'm going to be teaching you guys is this. I'm going to be building a really cool program showing you how to work with files, and by the end of these tutorials, you guys are going to be a pro on how to work with files. So basically what we're going to be doing is we're going to be pretending we're making a computer game. Now in this computer game we have a character, and this character in his own little world is going to come across a bunch of different objects. Some objects have no effect on him whatsoever. Zero effect on his health or his, happiness, whatever you want to call it. Some objects like ninjas, meth, and dirty needles, they harm our character. So they're going to, have negative 54 energy, or we'll just say it's like energy or something. Now some objects like a fruit, soda, and candy help our character out, so they're going to give him positive energy. So as you can see, we have a file with a name and the effect that it has on our character's energy. So we're going to be building a program just to print out these different types of items and groups. For example, we're going to have the user press 1 if they want to print out all the plain items like a shoe, a pencil, and a chair. Press 2 if they want to print out the helpful items like fruit and soda and candy. And press 3 if they want to print out the harmful items like a ninja, meth, and a dirty needle. Now we'll have them press 4 if they just want to quit the program altogether and go watch YouTube videos. So that's the basics of what we're going to be doing. We're going to be incorporating a program with a file, and it's going to work beautifully together. But like I said, it's going to take more than one video, so just be prepared for that. So let's go ahead and start coding this baby right now. So the first thing we want to do is we want to give them a menu to choose from. Now this menu is going to be 1, 2, 3, or 4 depending on what they press. We're going to output the appropriate items. So we're going to want to store this variable, either 1, 2, 3, or 4, in a variable. So we'll just go ahead and we'll store this number in a variable named what they want. Now this will be equal to 1, 2, 3, or 4. So now what we can do is we can just take that variable, what they want, and we're going to set it equal to a function in order, to get the number from them. So we'll just name this function get what they want. Now we didn't build this function yet, and this obviously isn't a built-in function on C++, so we need to go ahead and build it right now. So what I like to do actually is whenever I'm building a big program that's going to be working with a lot of functions, above each function, well, I'll just do it with main first, I like to leave a comment, just the function name, like a main function. And you guys may be like, alright, why the heck do you want to do that? Well, if you notice, the comments are a different color, and it makes it really easy to find functions whenever you're scrolling through like 3,000 lines of code. So you guys might be like, alright, that's kind of dumb, but trust me, do it. It's going to save you a whole bunch of headaches in the future. So we're going to be building this get what they want function. So the first thing I'm going to do is get what they want function. And I probably spelled it wrong, yep, but good enough. So now, remember, this function has to return an integer that's going to be either 1, 2, 3, or 4. So our return type is going to be integer. Now the name is get what they want, so just go ahead and copy that and paste that. And it's not going to take any parameters. We don't have to give any information into it. We just want to get information back from it. So that's why it's not going to take any parameters. So now what we want to do is we need a variable to temporarily store 1, 2, 3, or 4. So we got to make an int variable, and we'll just name this choice. Name it whatever. You can name it X if you want, it really doesn't matter. So now what we want to do is we want to output their choices for them, so they know whether to enter 1, 2, 3, or 4. So just go ahead and make 4 different cout statements. We can make it all in one statement, but it'd probably look cleaner if it's just 4 different statements. So in the first one, we'll just put enter 1 for just plain items, and you probably want to put each of these on a new line. So just copy this 3 more times, copy, and we'll go ahead and write enter 2 for 2 can be, let's say, helpful items, and this will be the candy, the soda. Is that really helpful for a kid? I don't think so, but in this game it is. And 3 will be for the harmful items, and this will be like the ninja, the dirty needles, and the what else I put? Oh yeah, meth. Definitely harmful for a kid. And 4 will just be like quit program. So whenever they press 4, the program's going to quit. So now what we want to do is we want to allow them to input, of course, one of those numbers. So CIN, that's how they get information from the keyboard, and whatever number they enter, it's going to be stored in the variable choice. Now all we need to do is take that variable choice and return it in our function. So whenever we return choice, it's going to store that number in what they want. So now this get what they want function basically gets a number from the keyboard, and it stores it in a variable what they want. So now we have a variable, either 1, 2, 3, or 4, but we didn't do anything with that variable yet. And what we want to do is, since this program is going to keep running until they hit 4, we want to throw pretty much our entire program inside a while loop. And this while loop is basically going to say, okay, keep running this program until they hit the number 4. So we're going to say, alright, while that what they want variable is not equal to the number 4, keep running this program. And of course, at the end of this while loop, well, let me think. Actually, no, okay. I'll save that for later on. But basically what I'm going to be doing is this. I guess I can throw it in right now. At the end of this while loop, we want to give them another opportunity to, get what they want, to enter another number. So go ahead and copy this, and well, I guess I can show you guys what's going on right now. Basically, this program is going to run, and I didn't prototype it. Always remember to prototype your functions, ladies and gentlemen. And whenever you prototype something, just copy the header and paste it at the very top. And that way, whenever your program comes across it like it did right there, it's going to know what it is. So let me show you guys what's going on so far. Well, the very first thing that we did is we ran this program and it called up this function right here. Now, once it got that function, it pretty much took a number from them, 1, 2, 3, or 4, and stored it in the variable what they want. And we said, all right, keep calling this function and making it equal to store to what they want until they enter 4. So whenever they run this program, they're going to be able to enter 1, it's going to do something. 2, it's going to do something. 3, it's going to do something. They can enter 3 100 times if they want. But as soon as they enter 4, the while loop is going to end and the program is going to quit. Just like that. So we have the basic shell of the program right now. We basically are getting a number from them, and we're going to keep getting a number from them until they enter 4. So now, with the basic shell done, the only thing that we need to do now is whenever they enter 1, handle that 1 appropriately and show all the plain objects. Whenever they enter 2, handle that appropriately and show all the helpful items. Whenever they enter 3, show all the items that are harmful to the character. And now that we have the basic shell, we can move on to that. But we can't in this tutorial because if I do, I'm going to run out of time. So copy all this code down, make sure you know how this menu function works, and also make sure you understand how we keep looping through this function until they enter the number 4. And by the way, as soon as they enter number 4, this while loop is going to be false and it quits. And as you can see, whenever it quits, there is no more code after it, so the main function ends and our program stops. So once you guys understand that, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Alright guys, so hopefully you watched my last tutorial, number 68, and now you're watching the 69th tutorial, and in this tutorial we're going to be finishing up the program that, well, I don't know if we're going to be finishing it, but we're going to be continuing the program that we started in the last tutorial. So in the last tutorial what we did is we basically built the main functionality for our program. The only thing that we didn't do is handle the other items except for 4. So I already told you guys that what this loop does is it tests this variable what they want, and if it's equal to 1, it should print out the plain items. If it's equal to 2, it should print out the helpful items. If they enter to the number 3, then it should print out the items that are harmful to the character. So what we want to do is we want to test this what they want variable for 1, 2, or 3. Now what we can do is make a bunch of different if statements, but remember I told you guys, whenever you're testing a single variable for multiple values, it's better to use a switch statement. Now a switch statement takes one parameter, the variable, what they want, and it tests it against a bunch of different cases. So let's go ahead and finish this by, we need the curly braces right here, and inside the curly braces of the switch statement we write all those different cases. So we go ahead and we first write, in the case of 1, what do we want to do? And we're going to be wanting to display these items, and we can write all the code right here, but since we're going to be displaying the items multiple times, it's better to build a function later on. So let's go ahead and just, again, I didn't build this function yet, we're going to be building it later on, but let's go ahead and build a function called display items, and whenever we enter 1, we're going to pass in the parameter 1. Now display items, like I said, is going to be a function that takes one parameter. Depending on what parameter it takes, it knows what items to print out. So whenever we display items with the parameter 1, it's going to print out the plain items. So of course, remember we add break after every case so it doesn't go to the rest of the cases. And let me just go ahead and copy this 2 more times. So in the case of 2 and in the case of 3. So if what they want is equal to 2, then we want to display items with the parameter 2. If they enter 3, that means that they want to print out the harmful items, so we'll go ahead and write a function display items that takes the parameter 3. Now check it out. This main function is done completely. We don't have to do anything else to this main function. The only thing we have to do is build this display items function. Pretty cool, huh? So let me go ahead and come down here, and the first thing, like I said, that I like to do whenever I'm building a function is add a comment. Now I'll just go ahead and put display items function. Now this function, it's only going to print out stuff on the screen. That's its only job, to display items. So let's go ahead and make void as a return type. We're not getting any information back. It's just going to print out something. It's just going to, do the dirty work for us. So it's void. We're not asking for anything back in return. We're just asking it to do something. So now let's go ahead and write display items. And of course, remember, it needs to know what items you want. 1, 2, or 3. It basically needs to know what choice did you enter, 1, 2, or 3. So we're going to be passing it in an integer parameter, just like that. Now, well, the first thing I want to do before I continue is go ahead and prototype my function. And remember, to prototype your function one last time, go ahead and copy the header and paste it right above your main. And the reason we prototype functions one more time is because whenever we come across it right here in our main program, it knows that it's a function that we made later on right down there. Hopefully you guys watched my series before and you should know that. But anyways, let's go ahead and build this display items function. So the very first thing that we need to do is we need to have access to that file where all the items are. And remember, this is the file right here with all the items in it, and whatever this is, the effect of energy on our character or whatever. So remember, we already know how to open a file to gain access to it, and that's through an ifstream object. And by the way, before I even finish typing that, make sure you have included your fstream. This is pretty much the header file that allows you to have access to the files. So in order to read information from a file, we need to make an if stream object. And just go ahead and name your object, objects file. By the way, I named this file objects, so that's why I'm naming this objects file. And of course, we can put this on 2 different lines, but it takes the optional constructor of what file do you want to associate this object to. And we want to associate this object with a objects.text file. That's the text file that I just showed you guys. Now after this, we need to make 2 variables. The first variable is going to store the name of the object, and the second variable is going to store, the power or the energy, whatever you want to call this thing. I'll call it power. So the first variable is going to be a string variable, and it's going to store the name of the object. The next variable is going to be a double variable, and this is going to store the power of the object. So now what we can do is, the first thing we want to test is what choice did they enter. So we're going to be making a bunch of different if statements. We can make a switch statement, but I think if will look a little bit neater. So we'll say, alright, if the choice they entered, which is X, is equal to 1, then check it out. That means that they want to display the plain items. In other words, they want to display the items that has 0 effect on our character. So if the choice they entered is equal to 1, what do we want to do? Well, we want to go ahead and first, here's what we're going to do. We're going to loop through each object. We're going to loop through this one, then this one, then this one, then this one. Each time we loop through, we're going to want to check if the power is equal to 0. If the power is equal to 0, then we're going to want to go ahead and print it out. So it's going to say, alright, loop through this one, print it out. Loop through this one, don't print it out, don't print it out, print it out, print it out, So that's what it's basically going to do. So the first thing we need to do is loop through each object. And in order to do that, if you remember from, let's see, I want to say 2 tutorials ago, we can just go ahead and make a while loop. And in this while loop, just go ahead and write, come on, there we go. I was waiting for it to pop up. Go ahead and write your object file, and then go ahead and we're going to store the first thing in name, and we're going to store the second thing in power. And this is going to loop through as long as your file is open. So it's going to say, alright, loop through the first thing, store it in name, and store it in power. So now what we want to do is we want to check, alright, whenever you loop through an item and the power is equal to, I'll just go ahead, I don't want to add that space. If the power is equal to 0, then go ahead and print it out. So cout name of the object and then we'll just go ahead and add a little space, and then the power, and then we'll go ahead and end that line. So basically we're going to be looping through this whole file. Whenever it gets to an item where the power is equal to 0, print it out on the screen. Now let's go ahead and copy this 2 more times, and we'll say alright. Remember, X is the choice that they entered. So if they entered the choice of number 2, then they want to print out the helpful items, just like that. So whenever they want to print out the helpful items, we know that the power must be greater than 0, because remember, a helpful item is like a candy or a soda, where the power is greater than 0. So what this is going to do is, whenever they enter the choice 2, print out the items that have a power greater than 0. And whenever they enter the choice 3, print out the items that have power of less than 0. And these items are, you know, a ninja, meth, and a dirty needle. All those items that are harmful items have a power of less than 0. Right like that. So basically, our program is complete. This is ready to run. And I know you guys are just itching for me to press this build and run button and see this program go to work, but I'm actually going to be doing that in the next tutorial, because first I want you guys to watch one of my other videos, kind of sucker you into that one, and also I'm going to be showing you guys that it does indeed run perfectly. Actually, in between these videos, I'm going to check for errors and make sure I didn't mess up anything. And I'm also going to be talking through you guys one more time to clear up any, confusing things that, or any questions that you guys might have. So thank you guys for watching. I cannot wait to press this button. So I guess you guys are going to have to see me press it in the next tutorial. So thank you guys. Don't forget to subscribe, and I'll see you guys next tutorial. Alright guys, welcome back to your 70th tutorial, and this tutorial really isn't a tutorial at all. We're just going to be running the program that we built in the last 2 tutorials, and I actually did check for errors in the last video, and this program is built perfectly. Who would have guessed? And so it's ready to run. So let me go ahead and press this build and run, and I'll show you guys how it works. So the very first thing it does is pop up a menu, and it gives us a choice. Press 1 to print out plain items, 2 for helpful items, press 3 to print out harmful items, and whenever you want to quit the program, press 4. So let's go ahead and print out 1, and this is going to print out the items that have no effect on our character. So press 1, go ahead and hit enter, and it's going to print out chair, a shoe, and a pencil, all with 0 effect on our character. So now let's go ahead and let's skip down to 3 or something. Hit 3, enter, and it's going to print out ninja, meth, and a dirty needle. So now let's go ahead and print 2, and whenever we hit 2 to print out the helpful items, it's going to print out fruit, candy, and soda. And now let's go ahead and press 4 to quit the program, and our program is going to end with an execution time of 49 seconds. How awesome is that? So one thing that I want to do, because it's just going to annoy me, is I want to add a new line right there and right there. So now whenever you run the program, it's going to, it just makes everything not bunched up into one line. So if you go ahead and hit 2, you can see that, it makes it a little bit better. So again, there's a lot of different formatting things that we can do, but, I just want to make sure it wasn't bunched together. So 2 prints out all the helpful items. If I go ahead and, hit 3, it'll print out all the harmful items, yada, yada, yada. So basically, I wanted to show you guys that this program does indeed work. I wasn't BSing you. And this is how you can build a program that works awesomely with a file, in this case, the object file, or the objects.txt file. So let me talk you through how this program works one last time. The very first thing I want to mention is, whenever you're building a program that takes a bunch of different functions, make sure to prototype your functions first and foremost. If you don't prototype your functions like this and try to run it, you're going to get an error message, because it's going to come across this function and it's not going to understand what it means. So that's why you need to prototype your function. So once you have your functions prototyped, let me run this, get that error message out of the way. Now that you have your function prototype, I'll tell you guys how this program works. The very first thing we wanted to do was display a menu to the user, and we wanted them to enter a number 1, 2, 3, or 4 depending on their menu choice. So what we did is we built a function to display that menu named getWhatTheyWant, and we took whatever they entered and we stored it in a variable called choice. And what this function did is it returned that variable choice, so it basically stored that number, either 1, 2, 3, or 4, in the variable what they want, because this number tells us what they want. So after that, we took that number and we first made sure it wasn't equal to 4 because remember 4 means they want to quit the program. So whenever they entered 4, this while loop ended and the program quit. So what this while loop did is said, alright, if they enter any number besides 4, go ahead and run this code right here because that means that they want something. If they enter 1, it means they want plain items, 2 helpful items, 3 harmful items. So I said, alright, test this variable if they entered 1, 2, or 3. If they entered 1, call this function in display items with the parameter 1. If they entered 2, it means they want helpful items, so we're going to call display helpful items. And if they entered 3, we're going to pass in 3 on this display items function. So you're saying, alright, so the display item function obviously displays the proper items to them. So say we passed it the variable 2. Well, it calls the display items function with the parameter 2. It basically scrolls down here and calls display items. Now remember, display items, it just prints out something on the screen. It doesn't give us any integers or strings back, so we made that void. Now whenever we passed in 1, 2, or 3, it treated that variable as x. So x was pretty much your choice, 1, 2, or 3. So the very first thing that we did in this function is we opened that file because, all the crap that we needed was inside this file. So we opened that file and then we made 2 variables. We made a name variable to store the name of the object, and we made a power variable to store how much power that object had, whether it's 0, negative, or positive. We then tested what choice they wanted. Remember, if x, which is now the choice, is equal to 1, then it means they want to display the items with no power, the plain items. Whenever they entered the number 2, it means they wanted to display the helpful items, and helpful items just had a power greater than 0, so that's why we printed out the objects with a power greater than 0. Whenever they entered the number 3, it means they wanted to display the harmful items, the items that hurt our character. So we said, alright, we're going to test this power variable, and any object with a power variable that's less than 0, go ahead and print it out. So that is how our program works, and here's what I'm going to ask one of you guys to do. You guys probably want all the source code for this, so actually what I'm going to do is I'm going to go ahead and copy this and post it in my forum under the C++ section. So if you guys want, just go ahead and sign up. Actually, you don't even need to sign up for my forum, but I would prefer you did. Sign up for my forum, go look in the C++ section, and I'll post all the source code here. So if you guys, are getting an error in your program whenever you're working along, you can just go ahead and copy my source code, and it's all there for you guys. So thank you guys for watching so much. Hopefully you understand how this program works. If you don't understand, then don't flip out. All you need to do is go ahead, look at the source code, and once you see it all together, you guys can understand how it's all pieced together. So again, one last time, this is how you build a program that works perfectly with a file just like this. And with that being said, I want to say this. In this tutorial I showed you guys how to have the user, input a number and print out all the helpful items or harmful items. But whenever you're developing a game, instead of just printing it out on the screen, you would want, whenever your user comes across a helpful item to, make them get that much energy, or whenever your character comes across a harmful item, have them, take that much energy away from your character. Or whenever your character comes across an item like a building or a chair or a shoe, it has no effect on the character. So aside from printing it out, we would do something different in this line of code right here. But that's basically your very first glance at how games and programs work with files in a useful program. So I'm glad I could teach this tutorial, finally make a program that's useful instead of teaching guys just the core concepts. I know a lot of you guys were complaining that I was just teaching you the concepts and you guys never really got to see how a program was put together. So hopefully here's a nice little look at how it works. So thank you guys for watching one last time. Thank you guys so much for subscribing, and I'm excited to move on to the next topic. So hopefully we're done working with files, at least for now. So thank you guys for watching, and I'll see you guys in the next video. What is going on, guys? Welcome to your, let's see, 71st C++ tutorial, and in these next, I want to say 3 or 4 tutorials, I'm going to be covering more about strings. Now, I know that I touched a little bit about strings, and we've actually been using strings this whole series, but I want to talk to you guys specifically about the string class. Now, the cool thing about these next couple tutorials is there aren't a lot of confusing concepts that you guys need to understand, but the string class gives us a bunch of functions that, well, let me tell you guys this. Whenever you're building a program and you don't know how to do something, that you usually want to look it up in the documentation, and if there's, an advanced function in order to do something, it'll tell you how to do it. But some functions, like how to print stuff out on the screen, are essential to have in your memory. And a lot of those functions that are essential to have in your memory are a lot of the string functions. So this is stuff that whenever you're programming, you shouldn't have to look up. So in these next couple tutorials, I'm going to be teaching you guys the core string functions. So the good thing is they aren't confusing. They take like a minute each to learn. The sucky thing is that we do, in fact, need to learn these because if you don't know them, if you do know them, it's just going to make programming a whole lot easier. So the first thing I want to clear up is probably something I should have touched on a long time ago, and that's also something that kind of confuses you guys whenever I was working with files. You guys didn't really understand that whenever I came to, a white space, that whenever I was like reading data in from a file, then it automatically quit reading it in. And let me explain to you guys what I'm talking about. Say, whoa, easy caps locks. Hold on, got a cough. Oh, there we go. Got some milkshake from McDonald's in my throat. So say we have a string called Bucky, and we want to, fill in the string with the user's data. Whatever the user enters from the keyboard, we want to store in this variable called Bucky. So we use the CIN, and whatever they enter is going to be stored in a variable called Bucky. So now we'll go ahead and just print out something on the screen like the string I entered is, and then we'll make a little space right there, and then we'll just go ahead and write the variable name, which was Bucky, and end that line. Well, let's go ahead and run this program, and I want to clear up a couple things. So now we see a blank cursor telling us to input something, and we already know that if we input something like tuna, it says the string I entered is tuna. We understand that much. But what I didn't tell you guys, and I probably should have told you guys this in like the 10th tutorial, but better late than never, is whenever you enter something like tuna sandwiches are good, and you say, alright, well that's my string of text, and you press enter, it only says, the string I entered is tuna. And that brings me to a point that I should have covered in either the 10th tutorial or in the last tutorial when I was teaching you guys how data is read in from a file. Whenever you're using CIN to read data in, whether it's from the keyboard, the user, or a file, when you're using CIN, the end of the input is determined by the first white space character it comes across. So for example, whenever you run this program and you see tuna sandwiches, it doesn't read that whole tuna sandwiches. It reads it until it gets to its first white space. So that's why in the last tutorial, whenever we came across, a new line character or a white space, that's when it stopped and that's when it finished reading in the data. So hopefully you guys understand CIN only reads one small piece of data at a time. So now that you guys understand that concept, let me talk to you guys about another concept, and that is, well, what happens when you do want to read an entire line as one string? Well, say we go ahead and let's name our string something else besides Bucky. Let's name it string X. Whenever you want to read an entire line of data, here's what you do. You go ahead and write the function getLine, and go ahead and write CIN, and just go ahead and write X. And now let's just go ahead and print this out on the screen real quick. End line. And now what getLine does is, instead of the end of input being determined by a white space character like a space, the end of the input is determined by a new line character. So getLine is going to wait till we have a new line. In other words, when we're working with CIN, which means input from the keyboard, it's going to wait until we press enter, or basically when we're done typing text on the line. So now when we put tuna sandwiches are good and press enter, it's going to output tuna sandwiches are good, and this entire thing is the string that's going to be stored in X. So again, what I want to stress is whenever you're working explicitly with CIN, it reads one small piece of data. Whenever you want to read an entire line, you want to use getLine. Sorry, I still got that milkshake stuck in my throat. So that is the difference between CIN and getLine, and how the end of the input is determined by a white space or a new line character. So that's not only going to help you a lot when getting information from the user, but also whenever you're working with files, that's how it read the information. I probably should have told you guys that before, but hey, like I said, better late than never. Never. There you go. Okay, let's slow down for a second, Bucky, and gather your thoughts. And all right, I'm good to go now. So now I want to talk to you guys about additional ways to create and copy strings. So aside from having, string Bucky equals yada yada, oops, yada yada yada, and while this is valid and this is the way we created strings before, I want to tell you guys about an additional way to create strings from the string class. Say we want to create a string named S1. We can go ahead and pass it in a constructor of a string like hamster, just like that. And now hamster is going to be equal to S1. Again, like I said, just two different ways of doing the same thing. But why do we need to know this? Because whenever we're working at a company and someone creates a string this way, we don't, think it's something totally different or some class that they made up. We know that, don't freak out. It's just the same way of creating a string. So if we want to create a blank string, we can do something like this. And let me go ahead and create another blank string because I'm going to be showing you guys an example later on. So anytime you want to copy a string, you can do so in one of two ways. The first way, which you guys probably could guess, is you can set string 2 equal to string 1, which is hamster. Now this is a valid way of copying a string, but some people also want to use a function from the string class, and that's called assign. Now assign isn't really a good word. They probably should have just named it copy, but it does the exact same thing. In that, say you want to have S3 and you want to have this, actually, we have it right there. It already pops up for us. Assign string 1. These two, with the exception of being string 2 and string 3, these do the identical thing. Each of these functions copy this string to this variable right here. So again, just to prove it to you guys, let me just print out all these on the screen. We'll print out S1, S2, and S3, and just go ahead and end that line. And whenever we print it out, we can see that all these things, hamster, 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 do the exact same thing. So again, what this line of code does is it's just an additional way where we can go through the string class and we can create a string using the constructor. And what this does right here, this assign, is basically an alternative to copying strings. So with that being said, I want to talk about one last thing, and hey, I guess I can. Okay, the last thing I want to talk about in this tutorial, and I'm probably going to go over 10 minutes, and I hate making videos over 10 minutes, but I'll do it, is strings are arrays of characters. They're not like arrays of characters, and they're not similar to arrays of characters. Strings are indeed arrays of characters. So let me go ahead and make a string called S1, and I'll set it equal to OMG WTF barbecue. Good enough. So now I want to stress that anything you can do to an array, you can do to a string. So let's go ahead and see out something like S1, and say we wanted to output one of these characters, and these characters are elements in the string 0, 1, 2, 3. So this W is S1, 3. Well, in addition to having the explicit index, the string class also has an at method to say, alright, if we put 3 right there, it's going to look in the third element in the array, and it's going to find what character is at that location. So it's a little easier to tell to someone who's like just learning programming. Using the at function is a little easier to see than using the array indexes right there. So let's just go ahead and end that line and print it out, and whenever we print it out, we can see that we indeed get a W. So the point of this lesson is I want to stress to you guys that strings are arrays of characters. And one other cool thing I might as well teach you guys while I have the time is, just like an array where we can loop through it and print out each one of its indexes, we can also loop through a string. So let me go ahead and put int x equals 0, and in order to get the length of a string, it has built-in length function. So we'll put x is less than, what's my string name? S1 dot length with no parameters, and we'll just loop through them one at a time using x++. So now what we need to do is just print out on the screen s1.at, and as a parameter we can just go ahead and type in x, because what x is going to do is it's going to say, alright, it's going to start at 0, remember this is the 0th element in the array, and it's going to count the length of the string, and it's going to loop basically from the beginning till the end. And the x is going to go 0, 1, 2, 3, 4, all the way until it reaches this last element. So that way, whenever we pass x into the parameter for at, instead of printing just one character, it's going to print the entire string. So let's go ahead and build and run this, and check it out. Here's what we printed from before, from the last lesson, and now here's the entire string getting printed out. OMG, WTF, barbecue. So those are some simple string functions. Like I said before, none of these are gonna, twist your brain like polymorphism or maybe working with files are, but there's some core functions that we need to learn, especially the at, the length. Those are two string functions that you're gonna see a lot whenever you're working for a company. Hopefully you're watching this tutorials in the hopes of getting a job, or at least working with other people on a game project or something like that. You're going to see these functions a lot, so you need to know what they are, how they work, and also some additional ways of creating and copying strings. So now that you understand these concepts, hopefully you memorize them, embedded them in your brain. I want to tell you guys that there are a lot of different things that the string class has to offer aside from finding the length of a string. So we're going to be covering all those core string concepts in the next couple tutorials. So have no fear, no really confusing topics for now. And I want to tell you guys that you're almost to the end of learning beginning C++. We probably only got like 20 more videos to go. So with that looking forward to, I want to say guys, thank you for subscribing, thank you for watching my videos, and I will see you guys in the next video. Alright guys, welcome to your 72nd, wow, we've come a long way, C++ tutorial, and in this tutorial, I'm going to be talking to you guys about some more very useful string functions. So the very first string function I want to talk to you guys about is called the substring function. Now what the substring function does is it takes a big string and it creates a substring out of a small piece of it. So let me go ahead and show you guys an example. It's going to be a lot easier just to show you an example rather than trying to explain it. So go ahead and make a string. I'm probably going to call all my strings S1 in this tutorial, and just go ahead and write something like OMG, I think I am preggy or something stupid like that. I don't know. Create any string you want, and go ahead and print out s1.substr. This is a substring function, and go ahead and end that line, end L. Now the substring function takes two parameters. The first parameter it takes is the beginning index, or the beginning character. Remember, strings are arrays, pretty much an array of characters, so this is 0, 1, 2, 3, 4, so on and so forth. So let me go ahead and put the beginning character, which is 17, and the next parameter it takes is how many characters do you want to go on for. So if we put 1, 5, it would start at 1 and it would go 5 characters in. So let's go ahead and put 17, 7, go ahead and run this, and we get the word preggy with an exclamation point. 1, 2, 3, 4, 5, 6, 7. Actually, 0, 1, 2, 3, 4, 5, 6, 7. I don't know. It's one or the other. But anyways, the substring method is basically what character do you want to begin in, and this is the 17th character, and if we count 7 characters, 1, 2, 3, 4, 5, 6, 7, that is how many characters is included in the substring. So basically, the substring function is how to create a smaller string from a bigger string. Definitely useful whenever you want to create a smaller string from a bigger string. Now after this, I want to teach you guys about another function, and that's called the swap function. Now might be, if you're working a lot with sorting lists or how to sort arrays, you're going to be using this function a ton. What it basically does is it takes one string and swaps it with another string. So let's go ahead and put string 1, and we'll make this one, make it something that begins with A, like apples. And we'll put string 2, and what this one does is we'll make this one like beans. Good enough. And what we can do first is just print out the strings to verify that they are indeed working correctly. So 1, and then it'll print out 2, and we'll go ahead and end that line. So what this line is going to print out apples, beans, and I'll add a space after this. And now what we can do is I want to show you guys what the swap function is and how it works. The first thing you need is a string to apply it to, and I'm going to apply it to string 1. Now go ahead and call swap on this. Now it always needs to take a parameter, and that's what string do you want to swap with it, and we want to swap string 2 with it. So we're basically saying, alright, swap beans with apples, and now string 1 contains beans, and string 2 contains apples. So if you go ahead and print this out again, let me just go ahead and copy it and print it out again and build and run it. The original strings were apples and beans, but now it took the contents or values of them and flip-flopped them. So now string 1 contains beans and string 2 contains apples. Again, this is very useful whenever you're sorting. Usually you're going to run through a huge while loop and you're going to be like, alright, if this value is greater than this value, then swap them. If not, leave them the same. And by the time you get to the end of the loop, everything's in a nice, neat order. So that's your basics of how to sort things. But again, let's go ahead and delete this. And again, one last time, none of these things are really confusing, but they're definite functions that we need to know. That's why I'm going to be covering this explicitly, because these are functions that you shouldn't have to look up in a resource or reference guide. These should be functions that should be stuck in your brain. So the last function I want to cover in this tutorial is the find function. Now, like I said, I want to repeat this one last time. Strings are just arrays of characters. So whenever we're finding a substring, what it's going to do is it's going to give us the location, or in other words, the index of where in the string that is. So let me go ahead and make a string. Again, most of these, it's going to be a lot easier just to see an example. So let me go ahead and make something like ham is spam, oh yes I am. And I actually made that string for a very specific reason, which you'll see later on. So go ahead and see out s1.find am. And now, let me go ahead and end that line. And you're saying, alright, so I kind of know what this is going to do already. It's going to go and look through your string and find where am is. But check it out. We have this one right here, and this one right here, and this one right here. So let's go ahead and build and run this and see what one it returns. And I forgot to do something and add a less than sign right there. So let's go ahead and build and run this again, and it's going to say 1. So you're saying, alright, so obviously it gave me the location of this first one right here, because this is the 0th index of this array, and this is 1. So what it basically does is it gives you the starting location of the first found AM, I guess that's all I need to say. The first found occurrence, that's the word I was looking for. So even though there are 3 occurrences in this string, it's going to loop through it and it's only going to return to you the first occurrence of this. So remember that whenever you're using find, it doesn't give you 1 and 10 and 19 or whatever the heck these are. So we're saying, alright, well, what if I want the occurrence of the last AM? Well, there's another function for that, and that's called rfind. This stands for reverse find. You know how whenever you're finding, a substring such as am in a bigger string, it's going to start at the beginning and it's going to work left to right. Well, what reverse find does is it works right to left, just like that, and it's going to go right to left, and it's going to look for am. So it's basically going to give you the last occurrence of am, which let's go ahead and print this out, and that is 21. So if we can see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21, right like that. As you can see, this 21st index, in other words, this one right here, is the first location of the last AM. So that's the difference between find and rfind. One works left to right, and one works right to left. So there are some more string functions right there. Again, these string functions are functions that you should not have to look up. These are some functions that should be embedded in your programming brain. So that's why I want to give them to you guys, and hopefully me showing you an example of how they work help, make them stick in your brain a little bit easier. So thank you guys for watching these tutorials. We only have a few more string functions to cover, but don't skip over these tutorials because later on when I'm developing games and showing you guys how to work with 3D and cool stuff like that, I'm not going to be taking time to stop and pause and cover these functions. So if you decide to skip these next tutorials and just go straight to game development or whatever, you're going to be crap out of luck. So there you go. Thank you guys for watching. Don't forget to subscribe and don't forget to check out all my other videos. And yeah, I guess I'll see you guys later. What's up, guys? Welcome to your 73rd C++ tutorial, and in this tutorial you will be happy to know we are covering the last string functions. So after this tutorial, no more string functions for a while, so I bet you guys are glad about that. So the first thing I'm going to be covering is the string erase function. Now what this function does, it erases everything from and including whatever element you tell it to. So let's go ahead and I'm just going to make a string called string1, and I'll write something like, hi, my name is Bucky, and I love bacon and ham. Something stupid like that. And why not an exclamation point, spice things up a bit. So let's go ahead and first just print this out on the screen so we have something to compare it to after we change it later on. So now what I want to do is, let's say I want to erase, I want to erase everything from the 20th character on. So it's going to be like somewhere around here. And say this is the 20th character right here. I want to erase everything from here till the end of the string. Well, we need to use something called the erase function, and it's probably already in there, right there, erase, and it takes one parameter. What character do you want to begin erasing it? And remember, it includes the 20th character as well, so it doesn't start at 21. It actually erases the 20th character as well. So now let's go ahead and print out the new and improved erased string, and we'll go ahead and run it and see what it looks like. So the original string is, hi, my name is Bucky and I love bacon and ham, and the new string is, hi, my name is Bucky, and it erased everything from here on out. So that's all the erase function does. So now, aside from the erase function, I guess we can go ahead and keep this and this and this. The only line of code that's going to change in this tutorial is this. So now that we know what the erase function does, I want to talk to you guys about another function, and that's the replace function. So press S1, replace. This function's already filling in for me. Alright, the replace function takes 3 parameters. The first parameter it takes is, what character do you want to begin replacing it? And Bucky, I already know, is the 14th character, since this was the 20th character right here. So this B is the 14th index. The next parameter, so let's go ahead and put 14 in there right now before I forget. The next parameter it takes is, how many characters do you want to replace? So let's count. 1, 2, 3, 4, 5. Bucky is 5 characters long, so if we want to erase this entire thing, or in other words replace it, we're going to start at the 14th character and replace 5 characters. So that's going to replace the entire word Bucky. So the third parameter it takes is, what do you want to replace it with? So now that we have Bucky replaced, I think it would be only appropriate to, add a new name, like, I was just going to add it right there. That'd be way too easy. Like, Samuel Jackson. And I spelled that wrong, but it doesn't really matter. So you don't have to replace it with the same number of characters. You're pretty much saying, alright, what do you want to replace? And what do you want to replace it with? So if we go ahead and run this, we can see that the original string was, hi, my name is Bucky and I love bacon and ham. And now the new string took Bucky out and added Samuel Jackson, so it says, hi, my name is Samuel Jackson, I love bacon and ham. And he probably does. So what replace does is basically takes a certain bit out of the string and replaces it with something else. Easy enough. So now I want to talk to you guys about one last string function, and that's insert. Now what insert does is it inserts a substring into the string, but it doesn't take anything out like it did Bucky before. So if we wanted to change the string to, hi, my name is Lucky Bucky and I love bacon and ham, we don't want to take anything out, we just want to insert something right after is. So what we do is put S1, that's the string we're working with. The function is called insert, right like that, and it takes 2 parameters. The first parameter it takes is, where do you want to begin inserting it? Well, we already know 14 is the beginning of Bucky, and the next parameter it takes is what string do you want to put right there? What substring do you want to add into the main string? And just go ahead and press Lucky, and we'll add a space after Lucky, so it would be Lucky space Bucky. If we didn't add this space, it would be like Lucky Bucky, one big word, but my name is Lucky Bucky. So I'm going to begin at index number 4, and I want to insert the word Lucky with a space after it. So don't forget your semicolon, and whenever you run this, you can see the original string, hi, my name is Bucky, and now we inserted Lucky, so the new string is hi, my name is Lucky Bucky, and I love bacon and ham. So that is how you insert words, into a string. And one other thing I forgot to mention, let's see if I can go ahead and ZZ replace, just like that. Usually people use replace whenever they usually use it in conjunction with find. So remember in the last tutorial I told you about find, how you can find like all the AMs in a string. I think that was the example I showed you guys. People typically loop through your entire document and find all instances of something and use this replace function to replace it with this. For example, here's a great example. If you ever use Microsoft Word and it saw that you did your whole homework assignment and you saw you spelled the word dictionary with a K and you typed it like 18 times. Well, whenever you right click it and spell check it, it says replace all. This is how they made it. It just loops through, finds all the time you type dictionary with the word K, and replaces it with the proper spelling of dictionary, which of course doesn't have a K in it. So if you're ever wondering how Microsoft coded that find and replace, these are the methods they use to do it. So if you think, Microsoft is a bunch of genius programmers and they program in ways that you can never even learn, well, that's one of the techniques we already learned, that we just, learn the concept of it instead of applying it in a main program. But all they did is they used find, they looped through your entire document, found all the instances, and each time they found it, they called this replace and replaced it with a proper string. So there you go. There's a nice little example of when this would be useful in real life. So with that being said, that's all the well, I don't want to say that's all the string functions. There are probably like 200 string functions, but those are all the main ones that I want to cover. Now that we covered all the main string functions, whenever you're programming games and documents and applications later on, and we come across a string function, we don't have to look up what it means. Again, there are a bunch of different other string functions, but these are the main ones that you're going to come across in your programming. So that being said, take a deep breath, and we only got a couple more topics to cover. So I am ready for it, and to be honest, I'm getting kind of tired of learning C++. I'm ready to move on to game development with C++ and 3D modeling with C++ and the fun stuff. But hey, we got to cover the boring stuff before we get to the fun stuff. Those are the rules of life. So thank you guys so much for watching. Thank you guys for sticking with me for, what was it, like 73 tutorials already? I had super fun. I'm just going to quit talking right now before I mess up anything else. But anyways, thank you guys for watching, and I'll see you guys in the next video.